What up, y'all, and welcome to the re-up. This is the next 50 exercises that I've compiled. I had another edition, another compilation of 0 through 49. This is 50 through 99, so the next 50 of my coding exercise videos. And I really like doing coding exercises. I think it's a great way to practice algorithmic programming, just to keep yourself sharp. A lot of these exercises are they're on the easier side, but it's really just about staying consistent, staying on the grind, and staying in the game. That's how you get better as a coder. I had a lot of fun doing these, and I think you'll have a lot of fun checking them out and going through the different principles and algorithms you use to solve them. So without further ado, check it out. Yeah, I'm back. I'm back with another breakdown, and today it's going to be how many unique consonants from Code Wars. This is C++, a little bit different than what I've been doing lately. Been doing more Python, but got to go back to the source, back to an older language, back to a more, I guess you could say, standard language. Even though Python is super popular, got to shake it up and do some C++. Complete the function that counts the number of unique consonants in a string made up of printable ASCII characters. Consonants are letters used in English other than A, E, I, O, U. Of course, these are vowels. Consonants are not vowels, so non-vowels. Your function needs to return the number of unique consonants, disregarding duplicates. If the string passed to the function reads add, the function should return 1 because there's only one unique consonant. 2 D's equals 1 unique consonant. Double D is 1 unique consonant because it's duplicated. And the next paragraph also says that you look at dad. Dad has an uppercase D and lowercase d. It's going to return 1 because the uppercase D and lowercase d both count as D's. So I guess you could say this is case insensitive, where the case doesn't matter, they're counted as the same letter. Looking at the examples down below, we already went over add and dad. These are all vowels, so there's no consonants. Silly string has 7 unique consonants. You look at the alphabet itself, it has 21 unique consonants. Did not know that. And so on and so forth. So yes, going to create a function to count the unique consonants in an incoming string. C++, remember? And you look at line 3 here, the return type is an unsigned integer, and the parameter is a constant string, or a string reference. Constant string reference, actually. I'm not even reading this damn thing right. All right, let's get into here. So to start this one up, we're going to count the number of unique consonants. What the hell is a consonant? You got to tell your code what a consonant is, and you can tell your code what a consonant is by telling it what it is not. Well, yeah, what a consonant is not is a vowel. So I'm going to create a set of vowels and use that kind of as a contrast and say, if this letter is not a vowel, it is a consonant, because there's only 2 kinds, vowels and consonants. So I'm going to create a string of vowels. Our good old A, E, I, O, U. Look, I'm playing Wheel of Fortune or something here. And I'm also going to create a string to hold each unique consonant that I find in my incoming string. So for my incoming string str, I'm going to loop through it And as I loop through it, I'm going to record the unique consonants in a string so that I know what I've seen, so I do not duplicate. Because the idea is to find unique consonants. Aha. Getting back in here. Yep, ASON unique, and this one's going to be empty because I'm going to populate it with unique consonants as I find them. And I'm going to loop through my original or incoming string. And I'm going to use the size t data type, which is an unsigned integer, an integer that cannot be negative. Typically, this is going to be used for looping in C++. And less than str.length. I have a slight amount of trouble remembering some C++ syntax. I haven't used it in a while, but it's the thing when you go between languages, it happens. Okay, gonna loop through and access each character. And for each character, I'm gonna determine that number one, it's a unique, number one, it's a consonant. Number two, it is a unique consonant. So gotta determine that it's a consonant first, then is it a unique consonant? I almost feel like I'm saying continent. So to determine if this letter or this character is a consonant, to determine if it's a consonant, I'm going to compare it to the set of vowels. If it is not a vowel, then it is a consonant. And how am I going to do that in C++? I'm going to use the find function. I'm going to look for the character in the set of vowels. If this character is not in the set of vowels, it is a consonant. So I'm going to do vowels.find, and as I pass the letter to find, I'm going to lowercase it because my vowels are lowercase, so I need to compare it to the vowels. My parentheses are going to be weird, an issue. Okay. I'm going to do a complicated expression here because I'm going to determine several things in this if statement. I'm going to determine that it's a consonant and that it's unique and that it's a letter. So I'm going to do all three of those things in this if statement. So I'm going to use the logical operator and. I'm going to say if it's a consonant and it's unique, I haven't found it yet, and it's a letter. So all that. Not sure if I need to do all that, but I'm doing it. I think I do need to do it. And this is not done anyway, so I've got to complete this find because I've got to say if the find does not turn anything up, and how you say it doesn't turn anything up is this in pause. Because if the find function does not return what you're looking for, it'll return this value, which means it did not find it. It's in pause. I don't know how to say it. Not that well versed in C++ documentation, but I know what it is when I see it. And that's good enough, folks. Take that to the bank. Take that ish to the bank. Okay, chatting it up today. All right. So what I'm going to do next is I'm going to determine if I've seen this character before, if it is unique. So if I haven't found this character before, then I can count it. So I'm going to look in this string, the unique string. Is it in here already or is it not? All right, and I'm going to use the same value, the standard string pause, in pause actually. In pause, we ain't talking about no cats. Yeah, this ends up being a long statement, somewhat. So yes, this unique find is, I'm looking for it. Have I seen it already? Have I not? A final and to ensure that it is a letter. Perhaps I should look for it being a letter first, but I already know that this works out, so I'll leave it as is. Is it a letter? Who effing knows? Alright, after all that, good God. Need some curly braces. If it passes all of those tests, I'm going to concatenate it to the unique string, the string that was created on line 7. And it's 2 lower. And this other one should be 2 lower as well. I think I'm using Python function there. The unique string is going to contain all of the unique letters, and this function is asking to return, or this problem is asking to return the count of those. To get the count of the items in the string, you just return the length. That will give me the count. Alright, I'm wondering if the parentheses are good with all this madness in that if statement. Let's see. No member named lower. I thought so. Yep, 2 lower. My goodness. Surprised those parentheses were tight. Oh well. Okay. Yeah, pretty damn hard to see this code, but pretty damn hard to close this thing. Okay. Well, I guess I explained it pretty well, but let's grab this code, store it in the online GDB. How about that? Yes, I'm back. Well, this may not be any better today. The type is so looking at what is between large. A Python exercise from codewars.com. Yeah, a little short and sweet here. This is a lower level one, the 8th level. Complete the function that takes 2 integers. Rewind for the explanation. Where a is less than check if it's and return. Is it a list of all integers between? Have I already seen it? Parameters including them. And is it a letter? So we're going to get 2 integers. A will be less. Join them with an and. You're good. We need to return the range. Basically, that's really enough gabbing for now. Consecutive numbers in between, solved, and I'm out of here. A and B, including them. Flip. It's a pretty easy exercise, and this really summons up some basic Python syntactic functionality, whatever that means. Long story short, you're going to use the range function and you're going to turn it into a list. Actually, do you even need to turn it into a list? Let's see here. But for those Python coders out there, you may recall that range is a function that produces a sequence of numbers, typically a consecutive sequence, so you can totally use that in this scenario. So I can do a one-liner where, so it says return an array of, I guess I've got to use a list. So I'm going to use the list function, and then I'm going to call range, and yeah, getting back to the range function, produces a consecutive sequence, and I'm going to start at A and end at B, but I'm going to go +1 because the end must be inclusive, and typically in range in Python, the end is not inclusive. So I want to include B, so I go B +1, so that will include B. This will be A to B inclusive. So let's see what we get here. That should be it. That's good, and that's good. All right. I want to see if I can just take off the list function. And by the way, what this list function is, it is a conversion function. I'm converting from range object to list. I think I need to do that, but let's see. No, I do need to do that. Alrighty. There we go, there we go. Alright, kiddies, well, there's your solution. Short and sweet, like I said. This is a lower level one, but just a little slight test of the extreme fundamentals. Hey, they're the fundamentals for a reason. So that's it. This one's good. It works. That's all I got for you. So until next time, I'm going to see y'all later. Okay. Once again, back again, and this time I'm back with an exercise that I just did called What is Between from Code Wars, and this time I'm doing it in Java. So I want to flex those adaptability muscles and just do it in a different language. This is a fairly simple one, and I'll get into what it is. Complete the function that takes two integers, a and b, where a is less than b, and return an array of all integers between the input parameters, including them. So this will be inclusive. Looking at the example down here, a is 1, b is 4. The task is to return an array that has consecutively the range of 1 through 4, and it is inclusive, including 1 and 4. Yeah, very good, very good. And yeah, doing this in Java instead of Python this time, a little more, not that it's difficult, but there's just more code involved, as you would guess. So going over here to the training interface, let's get started. So yeah, the idea is I'm going to get two integers, a and b, and the task is going to be to return an array that consists of all the numbers between a and b, including a and b. And we see up top in the header here that the return type is an integer array. So I will produce one that contains the range of a to b, from a to b, if you will. So I'm returning an array. Seems like step one. Let's create that array that we're going to return. And I will call the array range. And get my square brackets to indicate an array. And of course, when you create an array, you must initialize it to a size. What size is this array going to be? That's the big question. Well, it's going to be the size from A to B, the difference basically. It's like, if you look here, if I'm going to craft an array to hold 1 through 4, I've got to get the difference from 1 to 4 and then add 1, because that's really going to be the formula. It's going to be, you can say, the difference from 1 to 4 plus 1. Let's look at it here. The difference from 1 to 4 is 3. 4 minus 1 is 3. Of course, 3 isn't enough to hold all of these numbers because there's 4 of them. So you do the difference plus 1. It'll be 4 minus 1 plus 1, which will give you 4. That's going to be the formula. So I'm going to employ this in code. It will be B minus A. That gives you the difference plus 1. For inclusivity, we've got to have the full amount. So there we go. We've got our array initialized to the correct size. Now we're going to generate our range and put it into the array that we just created. I'm going to do this I'm going to do this range generation in a while loop because I don't know of a way to generate a range in Java automatically. There probably is, I just don't know it. So I'm going to do the manual way. And in creating a while loop, I'm going to need an index variable. So I'll create a variable, make it equal to 0. And I'm going to use this to index into my range array so that I can populate it as I loop. And I'll simply go while A is less than or equal to B. I'm going to start my looping with A and really use that as my, I guess you could say, iteration variable. And I'm going to increment it each iteration until it gets to B. So I'm going to take A, increment it. And as I'm in here in the body, I am going to populate my array with A. Of course, initially A is going to be the beginning of the range, but A is going to go up as I move forward. And to make A go up, I've got to give it a plus plus. And I also need to move my index forward so that I can continue to get the next index of my array. So I'll do that forward, move that forward as well with a beautiful plus plus. And that loop is going to populate the array. And then I will simply return the array. Range is the array, of course. And that is that. Bring things closer together so maybe you can see it on one screen. Yeah. Let's run this sucker through. That passes. And that passes. Correctamundo. There is your Java solution to what is between. A little bit longer in Java, but it gives you a chance to really work on some core skills there with the looping and the indexing and the such and the this and the that and the whatever. But we got a passing score. You don't really get scores in Code Wars, but anyway, we got it done. Here's the solution, and that means I'm out. I am out of here. Talk to y'all later. Haha, welcome back homies, and today looking at duplicate sandwich from Code Wars. Once again, been a long Code Wars grind, and this one is in Python. In this one, you're going to be given a list consisting of unique elements except for one that appears twice. Your task is going to be to output a list of everything in between both occurrences of that element in the list. Looking at examples, our first list, we have consecutive, well, not consecutive, but we have numbers, we got integers, and we see that we have a 1 and a 1. There is our duplicate, and the task is to return or to create a list of everything in between and return that. And if we look over at the solution, we see the 2, 3, 4, 5, 6 as the return. Looking at the next one, notice we got different data types. So looking at these examples, so that's something that's got to be thought about as well. Different data types. Anyway, looking at the list, we have none, hello, example, hello, none, extra. So we have none twice, the string none. So then the idea is to get everything in between the string none, which is hello, blah, 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 to hello. And yeah, that's in between, and we see that. Looking at the range of items you return, notice the duplicates are not inclusive or not included. So looking at the first example again, the 1 and the 1 are not included in your output. Something to keep in mind. Exclusive, I guess you could say. All right, so let's do this. And getting into the training area, I need to first find an element or value that appears twice in the list. Couldn't really think of a clever way to do this right away, so I'm doing it manually. I'm going to loop through and get a count of every element, which is not the greatest, but you got to go with what comes in your brain at the time, right? And I am going to hold the index of that duplicated element in this variable called start, because we're going to be using it later on. So yes, start is going to hold the index, the first index of this duplicated item, because I'm going to use it as a starting point to find the next occurrence of this duplicated item. I'm also going to create a variable to hold the value of this item. And I'm going to initialize the variable to none because I don't know the data type of the item, so I'm not going to make it a string, even though I guess it really wouldn't matter, but I can make it a string, integer, whatever. And of course I could override it with the right data type, but I'm just going to make it none because I don't know what data type it is. It's going to be used to hold the duplicated value. I'm going to use this later also. So I'm going to start looping so I can find the duplicated item. And this is a pretty simple thing where I'm simply gonna whatever, yeah. Talking crazy this morning. Yeah, I'm gonna loop in a linear fashion until I find the element that is duplicated. Simple as that. And when I find that element, I'm going to make my start equal to it. And I'm going to make this variable equal to it, equal to the actual value, because I'm going to use both of these items later on. And then I'm going to break, because once I find my duplicated item, I don't need to loop anymore. I'm done, I'm out. Kind of like when I'm done with these videos, right? See y'all later, but I'm not seeing you later yet. I'm going to continue. All right, so once this loop is done, I have the index, the first index, and the first index of the duplicated item, and I have the value of the duplicated item. Both important things. I'm going to now create a slice of the original list where I'm going to start at an index 1 past where I found the duplicated item, because I'm going to find the next occurrence of it. I'll call this one new start and make it equal to a slice of the original, where I'm going to go like this. Start is the index where I found the duplicated item. I'm going to go +1 because I don't want the duplicated item included in this new slice. I want to go 1 past it because I'm going to find the next occurrence, and I don't want the last occurrence mucking it up. I kind of wanted to say another word, but I'm not going to do that. Okay. So now I got that slice. I don't have much more to do actually, because what I can do is I can just find the next occurrence and return a list from 1 past the first occurrence up to right before the next occurrence, and I'm good. So I can do this all in one line, where I can take my slice and create another slice of it, where I start where the slice on line 9, let's say, yeah, start where that begins, and then I'm gonna do this. I'm gonna find the index of the next occurrence of my duplicated item by using the index function on the previous slice. So this new slice that I created on line 10, it's going to go from the original location of the slice that was created on line 9, starting there, and going up to the next occurrence of that duplicated item, really one before it. So on line 10, I've essentially solved the problem of starting from just after the first occurrence to one before the next occurrence, and that is exactly what I'm supposed to return. Creative slicing, or necessary slicing. Let's check it out, see where we failed. We have failed nowhere. Attempt, all good, all good. As one of my former students said all the time, all good. And there it is, nice and tight. Using some longer than necessary looping and some slicing, we got this sucker done. And now I'm going to be out because we are done. So with that, got a solution, duplicate sandwich, Python, Code Wars. Yes, y'all, I am out. All right, 1, 2, 3, welcome back, bitches, and good morning. And yeah, this is alphabet symmetry, a Code Wars exercise in Python. Looks like I'm always in Code Wars, but I'll break out of here eventually and do some other stuff. But today, we back in here. You know what I'm saying? All right. Consider the word abode. We can see that the letter A is in position 1, B is in position 2 in the alphabet. Or I read that wrong. In the alphabet, A and B are also in positions 1 and 2. Notice that the D and E in abode occupy the positions they would occupy in the alphabet, which are positions 4 and 5. Your task, my task, given an array of words, return an array of the number of letters that occupy their positions in the alphabet for each word. For example, you're given a list of strings consisting of letters, and you have abode, A, B, C, and XYZ, D, and you return 4, 3, 1. I don't think it's explained very well, but what is actually meant is for each letter in each string, we are to determine if that letter is in the same position that it is in the alphabet. So A is the first letter in this string. It's also the first letter in the alphabet. B as well. O is not. O is not the third letter in the alphabet, so it's disqualified. D is the fourth letter in the alphabet, and E is the fifth letter in the alphabet. So the D and the E are in their spots, correct spots. A and B are. And what we're supposed to do is get a count of each that are in their alphabetic spots. So we compare the string position in the string to the alphabet position. That's the key. And you count the number of each. Kind of a weird concept, but hey, it's practice. So there's four things in the alphabet spots in the first string, 3 in the second string, 1 in the third string. And yeah, you return a list of the counts. And the counts correspond to the strings. There will be the same number of counts as there are strings. So that's how you do it. All right. Got to get this in here because I got an appointment coming up and I'm got to squeeze this sucker in. So probably go a little fast on this one, folks. Okay. I'm going to create a list to hold the counts. And then I'm going to loop through the list of strings. And then for each string, I'm going to get a count of the alphabet stuff in the right index. It wasn't said right. Okay. Yeah, I'm going to do a nested loop because I'm going to be looping through each character in the string to see if it's in the, if it's in the alphabet position, or if it's in the same position as it is in the alphabet. Before I do that, though, I need to create a variable to hold the individual counts. Make that equal to 0. And now I'm going to do my inner loop. And that's not it. I'm going to do strings I. Strings I is going to be each individual string in the list of strings. And I'm going to go character by character and determine if that character is in the same position in the string as it is in the alphabet. So looking at this this example, you notice that we've got uppercase and lowercase letters. We've got to account for that. Either we've got to make it case insensitive by making it all one case, or we got to differentiate between the cases of letters. I decided to differentiate between the cases, and I'll show you what code I came up with to do that. And in the interest of time, I'm just going to copy my stuff in here and give you a little explanation. Yeah, because what I have to do is compare the character's position in the alphabet to its position in the string. That's the key. So let's look at lines 6 through 9. And we'll isolate on the first, on the if here. Strings ij is the current letter. And we're going to test if it's uppercase. Because if it's uppercase, I'm using ASCII values to determine the alphabet position. And so if it's upper, I'm going to test it against the uppercase decimal ASCII value. So I say if it's upper and if J, which is its position in the string, if its position in the string is equal to its position in the alphabet, then I'm going to increase my count of alpha because I found a match. Position in the string equal to the position in the alphabet. And yeah, this is an offsetting situation where I get the decimal ASCII value and then I minus 65 to offset it to zero-based alphabet ordering. And then I do the same thing if it's lowercase. If it's lowercase, I compare the current position, or not the current position, the position in the string to its position in the alphabet, ASCII wise. And so once I am done with that, once I'm done with that inner loop, I am going to append my count to my list because I'm going to return a list of counts. And then, really, as you see up here, I would loop back around and my alpha count becomes 0, and I do the inner loop over again for the next letter in the string. Amazing how that works, ain't it? Like my friend Kelly says, amazing. Going crazy here, folks. Losing my mind. All right. Got that. And then once the outer loop is done, it is time to return our stuff. And it's LST. Folks, I think we're done. All right. That looks good. That looks good. All right. On a bit of a time crunch, folks, so I gotta bail out. But y'all have a good one. Here's the code: alphabet symmetry, Python, Code Wars. Do it, get it done, do it better than me, and I'll see y'all next time. Catch y'all on the flip. Okay, welcome back, homies, and today we meet again, and the subject is midpoint sum from Code Wars, and this is a Python exercise. I think you can see that on the screen, but needed to give that intro just for the hell of it. That's what I do. Okay, midpoint sum for a given list of integers, or return the index, so the element, or the sums of the integers to the left and right of the current element are equal. This is kind of a classic exercise type of algorithm, and don't remember what it's called. Some of you guys, maybe you can tell me what it is, the name of this idea. But here it's called midpoint sum. Let's break down this idea. The sums of the integers to the left and the right of the current element are equal. So, given a list, we go along and see at which point, as we traverse, is the sum of the elements to the left of a certain index the same as the sum of the elements to the right. And here we got an example, pretty good example. Here, the point at which that is the case is going to be where this 9 is, because 4 plus 1 is 5, plus 7 is 12. And then on the other side of the 9, 9 plus 3 is 12. So we got a match there. Good. So yeah, the returned index would be 3 because you are returning the index at that midpoint sum area where we find elements to the left and to the right equal. This is element 3, obviously 0, 1, 2, 3. Take that to the bank. Next example. Next example returns none because there's no point at which the sum of the elements to the right, or the left, equal the sum of the elements to the right. There's no point at which. So when you don't find it, you'll return none. And I want to hip you to a couple of rules down here. Element at the index to be returned, if the element at the index to be returned is not, wait a minute, I'm reading this wrong. the element, the midpoint element that you find, it's not included in the summation. That's really what this is saying. So it's not inclusive. So we do not consider the current element when we go left and to the right. Know that. I had a hard time getting it out myself anyway. Number 2, both the first and last index cannot be considered as a midpoint. So you will not, your midpoint cannot be at the beginning or the end of your list. So don't even consider it. We got to block it out in our code. That's enough of an intro. Let's dive into this mother and figure it out. All right. This kind of ends up being pretty short and sweet, where I am going to loop through the range, loop through the list of integers, interestingly called ints or ants, whatever. I loop through it, and then I do a fairly long if statement where I say, really, if the sum of the elements to the left is equal to the sum of the elements to the right, and I is not 0 and I is not equal to the end, then I'm going to return I. Hope you got some of that. You'll see it in code here right now. So if the, and not sums, so I'm simply going to get the sum of the elements to the left, which will be a slice going from the beginning. The slice will go from the beginning of the list right up to I. That's going to give me the sum of the elements to the left. And I'm going to check to see if it is equal to the sum of the elements to the right. I will do another slice going from I plus 1 to the end of my list. Of course, I is not included in your summation on either side. So with both of these slices, I am omitting I, as you may notice. So yes, if the sum of the left and the sum of the right are equal, that is our beginning point. But we must also observe that the midpoint cannot be at the beginning or end, as per rule number 2 down here. So I'm going to go ahead and omit that in my if statement. So if and I is not 0, which would be the beginning, and I is not equal, I is not the end, so not equal to the length minus 1. Because if I was equal to the length of the list minus 1, it would be at the end of the list. And just generally, for you all that don't know, getting the last element of any list or any array is always the length of the size of the array minus 1. It will always give you the last element. Hopefully I said that right. Not somebody correct me. Because it's about getting the right answer, it's not about being right myself. Yes. Okay. And if all that is good, I'm going to return I, because that will be the index that I am seeking. And if I get all the way through my loop and it's not good, I'm going to return none, because the instructions said so. The instructions have spoken. Time to run. Who was born to run, baby? Let's go. That passes. Looks like that passes. We got a correctamundo. Very good, very good. Let's go. Yeah. All right, I like it. I like how it's going. Could be better, always can be better. Always strive for better. That's what I say. But I ain't doing any more on this one. This is going to be it. So here's your solution to midpoint sum from Code Wars in Python. All right, that's out. That's out. That's it for me. Ali Ali Oxen Free. I am gone. See ya. Okay, let's roll with this and back again with sum of array singles. This is a C++ exercise from Code Wars. Let's get it. Okay. In this one, you're going to be given an array of numbers in which two numbers occur once and the rest only occur twice. Your task will be to return the sum of the numbers that occur only once. This is worded oddly. I think it's worded oddly to deceive. So let's break down what this means. Looking at this example, the real skinny on this is that you're going to have most of the numbers will occur twice. There will be a pair of numbers that are unique. That is the key here. A pair of numbers that are unique. So they will only occur once. And the numbers that each occur only once in this list are 7 and 8. The rest of them occur twice. You see the 5 and the 4 occur twice. And what you do is the two numbers that occur only once, you are getting a sum of those two. 7 and 8, sum is 15, and there's your solution, your idea that you look for two numbers that are unique. Once you find them, you sum them, and there you go. So with that, I'm going to get in here. Nothing else to say. Short and sweet. Let's get it. Get into that training interface and get into C++. And you see from the function header that the incoming the incoming data is going to be a vector. So we got to deal with a vector, and so we got to look at this vector and see what are the two unique values. And thinking about like how do you get a unique, or how do you determine a unique value? There's a function in the standard namespace called count, where you can count the occurrences of a value. Well, if the number of occurrences is 1, that value is unique in the vector. So we're going to traverse the vector, meaning go from the beginning to the end, and look for the two numbers that are unique, the two values that are unique, and sum those two values. There's a synopsis, and here we go. And I'm going to first create a integer to hold that sum. Set that equal to 0, and then we're going to do our little for loop. I'm going to use size t for my iteration variable, because unsigned integer can only be positive, typically used for looping, traversing, iteration, whatever word you want to say, that makes sense. And yeah, the condition is while it's less than the size of the vector, we keep going. Okay, and here I'm going to do an if condition, where inside my if condition I'm going to get the count of each value. If the count of this value is 1, then I'm going to add it to my sum. There's only going to be 2 values that have a count of 1, And when I add to the sum, or add them to the sum, it'll be only those two. That'll be my answer. Hell of a way to explain, right? Good. Okay. Here's the look at the syntax for the count function, where it's from the standard namespace. So do that scope resolution thing, and then the arguments are the beginning of the vector and the end of the vector. I believe these are iterators for beginning and end. And then you put the value that you're looking to get the count of, which will be v index I, this element. And if the count is 1, then I'm going to add this value to my sum. I don't think that rhymed. It feels like it did. And that's the wrong variable. It's plus equals the value. Nope. Not v of 1, v index I. I. That's it. Gonna return my sum. There, my friends, my dears, is it. Run this through, see what we got. I think we're good. But yes, coding is a very humbling thing. You think you got it, and you run it, and you're not there. So never can be completely sure. I guess you can sometimes, but as soon as you get overconfident in coding, you get knocked down. And it's kind of like baseball. Don't get too low or too high. Yes, impressive. That's it. There's your solution for sum of array singles. Interesting exercise, whatever. Interesting solution on my part. But with that, that's it. That's the end. Enjoy. Till next time, I'm out, and see y'all later. Okay there, bring them out, bring them out. Looking at alternate square sum from Code Wars. It is a Python exercise. Let's dive in. Complete the function that takes an array of integers as input and finds the sum of squares of the elements at even positions. These would be positions the second, fourth, etc. Plus the sum of the rest of the elements at odd position. This will take some explaining because I don't like the way this is set up explanation-wise. For empty arrays, the result would be 0. Let's scroll down a little bit. The values at even positions need to be squared. For a language with zero-based indices, like most of them, this will occur at oddly indexed locations. For instance, in Python, the values at indices 1, 3, and 5, etc. should be squared because these are the second, fourth, and sixth positions. Long story long, we're going to square the elements at odd indexes in the list and leave the ones at even indexes as they are, and then we're going to sum everything. So, and it talks about positions here. Positions are one based in this context, so these would be even positions, which would be like the 12 and the 14 in this example. Even positions, but odd indexes. Could be confusing to some people, but anyway, even positions, those get squared and they are added to everything. Really, everything is added. So the thing is, we're going to square I feel like I'm saying this for the fourth time. We're going to square elements at odd indices, keep the ones at even indices untouched, and then we're going to add everything together. That is the situation. Got it? Got it? Good. If you don't, I can't hear you, so it don't matter. Rewind if I haven't blown your mind. All right. I'm gonna create a variable to get the sum of everything. Then hop right into a loop. This one's pretty simple, so not a whole lot of trickery going on here. And as I loop, I'm going to accumulate my sum, where I'm going to do an if and an else. If I'm on an odd index, I'm going to square my element. If I'm on an even index, I am not going to square it. I'm just going to add it to my total. So I mod 2. This is how I can find an odd index. If the index modulo 2 is 1, meaning if the remainder when this index is divided by 2 is 1, then that number is odd. And I'm going to add its square, because as I said for the 40th time, I'm going to be squaring elements at odd indexes. Then the else will be evens. I will sum those as well, but they will simply be the element as standalone, well, no changes. That's a better way to say it. Now I'll return the sum. And that's it, ladies and gents. That works. And that works. Alright, yeah, pretty short and sweet, simple idea here. But I'm going to do a little wrinkle here because, yeah, this situation is so simple, I can reduce this whole thing to one line using list comprehension. So I'm going to scrap what I got here, go into my list comprehension mode. Going to be kind of hard to see with the increased size of type, but oh well. What I'm going to do, I'm going to create a list of my squares and unmodified values, sum that list, and that will be my result. Because I am to get a sum of non-squared things and squared things, so it works out. Whoop, 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 whoop. I do have a video on list comprehension. You can check that out if you want to learn a little bit about the process and the idea behind list comprehension. If you know it, good for you. just watch and learn and listen and whatever. Can't always figure out how to end sentences, right? I know how to end pieces of code, though. That's what I do. Great googly moogly. I'm going to drop this into online GDB just so you guys can take a look. Of course, the idea here is to educate and inspire, so why not give you a look at this mother. Increase the size. Screw it. I ain't gonna increase the size. Check it out. Here it is. I'm getting a sum, creating a list through list comprehension, and what it is if I mod 2 equals 1, meaning it's odd, I am going to append the squared element. Otherwise, I will append the unmodified element. And here's the loop header, and that's it. It's going to return a sum of that list containing the squared items and the unsquared items. There you go. Gonna run it through just to make sure it works, and then be out. Things to do, bills to pay, homie. Yeah, looks good. All right, you saw two versions there, non-list comprehension and list comprehension. That will suffice. And just did alternate square sum, Code Wars, Python. Go have some fun, do your own version, do it better than I did, post it, comment, whatever. And that's it for me. So I am out. Okay, back again with another code breakdown, and this is from Code Wars. Dictionary drills and user contacts. Yeah, that's what it is. I had to reset myself a little bit there. You are putting together contact information for all the users of your website to ship them a small gift. You queried your database and you got back a list of users where each user is another list with up to 2 items, a string representing the user's name and their zip code. Yeah, some of these have backstories which are a little unnecessary. An example might look like, and yeah, they have a 2-dimensional list. Right, you have your outer list. The inner list is a name and a integer, and you notice some have both, some have one. So you got a name and an integer. So name and a zip code according to this backstory here. Notice that one of the users above has a name but doesn't have a zip code, namely Miss Bethany Cock. No jokes out there. Write a function user contacts that takes a 2-dimensional list like the one above and returns a dictionary with an item for each user, where the key is the user's name and the value is the user's zip code. If your data does not include a zip code, then the value should be none. So for Miss Bethany Cock, the value will be none. The objective here is to take the 2-dimensional list and turn it into a dictionary where the name is the key, the value is the integer zip code. And for one's missing a zip code, you're going to put none as the value. So we zoom it down here. There is your resulting dictionary. You see the names, zip code, key, value. Good, good. Let's go. Let's get into it. Hit the training area, hit the gym. Let's do this thing. I'm going to show you 2 versions of this. And yeah, as a little sneak preview, this is going to be able to be put into dictionary comprehension. I'll do that soon, once I get the first one out the way. Going to create an empty dictionary. I'm going to populate this, of course, with my stuff. I am going to loop through the 2-dimensional list, going first dimension, list by list. And yeah, of course, when you loop through a 2-dimensional list, each element is itself a list. And I'm going to do my check for each inner list only consisting of one element. Because if it consists of only one element, it's going to be like Miss Bethany Cock here, where I'm going to put none for the value. So I'm going to do that check just right away. I'm going to say, if the inner list only has one element, I'm going to put none as the value for this key. And I'm going to check the length of it. The length of the inner list is only 1. Then I am going to create a key for my dictionary using the name and make it equal to none as the value. See, checking out this syntax here on line 5. This underlined portion, this is the creation of a key in my dictionary. I'm creating a key that corresponds to the name, and I'm making it equal, I'm making its value for that key equal to none. That's what's going on there. And I'm going to say otherwise, or else, if you will. I am going to create a key as well, and I'm going to make it equal to, and actually I screwed that up a little bit. Let's go back to line 5. Got an addendum there. So data index I, it is not the name. Data index I is the entire inner list. Or yeah. So I've got to index into the inner list and get index 0 of that. See, let's look at one of these inner lists that has 2 elements. You look at this, the inner list. This is element 0. This is element 1. So my key needs to be element 0 of that inner list. I messed that up initially. Now it's corrected. Got to do that here as well. 0. So for the else, of course, I'm creating the key, making it equal to the name. The value is going to be equal to element 1 of my inner list, namely the zip code. And using double indexing, it's data I1. That is it, kiddies, because I'm going to have it, it's going to be populated, and the dictionary is, that is. I simply return the dictionary. We are good to go. Maybe not. Let's see here. Yeah, misspellings up in here. There we go with that. There we go with that. All right. There is version 1. Now I'm going to hip you to version 2 of this mother, and I'm going to do it with dictionary comprehension, turning this into a one-liner. Now I'm going to do that one-liner in a different environment because for some reason in Code Wars, actually, I was going to say I can't expand the training area, but I totally can. I forgot I can use this thing on the top right to do so. So I'll expand the area and get to work. Thank goodness for a good memory here. So turning this into dictionary comprehension. And if you don't know what dictionary comprehension is, it is the ability to create and populate a dictionary on a single line using a certain syntax. That syntax will typically involve a for loop, where you use a for loop to populate and create your dictionary. I'm going to do that for this because the objective here, of course, is to create a dictionary based on certain criteria. So this is going to be a one-liner, so I'll be able to create, populate, and return the dictionary on a single line. So it's all happening right here. I'll start with curly braces. denoting a dictionary. And it'll get a little thick here, and I'll just type and explain soon. Alrighty. Let me check this thing out a little bit, make sure it's good. Okay, yeah. So got your header. You put the header typically at the end in dictionary comprehension or list comprehension, as it were. And really what I'm saying is similar to what I was saying in my earlier thing, or the earlier version, is that it slightly different logic. But if the length of my inner list is 2, I'm going to make a key value pair consisting of the name and the zip code. Otherwise, the value is going to be none for that dictionary. There's your dictionary comprehension. And let's try this sucker out. Turn this mother out. Now I've contracted where this is the expansion and this is the contraction. In Code Wars, you can do this right here at the top. This is the top right. So just letting you know what's going on here. Now I'm going to run this sucker. Test. See what we got. Good test. Good not submission, attempt. And there we go. So there, my friends, is your dictionary comprehension version. So you got 2 versions. You don't remember the last one, rewind, take a look at it. Here's your other one. And that's it for me. Got a solution, got some explanation. Good morning, good afternoon, good night, and I am out. One, two, three, three, two, one. Back with another code breakdown, and this is numbers with D occurrences of D from Code Wars. Yeah. All right. Happy Saturday morning, even though I'm sure it's not Saturday morning when y'all are watching this, but it is here, so I'm gonna say it. This exercise from Code Wars is gonna be done in Java. Not Python, Java. So not getting Pythonic, getting Java-ic, whatever. That didn't sound right. Okay. In this one, we want to discover a small property of numbers. We say that a number is a DD number if it contains D occurrences of a digit, D, and D is in the set of 1 through 9. So D will be something 1 through 9. And if you don't think it's clear by that description, I'm with you. I'll explain it a little bit better soon. Examples, you have this number. It is a DD number because it contains 4 occurrences of the number 4. These numbers are also DD numbers, as they respectively contain 3 occurrences of the number 3, one occurrence of 1, and 2 occurrences of the number 2. This last example, these are not DD numbers. Okay, let me tell you what a DD number is if you haven't gathered it to this point. A DD number is a number that contains values that have or at least one value that has the same number of occurrences as its value. So looking back at the first example, this first one is a DD number because it's got 4 occurrences of 4. You see that matching? 4 occurrences of 4. This first number here, this is a DD number because it has 3 occurrences of 3. So the number of occurrences needs to match the value. So we're going to really have the method's going to take in an integer, and we're going to kind of parse that integer to see if there are any values in there that have the same number of occurrences as the value itself. That is a DD number. I think they got to do better on some of these descriptions. They got to have some quality control, but I guess you can figure it out by the examples and using your own guile. All right. Shout out to Street Fighter, right? Guile. Let's get in here and do this thing. Java, so you got your little boilerplate here. And I'm going to expand this out. And yeah, so how do you go about this joint? You're going to get an integer, as you see here, and you got to check out the integer to see like how if there are any values that have the same number of occurrences as that value itself. Well, think about a multi-digit integer like simply like 1, 2, 3, 4. How do you go about analyzing digit by digit when you've got this whole quantity? Well, you can break it apart where I think you may have seen this before, at least if you've watched other videos of mine or you're a fairly experienced programmer. You can break apart a multi-digit integer by using modulo and division. Modulo being the percent symbol from arithmetic, and it is a way to get the remainder of a division. Long story short, you use modulo. When you do modulo 10, like any number, let's say a number x modulo 10, that's going to give you the number in the ones place of that integer. The ones place being the rightmost digit. In 1, 2, 3, 4, 1, 2, 3, 4 modulo 10 will give us a 4. And this is the beginning of the isolation of digits, where if we do modulo 10 to get the last number, we can throw that into an array or an array list. Then we can divide the number by 10. When you divide a number by 10, it will eliminate the number in the ones place, leaving the other numbers. So then you loop around, you do modulo 10 on the modified number, and you get the next number in the ones place. You do this over and over again, and you eventually get all of the numbers isolated, put into your list or your array list. Then you can analyze each one. And that's really what we're going to do in this video, as they say in some countries. In this video, we're going to do that. And enough comedy here. I need to focus on the code. I'm going to clear this out and get into it. So yeah, I'm going to break it apart. I'm actually going to put it into an array list because I don't know how many digits each one's going to be. So when you don't know the size of your data structure, you can use an array list because array lists are resizable, various size. You don't have to say the size when you create the array list. I'm going to import java.util because array list is in there. And to avoid a little bit of typing, I'm going to plop an array list right in there because Java is a little more verbose than Python is. Yeah, I'm going to use that array list to store my numbers. And I'm going to go ahead and do a loop to do my number, my digit, I guess you could say, storage. Great, googly moogly. I'm going to add to the array list. N is my original integer. That code right there is going to create an array list consisting of the individual digits from the original integer. I'm going to do modulo 10 to get each digit. Then I'm going to divide the number by 10 to clear the ones place digit. And the condition here is while n is greater than 0, because n is going to progressively get smaller. I'm going to take numbers away from the ones place. Eventually, it will have no digits and it will be 0. That is when we will leave this loop. And once we leave the loop, we're going to have each digit isolated in a array list. So let's get back to how we're going to figure this thing out overall. We need to determine the counts of the digits, like how many of certain values are in it. Well, we need to, or what I'm going to do is determine what are the unique values in this number. To determine the unique values really means without duplication. And a data structure that will remove duplication when you create it is a thing called a set. And one of Java's implementations of the set is the hash set. And I'm going to use that because I'm going to take my array list, and put it into the hash set to get all unique values. Then I'm going to loop through those unique values and then get counts in the original array list to see how many of those values are in the array list. Maybe a complicated idea, but maybe not so much depending on who you are. I'm going to drop code for the creation of the hash set. This creates a hash set, and it's going to be a hash set using the array list as its source data. It's going to take all the stuff from the array list and give you only unique values. So this hash set HS will contain only unique values. What I'm going to do is loop through the hash set, and for each unique value, I'm going to count the number of actual occurrences in the array list. So looping through the hash set, I'm going to use a for each or enhanced for loop, if you will. Of course, it is a hash set of integers, so I'm going to say, like, for each integer in the hash set, do something. Once inside the body of this for each or for each or enhanced for loop, I'm going to create an integer to hold the count of the current value. Because I am looping through each unique value, I'm going to count the occurrences of that value in the array list. The array list is the one that will contain duplication. I want to see how many duplicates, basically, of each value are in the array list. So I'm going to loop through the array list. So this will be a nested looping situation, a developing situation, as Bill Pito used to say. Anybody watch NHL Tonight back in the day? Anybody old enough and a sports fan back in the mid-90s. Still love that show. Whatever happened to Bill Pito? I'm sure he's out there doing well. All right, so I'm looping through the array list using a normal for loop, and I'm going to do an if in here to count the number of occurrences of said value. That's not right. I want to get the value at I, and if this value is equal to num, which is the value from the hash set, if it is equal to the value from that hash set, let's I just have to clear my throat for 6 hours in the morning until afternoon. Okay, if the current value of the array list is the same as the hash set value, I'm going to increase number count because that means I've got another occurrence of that number or that value. Once my inner loop is done, I will have a count of the values, and I can do a little if statement here because going back to the original idea or the original purpose of this exercise, it is to determine if the count of a value is the same as the value of a value. That's a DD number, as it is said. Why couldn't they include that in the description? Oh well. I'm going to say if num count equals the value, which is num, I'm going to return true because this is a method that returns a Boolean, and true would be the case here. And for my false, I'm going to do a condition for false after the outer loop is complete. It means I've gone through all of the values, all of the array list values, and I found no DD number. If I found no DD number, then I will return false. There we go. I believe that concludes this code. I will condense this a little bit. And yeah, there is your complete code in one screen. It is time to run this thing. I've explained enough, I've said enough, I've cleared my throat enough, so let's take it out. Passed. Passed, very good. And give you one more look. There it is in all its glory. And then I will submit because I don't have a Java version of this one saved yet. So hit that submit. And we are in there. And yeah, there's your solution for number of D occurrences of digit D. My name is Dean Greer. I haven't said that on any of these videos before, but you know it is because you see it on the damn page. But I'm out of here. See y'all later. All right, back again with another one. Swap items in a dictionary from Code Wars. Python. Let's go. In this one, you're going to take the keys and values of a dict, no jokes, and swap them around. You're going to be given a dictionary, and then you will want to return a dictionary with the old values as keys and list the old keys as values under their original keys. Once again, a suspect explanation. But what you're going to be doing is you're going to swap the keys and values, or what I am going to do, and you're going to watch, is swap the keys and values in this dictionary. Looking at the sample dictionary right here. Focus up. Looking at this dictionary. Once again, all the throat clearing that happens in the morning. Good morning, folks. Okay. Given this dictionary, you're going to swap the keys and values. So let's look at the values. Cream, 21, cream, cream. What's going to happen is that cream and 21 are going to become keys, and of course the keys will become the values. Of course, keys must be unique, so you can't have like 3 cream values. So you make 1 cream value, and all of the keys that it corresponds to, I guess you could say, are going to become the values. So you see cream ice, cream light, cream double. The values are going to be in a list. So that's how you do the I guess the mapping, you would say, where in the original dictionary you've got the same value going to many keys. You take that value, make it 1 key, and then the keys that it maps to will be in a list. So that's how you handle that. So the keys are going to be strings in this new dictionary. The values are going to be lists of the former keys. So hope you followed that. But let's get into this and do this old swaparoo. This is a good exercise and kind of a classic deal where you're just going to be swapping keys and values. So let's dive in here, get into the training area. So DIC, again, no jokes please, that's going to be your dictionary. You swap the keys and the values. Of course, going to create a new dictionary, so I'm going to give it a file, not a file name, I'm going to give it a variable name. I'll just call it return, no jokes please. You can think what you want, but don't say it. All right, and I'm going to loop through the original dictionary, and let's see, how will I do this? I could do it a couple of ways. I'm going to get the key and val from I'm going to use the items function. When you use the items function, the items gives you a structure of tuples, and the tuples are pairs, and the pairs are keys and values. When you loop in this manner, you're going to, for each iteration, you're going to get a pair. First thing will be key, a second thing will be value, so it works out. So I can do this comma pair, and the key will be stored in this variable key. The value will be stored in the variable value. So, of course, I need the keys and values in order to swap them. So this is a convenient way to get them. All right, so focusing in here, we're going to take the values and make them keys. So as I loop, I want to determine if the value that I'm about to make a key, is it already in my new dictionary? If it's not already in my new dictionary, I will create it. So I'll do that check. If the value is, let's say not in, return dict. If it's not in there, meaning if it's not a key already in there, I'm going to make it a key. by doing that syntax. That makes it a key. And then I'm going to set its beginning value to a list, because remember, the values for this new dictionary will be a list of the former keys. I'm going to create that list, and I'm going to put the key from the former or from the source dictionary as the first element in that new list. And that's what I do for if the value is not already a key in the new dictionary. If it is already there, which covers the else says if the value is already a key in this new dictionary, it already exists, so I'm just going to append to the list that is already there. Same syntax, but you append here because the value list is already there. I'm just going to append a new value to it. And again, the values in the new, or the value in the new dictionary, is going to be a list of the former keys. Keep it straight, folks. After this loop is done, we are done. So I'm going to return my return dict, and that be's it. Tighten this up a little bit. Collapse the interface and try to run this sucker. I've adopted certain sayings in these videos and say them over and over again. But humans are based on habit, and that's kind of how I am. I'm a human, I think. Last time I checked, I was born on Jupiter. Okay, this passed. This is good. I tried to do this with the dictionary comprehension earlier today, and I wasn't able to do it. Maybe one of you can figure out how to do that and let me know. Maybe I'll figure it out, maybe I won't. But this exercise is done, passed up, got it done, cut, print, good. So I'm out and you're out. So talk to y'all later. See you on the flip side, and let's go. Okay, today looking at keypad horror from Code Wars, and this is a Java exercise, my friends. It is Java. So let's go. The description says having two standards for a keypad layout is inconvenient. Computer keypads layout, and it shows a little picture here of your standard kind of data entry situation. 789456123. We've seen this. We're probably on a computer right now. So yeah, you've seen that before. So it shows a picture of that. Then it shows a picture of a cell phone or telephone for you older cats, the layout. Yeah. And it says, solve the horror of unstandardized keypads by providing a function that converts computer input into a number as if it was typed on a phone. Example, 789 to 123. You get a string with numbers only. Okay, what really is going on here is that you're going to get a string of numbers, and you're going to convert from this format to your cell phone format. And it's like you're going to convert orientation to other orientation, like physical location, sort of. Like the 7 is at the top left here. It's going to get converted to a 1. The 9, top right, converts to a 3. So you convert between. So the 789 is the 1, 2, 3, 4, 5, 6 is the same, and then it's flipped where the 1, 2, 3 from the computer is 789 on your cell phone layout. So computer keypad to cell phone, that is the conversion happening here. And if I did not mention it earlier, this is a Java exercise, doing it in Java this time. Let's go. Going to expand out here because I'm going to need some room. And I'm first going to import java.util because I'm going to be using ArrayList and arrays for this one. Converting from computer keypad to cell phone keypad. I'm going to copy in to pre-made, pre-baked goodies here to array lists. I've got an array list of characters, really two array lists of characters. The first one is the numbers in order of computer keypad, and the second one is cell phone keypad. And what I'm going to do is I'm going to use the corresponding indexes for conversion. Like the 7 will map to a 1, the 9 maps to a 3. Of course, the 4, 5, 6s are the same as you saw with the difference in the pictures. And then yeah, these map to these. So what I'm going to do is, find a number in the computer keys and then convert using corresponding index. Like if I get a 7, it's going to convert to a 1 based on index, because the indices, I guess you could say, will be the same across the array lists. So I just look for the same index in the other array list. That's what I'm doing to do the conversion. So let's do it. Indent here, indent. The conversion is going to be held in a string, so I'm going to create a string. Empty one. Some of y'all out there use string builder. I never got into using string builder, but this works. String builder is good as well. Gonna loop. I'm going to loop through the original string. And the original thing is a string, so I'm going to get the length of it. And maybe I'll make this a little bigger, just in case it needs to be seen better by y'all. Okay, as I loop, I'm going to convert the number character, and concatenate it into my converted string. So on the left side, of course, the destination of things is always on the left. I am going to do this. I'll explain this soon. Okay. When you see a complicated expression, typically my guideline is to look from the inside out to kind of read it. This line really contains the entire conversion from computer key to cell key. So I get the current character from the original string. And then I get the index of that character in the keys array list. I get the index of it. That is going to be an integer. And then I feed that integer into the get method of cell, and that is going to get a character from cell that corresponds to the same index from the keys array list. Corresponding indexes. Like if I'm dealing with a 7, I'm going to get the index of 7 in keys and then feed that into cell to get the to get whatever is at index I of cell. So this is how the corresponding indexes match up, or indices, if you will. Indices. Whatever it is. You guys can tell me. I'm not a pronunciation expert in the world of programming. But at the conclusion of that, you're going to have the converted character, and you're going to concatenate it to convert it. Very good, very good. So now that that is done, I am done, pretty much. I will return my converted string. We are good to go. Time to test this out. Go back to this, and yeah, this looks crazy when it's all blown up and expanded. That passes. And I know that is going to pass. Passed. Excellent. Okay, there is your solution. Blow it up a little bit again. This is, what's the name of this one? Keypad horror. That's it, yeah. Not the other one. Keypad horror. Okay. In Java, it's done. Code Wars. Here we go again. Good morning. Happy Monday. Thank God it's Monday. And I am done. All right, hot damn, here we go again with another one. It is remove consecutive duplicate words, a Java exercise from good old Code Wars. Yeah, let's go. And your task is to remove all consecutive duplicate words from a string, leaving only first words entries. Not sure if that's correct English, but here we go. So you got a string here. You see there's duplication, duplicate words. The thing is to remove consecutive duplication. So where there are duplicated consecutive words, you get rid of those. So like here, here, and here, and here, leaving only the single instance situation. So really, no duplicates next to each other. That is the deal here. Looking at this example return, you see that there's duplication, but there is no consecutive duplication. So that is the thing. And the words are going to be separated by a single space. No leading or trailing spaces in the string. And an empty string is valid input. Very good, very good. So we're removing consecutive duplication. Let's get in here and start it. Oh, already got my code in here. Let's clear that out. Because I want to code from scratch with y'all so you can see the dang process. It's all about the process. I'm going to first create a string. This string is going to hold my eventual answer, I guess you could say, given the variable name. But yeah, I'm going to have a string that has consecutive duplication, and we're going to remove consecutive duplication from it. Yeah, I was going to put an example up, but nah, screw that. Okay. I'm going to get a string that the words are going to be separated by spaces. So I'm going to split that string into an array so that I can process word by word and find the consecutive duplicates that way. So I'm going to call split, and yeah, the split function is a good function to use in Java, also available in Python, but it is going to take a string and separate the string into an array of strings based on a delimiter, a separation character. That separation character here is going to be a space as specified in the parentheses. Now that I have my array of words, which is what str array is going to be, I'm going to loop through it and do my consecutive duplicate removal. Make this equal to, oh, I missed a step. So for my eventual, result string, or the ending string, I'm going to go ahead and put the first word from the original string into my new string, because there's no possibility of the first word being a consecutive duplicate because it is the first one. So I'm going to go ahead and drop that in there because there's no way it's going to be duplicated because it's the first in line. So go ahead and put that one in there with the space, because all the words in your final string are going to be separated by spaces. Back to the for loop on line 10. Gonna start it, and I'm starting it at 1 because of line 8. I already have one word processed, so I don't need to process index 0 again. Index 0 is done. I'm going to move on to index 1 for the rest of my processing. Start at index 1 and go to the end of my array. This being an array, I'm going to do length without parentheses. Okay, then for each, actually, not quite there yet. For each of the strings in the array, I need to make a decision. Is this string in the array, is it equal to the one before it? Because if it is equal to the word before it, it is a consecutive duplicate, and I will not copy to my new string. So I'm going to create a condition that says if this string is not equal to the previous, then I will do my copy concatenation. And I will copy a space afterwards, because these words are going to be separated by spaces. Word, space, word, space, word. Yeah. Going back to line 12, I use the not operator to say if this word is not equal to the previous word in the array, I'm going to go ahead and copy it to the new string because it is not a consecutive duplicate. If it is equal to the previous word, it's a consecutive duplicate, and I take no action. I just go to the next iteration of the loop. So here's the action. And go ahead and see that through. I'm going to have my non-consecutive duplicates copied to the new string or concatenated to the new string, and that's it. So I believe I can return, and I'm going to return the answer, but I'm going to trim it because there's going to be a space at the end because of the way that I'm copying or concatenating. I do word, space, word, space, word. There's going to be a space at the end. I'm going to trim it out because that extra space is going to cause it to fail in comparison to the assert statements. So let's try this one out. Did a slightly different version than I did before, so let me see if it works. I think it works. And I think that works. Impressive as it says. We are good on this one. So, kiddies, there is your solution to remove consecutive duplicates in Java. Code Wars. Keep coding, keep grinding. Things will get better. You will succeed, and I will too. I am out. Okay, here we are, folks, with what's a name in a Python exercise on good old Code Wars. How we doing today? Outstanding. I'm doing great. Terrific. As Brian Tracy says. What's in a name? All right, let's kind of fast forward to the real ish. Write a function taking two strings as parameters that tests whether or not the first string contains all the letters in the second string in order. Notice I'm doing my own translation for the subpar grammar that's in some of these. So yeah, you're going to take in two strings as parameters or arguments, or depending on the order of whatever. Okay, going to take in those two, and the test is going to be whether the first string contains all the letters of the second string in order. In order is a really important part and the toughest part of this exercise, making sure they are in order. The function will return true if that's the case. It's going to return false otherwise. Letter comparison should be case insensitive, so we'll probably just convert to all the same case to do our stuff, whatever that stuff may be. All right, examples. Across the rivers, Chris. These are your two arguments for this one. So we're going to look for the letters of Chris in across the rivers. And they've got to be in order. So the first one of the letters we find has to be a C, then an H, then an R, then an I, then an S. So looking at here, C, yeah, it's first to be found. H, R, I, S. So they're all in order. And in order is the key part. And again, the hardest part of this exercise, I think. Here's another example. Next to a lake in Chris. It's false because none of the letters in Chris are even in this string. So that's an easier determination. Moving down. We'll look at one more here. I don't want to take up too much time. I'll be late for an important date. Got to keep working, y'all. Dollar bill. Okay. Under C in Chris, It's false, because really you got to look for the C first, and you don't even see the letter C in under a C. So right off the bat it's false, because you don't even need to look for the other letters, because you got to find the C first, and it's got to be first in order. So you don't find the C, it's a no-go, my friends. Okay, so we got this. It's search for the letters of the second string and the first. They must be in order. Let's launch into it. Hit that training interface and let's go, go, go. And I'll expand this out as I've been doing lately. Here's the code. I'm going to create an integer. This is really going to be my marker for my starting point in the string on the left side. Whatever the hell that means. I want to grab one of these, I think. Yeah. This is going to help me illustrate a little bit. Okay, the idea is to look for Chris and across the rivers. Well, as I get further into this string on the left, I need to create like a marker. Like how it's going to be is I'm going to look for the letters from Chris in order. So let's say I find the C. Once I find the C, for the next search for the H, my starting point is going to be one past the C for the rest of the string. There's no reason to look back here anymore. Once I found the C, my next starting point is going to be this R, and I'm going to look forward for the H. Start is going to give me the location in the string to look forward from. That is the purpose of that. And because of the case insensitivity, I'm going to take the string on the left and make it lowercase. And then I'm going to compose a for loop, range loop, and I'm going to loop through the name, because I want to go character by character and find each character in my longer string on the left in order. So I've got to go I'm going to go in the order of the characters of the second string and find them in order in the first. So I'm looping through the name, and I'm going to get the location of the string. I'm going to get the location of the letter in the first string. I'm going to put it into this variable called loc. And I'm going to try to find the current letter from the name. I'm going to do my lowercasing. Alright, so what I got here is I'm running the find function on the left side, the longer string on the left, and I'm trying to find the letter starting at start. And on the first iteration, start is going to be 0, but as I find letters, start will move up through this string. And if I do find the index of the next letter in my longer string, then I'm going to change my start point to where I found the last letter plus 1. Because again, like in the case of the C, once I find the C, I want my starting point to be the R going forward. So this line is really what's where that takes place. I found my C, then I'm going to go the next index forward. And then as I loop, start has been updated. So now start is no longer 0. It's where I found the C plus 1. Plus 1. Sounds great, doesn't it? All right. And if loc is -1, I'm getting out of here because I have not found a letter or a letter from my name. So, adios. It's like, yeah, I'm going to keep going and continue to find them in order. But once I don't find a letter from the name, I am out because that breaks the whatever. And if I go all the way through and I find all the letters, meaning, I don't exit, I return true. And that's it. Let's run this one through. Run. That's good. And that's good. Correctamundo. Hype. Let's go. Keep it moving. All right. Alrighty, folks. That is it for me. Continue to make yourselves toward that ideal of being undeniable, and I'll do the same. And with that one, I am out. What's a name in Python? Okay, microphone check 1 2. What is this? Back with a Code Wars exercise. Probably tired of hearing this ish, but yeah, Code Wars exercise, unique string characters, Python. Yeah, let's go. And with this one, you're going to be given 2 strings, A and B, and your task is going to be to return the characters that are not common in the 2 strings. My interpretation here is that, yeah, it is going to be, you're given 2 strings, you're returning the characters that are unique across both. So we have XYAB, XZCA, and the ones that are unique across are YBZC. Yeah, and really, this is the symmetric difference. If you're thinking about set notation, symmetric difference in terms of letters. Although for this exercise, you can't really do sets, at least I haven't found the way yet. But yeah, if you guys find a way to do it, feel free to let me know. But I tried to do it with sets and didn't work. I have to probably do some finagling. But anyway, you're getting a symmetric difference basically of the letters. That is what I believe here. Yeah, unique across. So yeah, let's get into it. And note to self, I gotta stop saying yeah all the time, among other things. Okay, so A and B are gonna be the 2 strings. So I need to find the things that are in A that aren't in B, and the things that are in B that are not in A. And looking at this thing, it says, notice that you return the characters from the first string concatenated with those from the second string. So you get the uniques from the first string first, then concatenate that with the uniques from the second string. So it must be in a certain order, which prevented me from doing it in the set format. Although I'm sure there's a way to do it. I don't want to take the time right now to figure it out. especially since I'm on a video with y'all. I don't want to turn this into a 30-minute video. Keep it short. These are already long enough, right? Okay. I'm going to create a string to put all of my unique letters or characters into. I'll call it a new string. Very inventive. Okay. Then I'm going to loop through I wonder if I even need to do range. I don't think so. I'm going to do a for each loop, actually. Using the not in notation allows you to see if something is not in something else. So it is very convenient in Python that we have this really easy search notation with the in keyword and then using not with it. And very simply, I'm going to determine if this character is not in the string B. And if it's not in there, I want to add it to my new string via concatenation. And then I'm going to do the same thing for B. For letter in B, if LTR are not in A, yeah, two separate, I'm doing two separate loops because you want to capture all from the first, then all from the second. You could intersperse them, but then it would fail the test because they must be in a certain order. I'll just return the new string at the conclusion. That should be that. Test it up. That works. And that works. Impressive, maybe fairly impressive, but yeah, this one is pretty straightforward, y'all. I'm sure you're seeing that on your end. Yeah, so do it better. There are one-liners you can do. I kind of tried to do it and it kind of got screwed up. Didn't want to take the time to figure it out, so I'm here with this more simpler solution. Yeah. All right, that's it for me. I'm out of here, and I'm gonna see y'all later if you don't see me first. All right, the language is C++. This is a code words exercise, and it's called sum to length. Drum roll, please. Yeah. Or no, sum and length. I don't think I said that. Anyway, C++. I was in a trance, folks. I don't know. Sum and length. In this one, you're going to return a string value, where the first part of the sum, the first part is the sum of positive numbers, and the second part is the number of negative numbers. Knowing that the first 0 is negative, second is positive, third is negative, and so on. A little explanation is in order here. So we're going to return a string where one part of it will be the sum of all the positive numbers. Second part is the number of negative numbers. Important, not the sum, the number, like the count of negative numbers. So we got a sum and a number, a count. That accounts for the two numbers. And then there's a special rule of 0 here. And yeah, not really explained well, but it's kind of par for the course with a lot of these. It's kind of the way it is, but we need to rely on our guile to figure things out. So first O is negative, second is positive, third is negative, and so on. So the O's or the zeros really go to the count of negative. For the sum of positive, they don't mean anything because, plus 0 doesn't mean anything, but they count as a negative number. So I didn't really explain it before I got into this. The polarity of 0 alternates. The positivity or negativity of 0 alternates. So it begins as a negative, so it counts with the number of negatives. Then the second time 0 appears, if it does, it's positive, so it will go into the sum, and then it flips back to negative. So its type of value changes. I don't kind of know what the term is there, but it don't matter. Y'all know what I mean. And if you don't, so what? All right. Looking at here, in C++, you're going to get a vector of integers. There's your vector, and then return 10, 5, 10 space 5, because you add the positive numbers and you get the number of negative numbers. 3 is one, 2 is another, and the second 0 is another one. That's where the 0 comes into play. The second 0 is counted as a negative. All right, let's get in here and do this. My intros, I think, take a little too long. I'm watching myself here. All right. I think I say all right too much. I'm going to be getting a sum of the positives and the count of the negatives, so I'm going to create variables for each. Perhaps those numbers are these variables are self-explanatory, or the variable names. I'll get it out eventually, folks. Okay. And because the zeros will alternate, and I think the word is polarity, they're going to change negative to negative in an alternating fashion. A Boolean variable is very natural for this idea. And I'm going to start out as false because the zeros are, they start as negative, I believe, first. So, all right, now for the fun, I'm going to loop through my vector using size t, as it is an unsigned integer typically used for looping iteration scenarios in Pewter. That's what happens when you talk while you're typing. The name of the vector is input, as you see up here in the header. All right, so as I loop through this vector, I'm going to get a sum of the positives, a count of the negatives, and if 0 is a negative, I'm going to add it to the count of negatives. All right, if this element is greater than 0, means it's positive, I will add it to my sum of the positives. So yeah, I've got to add the value to my sum. That's how you do summing, of course. Do an else if the input is less than 0, meaning it is negative. I will increase my count of negative numbers. Let's go plus 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 1. Else, we got a 0, and in the case of a 0, I will well, actually, I got to check the zeros polarity. I hope that's the right word, because I'm locked into that one for this one. So if the 0 is false, I'm going to say it's a negative, and what I will do is count negative, because I'm going to add to the count of zeros. And if it's a positive, I'm not doing anything. But every time I encounter a 0, I'm going to flip the Boolean value. And yeah, if you don't know, if you want to just, with the Boolean value, change true to false, false to true, whatever it comes in as, it'll come out as the reverse. This is your notation for that. Variable equals not variable. 0 equals not 0. Alrighty. Now once we got that stuff done, we can then return the string, because I have both of my counts all good. Now I'm going to take those counts, put them into a string, return that sucker. So create a standard string, the beautiful prefix, and actually, let's do this. That's not right. This is a function or a method. Not even sure what to call it in this context. Our C++ functions that are in that are members of objects, are they called methods or functions? I know the answer in Java, but I forget in C++. They might be member functions. All right, so I'm going to convert the sum to a string, concatenate a space, then convert the count of the negatives to a string using the handy toString function. Yeah. Let's run it. Pass. Impressive. Passes. Let's take a look. Whoa, those are the tests. Don't want to look at that. Don't want to look at that again. Screwed that up. There's your code, my friends. Sum and length, I think it is. Code Wars, C++. I'm out. Okay, we're looking at special number from Code Wars, a C++ exercise. Yes. Getting in here, a special number. A number is a special number if its digits only consist of 0, 1, 2, 3, 4, or 5. So only those digits in the number that constitutes a special number in this case. Probably not a scientific definition, but whatever. It's a Code Wars definition. The number passed in is going to be positive. And all single-digit numbers from 1 to 5 are considered special numbers. And this should actually be inclusive. So I'd assume 0 should be in there too. But anyway, whatever. I'm not going to attack the rules. So, if you have a special number, you're going to return special. If it is not a special number, you return not. So, 2 is, 9 is not, 2, 3 is, 3, 9 is not because of the inclusion of the 9, 5, 9 is not because of the inclusion of the 9, 5, 13 is special, 7, 0, 9 is not. So, each digit, it's got to be 0 through 5. That is your guideline, or my guideline, as I start this right now. I don't know why I'm laughing, like halfway out of breath. I'm not as used to speaking today. Something's going on here. Whatever. Okay, so we take in an integer, and then we determine if it's special by are all of the digits 0 through 5. So, of course, we got to get the value of each digit. So to get the value of each digit, we can do a modulo to get the value of each digit, because for those of you who don't know, when you do a modulo 10 is going to give you the single digit in the ones place, and you can use that to isolate digits, where you do modulo 10, then divide by 10, because divide by 10 is going to take that number from the ones place and remove it from the number. So I'm going to take every single number, every single digit actually, in the number, and see if it's 0 through 5. If it is not, it is not a special number. If all those numbers are 0 through 5, we got a special number, my friends. Special, special. Okay, so setting up the while loop, the condition is going to be while number is greater, if number is not equal to 0. Really what I'm going to do is I'm going to break this number down until it is 0. So then the loop will exit. Alright, so what I'm going to do here is I'm going to do number modulo 10, giving me the number in the ones place, and I'm going to say if that digit is greater than 5, we found that we do not have a special number. And there you go. That's what you do, and I don't know why I got the semicolon. That's what you do when you have not a special number. But if we go forward, we want to take that number from the ones place and remove it from our, take the digit from the ones place and remove it from our number. And the division is going to do that, and actually got to do the, I thought I was in Python for a minute, and actually, yeah, I'm kind of flipping out between languages. I do need the semicolon because this is C++. Wow, I had a moment there. It's too much going in between languages. I actually thought I was in Python for a minute. Wow. Okay, so the division happens removing the next digit, and then it goes with a smaller set of digits each time through the loop. And if I get all the way through this loop and I do not return not, then we have a special number. Because if all of the digits are special, meaning they're 0 through 5, then we got our special number. And we will christen it special. There we go. I think that's it. Let us run it. Looks good there. Looks good there. Very, very good. Okay. Great, great. There's your solution to special number. Looks pretty, folks. Yes. So isolate the digits with modulo 10, and then remove each digit at the end with division by 10, and check each one to see if it's special. But I know one thing, you're special and I'm special too, and it's time for us to part ways as friends. So that's it. See y'all later. All right, testing 1 2 3 1 2. Can you hear me okay? I think you can. And today I'm going to look at an original exercise that I wrote a couple of years ago called Redemption Center Empties. And this is not a Code Wars exercise. This is an exercise created by me, and it is going to be done in Python. And of course, I've got a little write-up for my exercise. But let me set the stage for y'all for this exercise. I live in Maine, and in Maine there's a hell of a lot of drunks. And in Maine we have mandatory recycling where bottles, cans, and the like, you give them to recycling centers called redemption centers, and you get a small amount of money back for bottles, cans, and such. So 5 cents, 10 cents, 15 cents, blah blah blah. So alcoholics, they're going to consume from these containers, and they will produce a lot of empty containers. So there's kind of a cycle that goes, you buy up a bunch of stuff, you drink it, you got empties, you take the empties to the redemption or recycling center, then you get your little bit of money, and then you go buy more drink, and then the cycle goes and goes, So it's just like a thing here where you got a lot of alcoholic dudes, they buy up their stuff, they drink it, take their empties to the redemption center, and then they use that money to get more stuff, more drink. All right, so there's the stage. Now, this exercise follows our friend Jimmy the alcoholic, and he's got a little dilemma that we're going to solve with code. We're going to use our coding skills, our Python coding skills, to help out the homie Jimmy to buy more beer. All right. Yeah, Jimmy the alcoholic needs more beer, but all he's got are empties. Remember, those are the empty bottles and cans and such that, from his drinking. Okay. not enough stalling, man. Okay. He will gather and count the empties, but he needs you to write a script to determine how much money he can get from them. So yeah, he needs your help. His brain is too wrapped from the drinking. He can't do this code himself. He used to code with you, but he stopped. Once you determine how much money he will get, you will then determine how many 18 packs of Bud that Jimmy can get. So he's got his stuff, and he's got his counts. Somehow he got them counted up. He's going to give you the counts, and then you're going to determine how much money he can get so he can go and buy a little bit more. The distribution of the empties will be stored in a dictionary with the following keys. The keys will be liquor, regular beer, and 22-ounce beer. So the types and the counts of those types of empties, they're going to come in a Python dictionary, and the keys are liquor, regular beer, and 22-ounce beer. The Redemption Center pays the following rates: 15 cents for liquor empties, 5 cents for regular beer, 10 cents for 22-ounce beers, and there you go. So 15, 5, and 10 for the different types. And you see up here, you remember you got the keys. So the keys are going to give you the types. Or, yeah, that's right. So our buddy Jimmy is going to provide the dictionary with the counts of the various empties. You're going to provide him with the total money he's going to get, along with the number of 18 packs he can buy. So, yeah, he's going to supply you with the dictionary with the types and the counts. We're going to produce a function that is going to return the total money that he's going to receive from the Redemption Center, and then the total number of 18 packs that he can buy, because yeah, the eventual reward is he's going to buy 18 packs with this. You will return a list with 2 elements. Element 0 of that list is going to be the total amount of money as a float, data type. Element 1 will be the number of 18 packs that can be purchased as an integer. And the last note, 18 packs cost $16.99. Of course, you got to know how much the 18 packs cost so you can determine how many he can get. And if you don't know, yeah, 18 packs are 18 cans of Budweiser beer. That's what I mean by 18 packs of Bud. I kind of glossed over that, but I figure most of you can kind of figure out what that is, yeah. Alrighty, let's look at some example inputs and outputs down here. If we have a function called redemption, and the input is this dictionary right here, dictionary liquor 16, regular beer 180, 22 ounce 30, it's going to return 14.4 and 0. And 14.4 would be the total money he's getting from these counts. 0 is the number of 18 packs he can buy, because 14.4 is less than 16.99. So of course you can get 0 18 packs for 14.40. So no beer for Jimmy. He's asked out. Maybe he can get some 22s or something like that to tide him over. The next example, you look at these counts: 200, 587, 200. Consumed quite a bit, and that returns 79.35, and he gets 4 18 packs. Next one, 123, 437, 149, returns 55, about 55.20, and he can get 3. So your input is going to be a dictionary of types and quantities, and the output is going to be a 2-element list. First element is the total amount of money you get. Second element is the number of 18 packs that Jimmy can get. All right, so I'm going to show you the code that I composed for this right now, and I'm simply going to show you the completed code because, well, doesn't matter why. I'm just going to do it. I don't need to explain myself all the damn time, right? Yeah. I'll do it full screen first. So to recap, we're getting a dictionary with the keys will be the type of empty. The value will be the quantity of those empties. We got to total them all up, and we got to determine how much money we're going to get for each and total that up. So looking at the function that I composed, empties will be the dictionary that comes in. Total money is, of course, it's a float variable that's going to hold the total amount of money that we're going to get from totaling up the cash from the empties. I do a for loop, and I'm looping through the dictionary. Empties is the dictionary. This is a for each loop where I'm looping through the dictionary empties. And types will be a key in this case. And if the key equals liquor, I'm going to add the value, because empties index types is the value times 0.15. Remember I said 15 cents for liquor empties. So let's zoom down here real quick and look at this key value pair. Liquor, the key, value 123. When I index in here with types into empties, on this first, for this condition, I'm going to get a 123. 123 times 0.15 will give me 123 at 15 cents each. And I'll get some kind of, I don't know what the answer is, but I'll get that answer. That answer is going to be added to total money, and there we go. 123 times 15 cents per. That's how the totaling up is going to be done. You index in using the key, you get the value. The value is going to be the count of the empty. You do the empty times the amount of money you get from the redemption center. There we go. And so we have an elif, and actually this if is not correct. This should be another elif, actually. Let me correct that one real quick. Yeah, sometimes you find little mistakes in your code. I don't know why that's like that. Because this is exclusive. We're only doing one type per iteration. There's only going to be one key per iteration. So yeah. So yeah, regular beer will be times 5 cents, 22 ounce, times 10 cents. And yeah, good to go. So as you continue your iterations, you're going to get through all of these keys, and you do the totaling up. And so once the loop is done, I'm going to have my total money all calculated, and it'll be in a float. The next piece is how many 18 packs can Jimmy buy? Well, when you have a total, if you want to determine how many of a certain thing can be bought, you would take that total and divide it by the cost of said thing. So on line 12, I create a variable called packs 18, and I take my total money divided by $16.99. $16.99 is the cost of an 18 pack. So taking my total money divided by the cost of the 18 pack will give me the total number of 18 packs that can be bought. And it'll be stored in packs 18. And what I do is I take that the result of the division, and I convert it to an integer, because you can't buy part of an 18 pack. So I want a whole number generated from this. So if it's like 3.3, I cannot buy 0.3 of an 18 pack. I can only buy 3 total. So you just, yeah, I've explained enough. Line 14, I return a list, and I return a list in this format. Index 0 is the total money that I generate from all the bottles and cans. Index 1 is going to be the number of 18 packs gotten on line 12. There it is, kiddos. And let me take some sample runs of this mother trucker. Okay. You thought I was going to say something else, didn't you? All right, so we got 2 dictionaries here, and I'm already set up to run the August dictionary. So, and I believe both of these are correspond to the examples that I've already set up. So let's take a look over here. Let's contract this. Yeah, the August one, this August dictionary, I believe corresponds to this one right here. Okay, so I should get 555.19 and 3 when I run this one right here. So let me go ahead and run that. These results are time tested over years of study in the lab. Hit that run. Okay, we see 55.20 and 3. Yep, got that. This other one, this January, will correspond to this result right here. So it should return 79.35 and 4. Clear it out. All right. So to run that, of course, I've got to replace. Let's hit that run. All right. We see 79.35 and 4. All right. So we got a good situation here. It works. And of course it works, because, yeah, I don't need to explain that. All right. So here we are with redemption center empties, and we've cracked the code. We found how we can calculate the cost of Jimmy's empties and be able to get him a result of how much money he's going to get and the number of 18 packs he can buy, so he can be on his way. We can help out our friend, and we can be a good buddy. And we did a little bit of code. So this is a win-win situation where you help out a friend and you can practice your Python skills. All right, folks, this is it. Redemption Center empties, an original exercise from me. And yeah, my name is Dean, but that don't matter. What matters is you saw some cool code, and that is it for me. And I am out. Hello, hello, hello. Looking at reversing fun, a Python exercise from Code Wars. Here we go, folks. And you're going to be given a string. Your job is to return that string in a certain order that I will explain below. Let's say you start with this, 0, 1, 2, 3, 4, 5. Notice that this is a string of integers, or I guess a string of numbers, because, yeah, I don't need to explain that. Okay, yeah, the first thing you do is reverse it. You see the 0, 1, 2, 3, 4, 5 is reversed right there. Then you will take the string from the first position and reverse it again. What that line really means is that the first digit remains fixed, and you reverse the rest of the digits in the string. So step 1 was reversing the whole thing. Step 2 is reversing the whole thing except for the first digit. Notice the 5 stays in place. Then you will take the string from the second position and reverse it. So what that means is now we have the first 2 digits are going to be fixed, and then the rest are reversed. Notice that 1, 2, 3, 4 becomes 4, 3, 2, 1. So the last 4 are reversed. Then on the next iteration, then you will take the string from the third position and reverse it again. So now we have a fixed portion of 504, and the 3, 2, 1 becomes 1, 2, 3. Generally, the fixed portion is going to become larger from the left, and then the reversed portion is going to become smaller from the right until there is nothing left to reverse. When there is nothing left to reverse, the job is over and you return that string. Continue this pattern until you have done every single position, and you will return the string you have created. For this example that we just looked at, that was provided, the final string is 504,132. You can't reverse anymore, and yeah, everything became fixed. Now getting into the code, let us do that. Training again. Okay. I'm going to be using a while loop, so I'm going to start my I at 0, my iteration variable, and we are going to be reversing, and a portion is going to be fixed, and it's going to get larger as we go through. I'm going to loop while I is less than the length of n minus 1. N is the string of digits, and I'm looping until n minus until the length of n minus 1, because I'm going to stop at, I'm really going to stop at the length minus 2, one less than the last element, because there's no reason for me to iterate to the last element, because there's nothing left to reverse. Really, I'm using I as my reversal boundary, where everything behind I is fixed. Everything in front of I is reversed. Kind of like this. Let's say, for instance, we do a 5, 4, 3, 2, 1. Let's say I start the routine with this, and I start my I at index 0, which is 5. On this iteration, the 5 will stay fixed and everything else is reversed to the right. So the result after this would be 5, 1, 2, 3, 4. Then I is going to move to the right, because of course I will increase. So now I is here, and the fixed portion is 5 and 1. So then I would be 5, 1, 4, 3, 2, because the last 3 will reverse. Then I will move forward once more, and then the first 3 are fixed, and the last 2 get reversed. And the result there is 5, 1, 4 remain, and then 2, 3, the reversal. Then I comes here, and I is going to stop here because the 3 by itself cannot be reversed. And this is why I have the length of n minus 1 as my limit, or actually while it's less than that, because here I is at the length minus 2, and this is where it needs to stop because there's no more reversal possible. All right. Get rid of that pass. And digging in here, I'm going to change n over and over again. And I'm going to do it like this. So what you see here, this is a concatenation, and I'm concatenating portions of the string. This is going to be my fixed portion. And the concatenation to the right is going to be my reverse portion. I is going to continue to increase, so these slices are going to change, of course. The slice on the left is going to get larger. The slice on the right is going to get smaller as we go. Looking at the slice on the right, we're going from the beginning of the string to I. The slice on the left is starting at I and going to the end of the string. So you know, the right side. And this portion of indexing after the slice, this is reversal notation, where you use this notation with a string, it is going to reverse the string. So really, I'm taking this string and reversing it with this this ladder indexing, you can call it. So the rest of the string reversed. That's how you can read it, where you're going from I to the end and then reversing it. And again, I is going to get larger, so the concatenation on the left will get larger. The concatenation on the right will get smaller as we increase I. It's going to slide to the right, slide to the left, like the cha-cha slide or something. Anybody know about that? Anyway, don't speak on what I don't know about, right? So, of course, I is going to increase, so you're going to do I plus equals 1 to move it forward, and there you go. And that's really it. Once this is done, it's going to, your string is going to be as it should be. Line 4 is really the driver, where for each iteration, your strings are going to be transformed into the next fixed reversal portion. And I'm going to return N, because N is the string that continually gets redone and transformed. And that's it, kiddos. Let's check out, see what the damage is. Run it. Riggedy, riggedy, run it. Got that. That's good. And we got that. Impressive. Totally, totally. All right, homies. That is it for reversing fun from Code War as a Python exercise. I don't remember how I said all those things in the beginning, but I'm saying them now. Glad you made it to the end of the video. If you did, if you didn't, I can talk about you because you're not even watching right now. Anyway, that's it for me. I am out. Hello and welcome back. And today, or right now, looking at speed limit, a Python exercise from Code Wars. Absolutely. The police, the Popo, have placed radars that will detect those vehicles that exceed the speed limit on that road. If the driver's speed is 10 km per hour and 19 above the speed limit, the fine will be $100. If it is exceeded by 20 to 29, the fine will be $250. And if it is exceeded by 30 or more, or actually it says exceeded by more than 30, the fine will be 500 smackaroonies. Okay. You're going to be provided with the speed limits of the roads, of those roads, with radar as a collection of speed limits. Well, this is a list of integers, of course, and they're going to specify the speed limits to translate it correctly. These are going to be the speed limits in this list. And moving down, scroll. And the speed of the driver will be the same on all the roads and can never be negative. And I don't even understand the last sentence. Yeah, I'll just explain it in my own terms. Yeah, we get a lot of these that are just like, the explanations are just not that good and not explained well. Anyway, don't mean to bag on these dudes. All right. You're going to get, there's going to be two arguments, speed and signals. Speed will be the driver's speed. Signals will be the different speed limits on the roads, even though I think it talks about one road in the first paragraph. Okay, speed limits on all the roads. The objective is to total up the fine. So if we look at speed 100 and the limits of 110 and 180, we see like we compare 100 to 110. Does it exceed the speed limit? It does not. So there's no fine there. 100 to 100, there's no fine there because it doesn't exceed the speed limit. And then you go over to 80. 80, there is a fine because you are 20 over the speed limit. The big 20. 180. 100 minus 80 is 20, I think. And so you look up here to your kind of chart here. If it's 20 to 29, the fine will be 250. Thus, the overall is 250. So you just accumulate the fines according to how much over the speed limit this individual is, and the fines according to that. That's it. Pretty straightforward. So, diving in, as we always do about this time. I'm going to get speed and signal. So the speed, yeah. First, I'm going to make the fine equal to 0 because I'm going to total up the fine. Of course, it's going to start at 0 and I will accumulate it. And what I devised is looping through the speed limits on the roads. And for each speed limit, comparing it to the driver speed to see if the driver speed exceeds it. If it does exceed it, then the fine will be assessed. So I'll set it up like this. Slurring my words, homie. Okay. I have not been drinking. Just water. So limit is going to be each speed limit, and I'm going to compare each speed limit to the speed that this individual is going at. And I'm going to say, if their speed minus the limit is, for the first one, greater than or equal to 10 and less than or equal to 19, which is the first range, then I'm going to assess a fine of 100 smackaronis. It's interesting that, well, I'm not going to say anything about the country that this thing is originated in. I'll leave that. Okay. And we do an elif. And this is wrong. Mistyped. And then the next is going to be 20. That's kind of the next thing of the next thing of the thing, right? Very specific. And that range I have is wrong on the first, so change it up. So greater than or equal to 20. So you probably see what's going on here. I'm just making ranges and then assessing the fine based on the range. So this one is pretty simple. But I guess it is good conditional practice. I think I will use this in one of my courses actually. I have a unit coming up on conditional logic, and this is a good one for my conditional, or I'll stop. It's rambling. All right, 100, 250, 500. Got all the fines. That's good. I'm just going to return the fine because it will have been totaled up, and that is good. All right. I think I said all right too much. I've said that in other videos. And what do we got here? Aha. Semicolon. Great. And so interestingly, it said great here. That's dope. It says a few different things like, well, impressive and excellent and all this stuff, and just happened to say great when I said great. That's cool. Okay, well, here we are with this one. It is, what's the name of this thing? I just picked this one out. Yeah, speed limit, Code Wars, and man, I just killed my solution. Anyway. Well, I can look here. I can show you. There you go. Here's that solution. So I like to show the solution at the end to y'all. There you go. There's the beautiful solution, and goodbye, you beautiful people. And this beautiful person is out. See y'all later. Okay, welcome back. And today, looking at duplicate arguments, a Python exercise from codewars.com. Let's dive in here. First, complete the solution so that it returns true if it contains any duplicate argument values. Any number of arguments may be passed into the function. Array values passed in will only be strings or numbers. The only valid return values are true and false. So this is, you return a Boolean value, true or false, if it contains duplicate argument values. And the kicker is that it's going to supply a variable number of arguments. So you need to be able to handle that. In Python, there's a certain notation where you can handle a varied number of arguments. And generally in programming, it's called a variable argument list. I don't remember what it's called in Python, but I'll show you the notation when we get into it. But yeah, so handle a variable number of arguments and then determine if there are any duplicates. It actually ends up being pretty easy once you implement the variable argument list syntax. And what it does, it will put the arguments into a data structure, and you can simply go through the data structure and look for duplication. So that is what we'll do. Let's get in here. All right. There's that word again. All right. So here's the variable number of arguments notation. It is the asterisk, and then I'll just call it args. And what it'll do is any number of arguments are going to go into args, and it'll be a data structure, kind of like a list. So you can loop through this thing. And I'll loop through it. And what I'm supposed to do is to determine if there's duplication in the arguments. So I loop through this argument list, and if there are any duplicates, I return true. If there are no duplicates, I return false. So how do you find duplicates? I'm just going to, for each one, I'm going to see if the count of that one is greater than or equal to 2. There you go. Yeah, so I go through, and if this argument has a count greater than 2 in the set of arguments, then I'm going to return true. And if I get all the way through and I don't have one that has greater than or equal to 2 occurrences, I return false because there is no duplication. And that is it, my friends. There is not much more to this. You handle the variable number of arguments here. Then you loop through those arguments and determine duplication by using the Python count function. So let's run it through. Looks good there, and it is correct. Okay. I'm going to submit now. Well, actually, I'm going to submit because I've already done this one. So no need to do it there. There's your solution, kiddos. What's the name of this one? Duplicate arguments. No. And I washed away my code. Good stuff. I did it again. There's your code, or the code. Variable number of arguments, count, good. All right. Enough rambling. That's it for me. I'm out. Have a good one. See y'all next time. Hello. Now we're looking at invert a hash, a code wars exercise using Python. Yes, inverting a hash. What the heck is a hash? In this case, a hash is a Python dictionary. I believe a hash is a more generic computer science term. Yeah. So given a hash made up of keys and values, invert the hash by swapping them. So we look at this dictionary here, A1, B2, C3, got keys and values, and you return the inverted version where the values become the keys and the keys become the values. So really, yes, you're swapping the keys and values in the dictionary. Look down further,
the classic foo bar hello world. And you see on the return, they are reversed. So that is the objective here. Reversed keys and values. And a few rules. Really, this is all we got to worry about. Not that you have to worry about anything, but reversing keys and values. Let's get in here and do this thing. Nothing more to say. This is a short, simple idea. So dictionary will be the dictionary. And so what I will do is I'll create a return dictionary. And I'm going to loop through the original. And I'm going to use the zip function in Python. What I'm doing here is the zip function allows you to take two or more data structures, and as you loop, you're going to pull out corresponding pairs from these data structures. Basically, data structures, elements of the data structures that are together at corresponding places. Here I'm getting the keys in a data structure and the values in a data structure via these two functions. And I'm using zip to pull them at the corresponding indexes. So basically, even though dictionaries aren't really ordered, they do come in some order when you do this. So like key 0 and value 0 are going to come out together. Key 1, value 1 are going to come out together. And how it works is that each is going to be placed in K and V for each iteration. So on iteration number 0, I guess you could say, K will be the first key and V will be the first value. So I've got my keys and values together, and I could just swap them because I know what they are. They're in K and V, and in my new dictionary, in the body, I can simply do this, where I can make the value the key and the key the value. This is a dictionary notation where you create an entry by indexing in using the key. I'm going to make the key the value and the value the key. I do that for each iteration, and that's it. I'm done. And I will simply return the dictionary. That is it. I think. Yeah, that is it. Felt like there was something missing, but there ain't nothing missing. That's proper English, ain't it? All right, outstanding. So now that I got that, I'm going to show you guys a different version, because you can also do this with dictionary comprehension, which is where you can create and populate a dictionary on a single line. So I'll expand this again. And so yeah, you got this solution. Nearly one line, but you can also switch it up here. Cut. And you can simply do this. Whoops. And I don't even need a variable assignment. Just return. Looks good. Yeah. So for loop header is the same. I use zip to get keys and value pairs together. And then for each turn, I'm going to add the pair VK, V being the key, K being the value. And there's my dictionary comprehension version, narrowing it down to a single line. Run that just to be sure. And that passes as well. Great. Sounds good. So that is it. Got two versions of inverting a hash and Code Wars. And with that, buddies, I am out of here. See ya. Okay, 1, 2, 3, 3, 2, 1. We're back again with another Code Wars exercise in Python called Sum to Total. Given a list of numbers, repeatedly sum adjacent pairs of numbers until only one number remains. So you're going to be given a list of numbers, and it says repeatedly sum the adjacent pairs until only one number remains. Now looking in here, let's go scroll down. The scrolling isn't working. All right, what's going on here? Come on, man. Weird, the scroll isn't working. So I'll have to refresh. Technical weirdness, my people. Okay, now it works. All right. If the list is 1, 2, 3, 4, 5, the first step would be, see, we are summing adjacent pairs. So we're going to sum 1 plus 2, 2 plus 3, 3 plus 4, 4 plus 5. And what you do, it doesn't really say this, you are going to generate another list of the pairs. So if you start out here, 1 plus 2 is 3, 2 plus 3, 5, 3, 4, 7, and 4 plus 5 is 9. So after this first pass, you're going to have 3, 5, 7, 9. And that'll be the result of all 4 of these additions. So that's what you produce on your first pass. And it says repeatedly sum until only one number remains. So once you get this, you're going to go in again and sum the next set of pairs. So moving down here, take the results from the first step and repeat the process of adding adjacent pairs. So now you have 3, 5, 7, 9, and you do, I'll just go through this again. You have 3, 5, 7, 9, and that produces 3 plus 5, 5, 7, and 7, 9. You've now produced this new list of 8, 12, and 16. And then it says continue this process until only one number remains. Now you have 8, 12, 16. You do your adjacent pairs. You got 20 of those two, and then 28. That leaves you with 2. And then, of course, you sum those 2 and you get 48. And you can see if you scroll down, or if I scroll down, because I'm doing the scrolling down here, you get 48 at the end. But that is what you do. You're starting with a list, you sum the adjacent pairs, get a new list, and then from that list you sum the adjacent pairs again, get another list. You do this process over and over again until it boils down to a one element list or one number. Yeah. And there you go. And if you come down, oh yeah, there's a couple other ones, but there's no breakdown. I'm just going to get into the code, god damn it. Let's go. I'm going to train again. So, ARR is going to contain a list. And one thing to know is if the list only contains one number already, I'm just going to go ahead and return it because I don't have any summation to do. There's no adjacent pairs to add. So if the length is 1, I am done. Yeah, if it's done, if it's 1, it's done. There you go. And then, so if it is more than 1, then I'm going to loop through and sum my adjacent pairs. And I'm not only going to sum the adjacent pairs, I've got to do it over and over again. I've got to get my next set of sums, do it again, get my next set of sums, do it again, until I only have one number remaining. So this is going to be a nested situation because I need to have an inner loop where I generate my list of sums, and then the outer loop that says, while this list of sums has 2 or greater numbers in it, I'm going to keep looping. So really, if the length of the list that I generate is not 1, I'm going to keep looping. So I'm going to do a while loop. The whiles allow you to customize the condition pretty damn well. I'm saying damn a lot today. But yeah, while the length is not 1 of this array, I'm going to keep getting my sums. And for brevity's sake, or to save a little bit of space, I'm going to do a list comprehension here, where I'm going to, I'll just let this play out and then I'll explain for my peoples, strictly for my peoples. Okay. All right, so we got a little list comprehension action going on here, and in this list comprehension, I'm doing my repeated adjacent sum list creation. That's what I'm doing here, creating a list. Creating the list. Can't say it right. Okay, so I'm going to loop through the list, and I'm starting at index 1 because I'm going to be looking at adjacent elements. So let's say my list is something like this. I start at element 1 so that I can sum 2 and 1. Then I can sum 3 and 2, and then 4 and 3. That's why I'm starting at element 1 and going to the end. And you see here in the body of my list comprehension, I'm going to get the sum of the previous element plus the current. So on the first iteration, it's going to be the 2 plus 1. And that sum is going to become an element of the list as per its location in this list comprehension. So my sums are going to be the elements of the new list. And I'm using ARR as the new list. So I'm using the old list ARR as the source, and then I'm putting it into a new list called ARR that comes from the source, which will be the summations of the adjacent elements. There we go. So ARR is going to be the new list every time, and then eventually it's going to get whittled down to 1, and then I'll just return element 0 of that list. So there you go, folks. And I need to, of course, return that sum, or no, return that element. There we go. And that's it. The list comprehension handles the repeated creation and summation and creation of the list. And then this outer list is going to loop until it's 1, until the length is 1. Yeah, having trouble connecting today, but I got the code. That's all good. So run. That looks good. And that looks good. Correctamundo. Here we go. All right. So there's your code, kiddies. This one is sum to total. And there's your solution. And now that we got a solution, that means it's time for me to break north. I am out. Okay, 1, 2, 3, welcome back. And today, looking at mirror, mirror on the wall, a Python exercise from Code Wars. And this title has me thinking of the old De La Soul song, Me, Myself, and I. Remember that? Mirror, mirror on the wall. Yeah, for some of you old heads out there. It's a great song. Anyway, and we love De La Soul up in here. Absolutely. One of the great groups in hip-hop. All right. Too long, didn't read. You get a list of integers, and you have to write a function mirror that returns the mirror or symmetric version of this list. The middle element is the greatest, then the next greatest on both sides, then the next greatest, and so on. The list will always consist of integers in the range of -1,000 to 1,000, vary in size between 0 and 10,000. It's a lot. Your function should not mutate the input array, means you don't change it. And this will be tested. Notice that the return list will always be of an odd size since there will always be a definitive middle element. All right, let's look at some examples here of what they be talking about. All right, so let's focus on these, well, actually maybe more than these two, these three maybe. Yeah. The objective here is you begin by getting the, well, looking over on the left, let's focus here. On the left, you got your input list of integers. And then you look on the right to see the solution. And what it is you start with the highest element, or the highest valued element from the original list. And then surrounding that highest element, you put the next highest element duplicated. Then moving outward even more, you get the next highest. So you get, you start with the highest valued element, and then you get the next highest in descending order surrounding that highest element, then the next and the next and the next. So looking at this one, you have a 2 and a 1. You start with the 2 in the middle. Then you duplicate the 1s on the outside, then you're done there because there's only 2 values. For the next one, 1, 3, and 2. You start with a 3 in the middle, then the next highest is a 2. You duplicate 2s on the outside. Next highest is 1, so you duplicate 1s on the outside. And you may be seeing the pattern now where you start with your highest valued element, and then in descending order, you take the next values and duplicate them on the outside. Notice the values after the highest one are duplicated. The highest value from your original list is not duplicated. It is singular, like this 3. Every other value as you add, they will be duplicated. So the next highest value 2, 2s are duplicated. Next highest value 1, the 1s are duplicated on the outside. Let's look at one more example here, and this will be a good example. This input with the negative numbers and the blah, blah, blah. Yeah, it's all about the blah, 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 folks, whatever that means. Looking at this list, the highest value is 42. So we start with the 42. And then we take, in descending order, the next highest and the next highest and the next highest. For each next highest, we duplicate them on the outside of what you have previously. The next highest value is 18 from this list. So we duplicate the 18s around the 42. I guess what you could say this creates some mirror, hence the name of the exercise. Next highest is 0. Duplicate zeros on the outside. 0, 0. Next highest, -8. -8. All right, I think you see where this is going. here's your solution right here. The only remaining thing is to add the negative 16 on the outside. But yeah, start with your highest value, then you duplicate the next highest on the outside, producing this interesting mirror image where like one side's a mirror image of the other side. And there you go. There's mirror, mirror. Now it's time for that code. Let's get it. Going into our awesome training interface. Let's take a look. Wonder if you guys can hear the birds outside. Got the window open. It's a good 14 degrees outside. Nice and balmy out here in the Great White North. First, I'm going to eliminate the thing of if you got an empty list, just return that list. I'm not going to do any stuff to it. Yeah. And because I want to get the highest value from this original list, and I want the values in order, because I'm going to be constructing a list with them in order, basically, this mirror list, I'm going to sort my input list. Whoops, there's sorted. So I've got my sorted copy now. And I'm going to create a list, really my destination list. This list mirror is where I'm going to be placing my final answer, basically, my mirrored image. And initially, I can go ahead and populate this list with the highest value because, as you saw in the little explanations, I'm going to put my highest value in the middle, and then I'm going to have subsequently, I guess, populated. I'm going to have the next highest in descending, then the next highest, and the next highest. But I already know the first thing in here can be my highest, so I'm going to get my highest value by doing max. So I'm going to go ahead and populate the list with that, and then I'm going to get the rest of the values. And I'm going to loop to do so. And that's not right. Looping through the sorted copy. All right, so looking at this list header right here. Whoa, how'd that happen? Too much going on. Looking at this not list header, looking at this loop header. What the hell am I saying? This loop header is going to go backwards through my sorted list. I'm going to start at the element at the length -2. This is going to be the second to last element that I'm starting at. It's because the last element is already taken care of here with the max, which is going to be the highest in the list because the list is going to be sorted. So I'm going to start at the second to last because I'm going to start with the second highest element from my sorted list, and I'm going to go backwards. As you see, this list or this loop is set up to go backwards through the list. And getting into the body here, what I'm going to do is for my subsequent highest values, I'm going to insert them before and after what I already have in my mirror list. And this is before and after. The insert 0 is going to place a value before, the append is going to place a value after. So let's say my mythical first value in the middle is 42, kind of like my last example. And then as I loop through the rest of the list, my actions in the body are going to be with my next value. The insert 0 is going to place it before. The append is going to place the value after. Remember, the next and the rest of the values are going to be duplicated on the outsides. And let's say my next value is a 7. It would be here and here. My next value is a 3. It's going to be here and here. Yeah, duplicated on the outside. The insert is the before. The append is the after. And that, folks, is pretty much it. That tells the tale. And once that's done, the whole thing is done. Mirror is going to hold the correct output. So yeah, it'll have the mirrored thing. So quite abruptly, that's it. I am going to run it and see what we got. As we see, it passes. And there we go. Good, 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 great. All right, good to great. There it is, folks. Got it for you. Here is Mirror, Mirror on the Wall. Go listen to that song. And yeah, this is it. Here's your solution. Check it out. Love it. Do it better. Let me know. Play something in the comments. But my time is up. So with that, folks, see y'all later. And I am out. All right, 1 2 3 1 2 3. We're back, bitches, and today we are checking out recursive replication, a Python exercise. What the hell was that? In Code Wars, from Code Wars. You need to design a recursive function called replicate, which will receive arguments, times, and number. The function should return an array, really a list, containing repetitions of the number argument. For instance, replicate 3 5 should return a list of 3 5s, as you see. If the times argument is negative, return an empty list. As tempting as it may seem, do not use loops to solve this problem. Yeah, this is a recursion problem. So you see the title up there, recursive replication. We have to use recursion to solve this one. I think this is the first recursion exercise I've done in my whole series, so this should be good. Yeah, so replicate 3 5. You get the number of times to replicate and then what you are replicating. So through recursion, we're going to build a list where we have the same value over and over again in a list, using recursion. All right, so there it is. Let's dive into it. Where yeah, you're going to add the same value to a list over and over again using recursion. So I don't think I need to say it a fourth or a fifth time. Let's just get into it. I'm going to use PyCharm for the composition. Just wanted to see if there's like another test case here. Yeah. I'm going to grab a couple of these test cases just because I'm going to be testing them in another environment. I might want to use them. I'm not sure yet which one I'm going to use, which ones I'm going to use. I'm muttering to myself on a damn YouTube video. How you like that? All right. Bring it over to PyCharm here. Yeah. The size is probably good enough. Okay. So, of course, in replication, you've got to create a base case. Like, in replication, you do the recursive case and the base case. The base case is the ending condition, like how does this recursion loop stop? The recursive case is the looping condition, where like
if this is present, we're going to keep doing the recursion. We're going to keep looping, whatever you want to call it. So I'm going to create the base case right now, and we're being asked to do something a certain number of times. So we're going to count down the times. We're going to reduce the time every time, times every time. So I'm going to say if the times is less than or equal to 0, then I'm going to return something. And what I'm going to return is an empty list, because you'll see with the recursive case, I'm building a what I'm doing here is I'm going to be really concatenating lists over and over again. I'm going to return a list at the end, an empty list at the end, to kind of tack that on to the end to finish the concatenation, basically. Because whatever I return is going to be concatenated. Of course, you don't see it yet, so I'm going to show you now. So I'm kind of explaining it backwards, because you kind of need to see the recursive case to be able to understand why I'm returning an empty list here. So here is the recursive case, and what I'm going to do is, number is what we're going to be replicating in the list, as you see in the test cases. So I'm going to do number plus, because I'm going to have for every turn of this recursion, I'm going to concatenate a single element list to the rest of what I have, really just duplicating the value in a list over and over again. Because if you concatenate a one element list to another one element list, you have a two element list with the same value. So that's what I'm doing. So I'm going to do the one element list plus, and then I'm going to do the actual recursion, which, for those of you who don't know, recursion is a function calling itself. And for this recursive call, I'm going to do times minus 1, because you want the number of times to reduce every time you recurse, because if you don't, you're going to have an endless recursion, or it's going to get stopped by the Python interpreter. And my second argument, of course, is going to be the number that I'm duplicating, and that isn't going to change. And there we go. So that really is the solution. I've got my recursive case, and I've got my base case. So I'm going to run the test case that I already have set up, which is 3 and 5. I'm going to go ahead and run that, and here we go. All right, we got 3 5s, as you would guess. So times the first argument, number is the second argument. Let's just change it a little bit just to show you. 10 5s. You see down here we got 10 5s. Good to go. I'm going to try another one of these test cases. I'll do 8 and the 0. 8 0. There we go. You got 8 zeros. That looks like 8 zeros to me. That looks pretty darn good. Yeah. And let's, for the heck of it, let's experiment. And let's go to line 9 and take out the times minus 1, leaving times to be the same every single time. So now every time I run this, the times are going to be 8, and it's just not going to stop. So just want to show you what happens here. Yeah, maximum recursion depth exceeded, because the Python interpreter has a recursion limit built into it of, I believe, 999. So it just recurses over and over again. Yeah, because the times doesn't change, and it never gets to the base case because the times doesn't change. So you can liken recursion to regular iteration, where yeah, something has to break the condition, because if not, it's going to keep going. All right. Enough of this. I'm going to repair this. One more test, and good to go. So I'm going to pop this in to my CodeOrs interface and ensure that it passes. so I can jet. So I can Joan jet up out of here. All right, we're gonna test. Looks good. Gonna attempt. Looks good. All right. There we go. There we go. There we go. Impressive, impressive, impressive. All right, that's it. So what we have here is a recursive replication. Hope you learned a little bit about recursion. I know I didn't really give you a tutorial, but maybe you saw something in the commission of here that helped you understand recursion. If you did, if you did. If you didn't, you didn't. But either way, I'm out of here. I'm good. So I'll see y'all later. Talk to y'all later. I am out. Okay, what up, what up, what up? We're back, and today, looking at, are they the same? They not like us. Or not really. It's, are they the same? A Java exercise from Code Wars. Try to insert a little Kendrick in there, I guess. He's in the news nowadays. Okay, but the name of the exercise is, are they the same? That's what it is. I'm being silly here. All right. Given two arrays, A and B, write a function that checks whether the two arrays have the same elements with the same multiplicities. So you're going to get two arrays. Multiplicity is the number of times a value appears in the array. So that's what that is. Same means that the elements in B are the elements in A squared regardless of the order. So what it ends up being is A, you have a set of integer values. B, you're going to have a set of squared values. And you need to determine, is every item in B a square of an item in A? And do the squares and the roots appear the same number of times in their respective arrays? That is the case. So multiplicities is the number of times these values appear, the roots or the squares, and then same is well, the square root relationship. Squares in B, roots in A. Now let's take a look down here. Scroll it. Okay. So, as I was saying before, A is the root and B's are the squares. Like, I think root is the right term. So every element in B needs to be a square of an element in A. So you look here, 121. You look through here, that's a square of 11. So that's good. 14641. I don't know what that's a square of, but it's a square of one of them because it says it's a valid array. But you get the idea. You go down here and all of them are squares in B. Now these have to appear the correct number of times. So let's say if you have 111, you have to have 121. You know, the root, the number of elements in the root array must be the same as the number of values in the square array. The root's got to appear the same number of times as the square in the other array. So hopefully I'm not confusing you too much, but it is the nature of the exercise. It is what it is, buddy. So there's that there. And looking at this part here, you see what I'm talking about. And yeah, these can appear in any order, so it's not like you got to match the element or the index wise. It's more like, does this square have a corresponding root in the other directory, or not directory, the other array, and are they in the same number, the same amount? So yeah, looking at B here, we're showing, you see the squares, and you kind of compare this to up here, you break them down to the squares, you see that every number or every value in A
has itself squared in B and also the same number of times. Like you got 3 19s here, and in B you've got 3 19 squared, and I guess the 361 is 19 squared. So there's the idea. Let's look down below at some invalid entries. So A and B, and it kind of tells you what, it doesn't kind of, it does tell you this right here, that this set here returns false because 132, which was inserted here, it's not a square of anything in A. So that is out. Here's another test case here. This one fails because 36100 is not the square of anything in A. So there you go with the explanation. Now we need to do some code to determine this. I'll clear this out and let's dive into the Code Wars training interface. Let's go. Full speed ahead, my friend. Eventually. So make this bigger because the text or the font is so big already. We can't have that other stuff in here. And yeah, switching gears with Java a little bit here. I've been doing a heck of a lot of Python lately, so want to give Java a little bit of love here. Okay, so you didn't see this down below, I don't think, in the exercise, but it says that if A or B is null, either one of the arrays is null, we need to return false. And yeah, this is didn't really say that either. The method is going to return true or false whether the multiplicities and the square root relationship matches, whether they do or not. So if everything's a match, true; not a match, false. There's my 30-second explanation, or maybe less than that. Okay, so we need to check for null. If the array A is null or the array B is null, we are returning false. So yeah, that's the beginning, but I'm gonna do more because thinking about the possible solution here, these roots and squares, their amounts or their occurrences in their respective arrays are supposed to match each other. So realistically, if these arrays match, both arrays are of the same length because they have the corresponding roots and the corresponding squares in the same occurrences in the respective arrays. So they will have the same length if they are a match. So I'm going to say if the length of A is not equal to the length of B, we are going to bail and say false because this is not a match. So both arrays got to be the same length, or length, if you will, if you're from across the pond. Length. Okay, what I'm going to do as far as solving this this algorithm, or solving this idea, solution, exercise, whatever the hell you want to call it, I'm going to loop through the root array and I'm going to square everything from the root array, because I'm gonna square everything and then I'm going to compare it to B to see if they're the same after sorting each one. So actually what I'm going to do is I'll write it out here. I'm going to square the root array, which is A, then I'm going to sort both arrays, and see, if I've squared A, all of A, and then I sort both of these arrays, they should be identical because they should have the same number of occurrences. When A is
when the items in A are squared, they should match B because the same number of items in B should be in A as far as the squares versus the roots. So yeah, when I bring up A up into squares, sort them, or sort it, and then sort B, they should be identical arrays. And so that's what I'm going to do. I'm going to compare these arrays once they are sorted, and if they're not the same, there is no match. So I'm going to first square A by doing this. Plus plus, and then just gonna multiply the element by itself. Okay, once I have all of A squared, I am going to sort each one of these using the arrays utility class. Good. That reminds me I need to import util to get the arrays class. All right. Once each of them is sorted, I'm going to go through each and compare elements. A and B should be the same size at this. Well, they should be the same size, or they will be the same size because I've already done a checkup here for them not being the same size or same length. So they'll be the same length. So I just get the length of A and then loop forward. And what I do here is I check is element of A equal to the element of B because they've both been sorted. So they should be identical. And if they're not, we're returning false. And so if we've made it past really all of the checks to see if there's a failure, and there isn't, we are good to go. We got a match, baby. Because, yeah, if it doesn't fail in this second loop here, and it didn't fail up here, we are good. So that's that. All right, let's cram this mess into the tester, see what we get. Yeah. Didn't do my quality control checks. It's supposed to be multiplication, of course. Multiplying, doing a square. Aha. Let me open this up again. Probably syntactically jacked up. Multiply. Da-da. If A is not equal to B, of course. That's what that should be. Let's see if that clears it up. Good there. Good there. Magnanimous. I'm sure that didn't use that correctly. All right. Okay, folks. Great. There is your solution to Are They the Same? A Java exercise from Code Wars. Have a good day, a good week, and a good life. See y'all later. Okay, welcome back in here. Right now I'm looking at strong password, a Python exercise from Code Wars. Here we are. Yes. So, your user's passwords were all stolen in the Yahoo hack, whatever that is. And it turns out they have been lax in creating secure passwords. Create a function that checks their new password, passed into the string, to make sure it meets the following requirements. This is going to be a password strength checker. Between 8 and 20 characters, contains only the following characters, and at least one character from each category: uppercase letters, lowercase letters, digits, special characters from this set of special characters. You're going to return valid, or I'm going to return valid if it passed, or not valid otherwise. So this is not a Boolean, true or false. This is going to be a string, valid or not valid. So I'm going to get a string and I'm going to check it for all these criteria. Yeah. So, pretty plain and simple. So let's take this and go into the interface. Make it big. And just for the hay of it, I will do a comment so you can see what the requirements are as I do them, in case you forget. All right. Yeah, this is a classic kind of exercise where you do a password strength checker. Good exercise in conditionals and a little bit of Boolean logic here and there. Yeah, so between 8 and 20 characters, I'm just going to make that the initial barrier to entry. I'm just going to say if the length, S is the incoming string, greater than or equal to, the length is greater than or equal to 8, and the length is less than or equal to 20, then it's good. It's initially good. And then I'm just doing an else. I'm going to do an else that will be not valid, because, of course, if it's not within that range of length, it's not valid. So right off the bat, there you go. And what I'm going to do is have all the other tests inside of the initial if, under that umbrella. So how I'm going to organize these is, of course, you have these criteria. It's got to have one uppercase letter, at least one lowercase, one digit. So you have to check for all of these. And really, you kind of are going to need to go character by character to see, like, is this an uppercase letter, a lowercase letter, or a digit? My idea with this is to actually use list comprehension to go through, check character by character to see, really for each of these criteria, to see if it matches. And I use list comprehension. What I'm going to do is take the outcomes of the checks, put them into a list, and then I'm going to use the Python any function to check the trues and falses. Because I'm going to, for instance, I'm going to go through for uppercase, see if how many are uppercase, record true and false, and if none of the checks return true, then I know this is not a valid password, because it's going to need to be true for at least one check. And I'm going to use the any function to check for the occurrences of the trues. Here is how it is going to look. I'm going to use is upper. Okay, this is the model that I'm going to use for my checks, and how it goes is internally inside the any function, I am using list comprehension to loop through the string character by character, and for each character I'm going to check if it is uppercase for each character, and this list is going to produce a list of trues and falses, a list of Boolean values. Trues if it's upper, false if it's not upper. I'm using the any function to check and see if there are any trues in this list as a result. And then the not modifier says, or the not operator says that if there are no trues in here, I'm going to return not valid because there are no passes of the test. So there you go. And I'm using this model for all of my checks, so I'm going to replicate this and then change it slightly for each. Gonna do one for is lower and is numeric. I know that there's is digit out there as well. And then this one's going to be a little bit different. This is going to be to check if it's if it is one of the special characters, I think. Or no. Yeah, I got it. I know what I'm doing. Gotta copy this. The logic's all a cross step. Yes, no, what? All right, so what I'm doing here is I'm checking to see if each character, if it is not in here, it doesn't qualify, because one of the rules says if it's not upper, lower, numeric, and not in this set of characters, then it's not valid. So what I'm doing is checking for any character that's not in here, and then it's almost like a double negative. If it's not in here, it's going to be a true, and then if there are no trues, then return non-valid, I think, and not valid. I'm actually crossed up on it right now as I think about it, but at least you see the code, you can work it out yourself, and yeah, the code works. So I'm kind of screwing myself up here. So with all these tests, if it doesn't return non-valid or not valid for these, then you're going to return valid. And wait, where's my else? So it's all the way down there. Oh. Come on. I gotta put all this together. Clear the spaces. All right, over there. Good. Now let's take this and run it and see what we've got. And actually, yeah, my logic here is wrong. I forgot. I'm kind of remembering it now. That should be if any. Yeah. Here. Yeah. So I'm remembering how I got crossed myself up with this one. It's like, so yeah, I'm checking for the character not being in this string. And of course, if it's not in there, it's going to be a true in the list. And the any will check if any of the values are true, then it's a not valid, because true means that I found a character that is not in this set of characters. And characters not in this set of characters are not allowed. And actually, wait a minute. I've screwed myself up again, because I need, it's not only not that set of characters, it's also, I need to check for the character not belonging to the set of letters and digits. Yeah, this if here, now it's all coming back to me. This if is supposed to be really to find the characters that don't match any of the criteria, not letters and not numbers. and not in this set of characters. So what I need to check for is not being alphanumeric. Is al known? Yeah. Okay, yeah, I know I took you on a journey there, but what this is if I loop through and if the character is not in this set of special characters, and if the character is not alphanumeric, meaning it's not a letter or a number, it is an invalid character. And it would place a true in the list. And then looking at the any, if any in the list are true, I would have an invalid character, thus I would return not valid. There is your explanation. Yeah. It's a process, folks, always. But I think this process is done. Let's take it in here and run it. Or test it, actually. Not really running it, I'm testing it against stuff. And I failed 4. Let's see what we got here. Let me check. I'll just check the code. What is the failure? Numeric lower upper. Oh, I think I am missing one check. Yeah. Yeah, in my explanation of that other thing, I forgot one check, and I'll just paste it in here. I need to check if looking at line 20, I need at least one character that fits into this set of special characters. So I need to do check for that. So there is that one. If I've got at least one special character in this set, or if I don't actually, then it's not valid. All right, that's it. All checks complete, everything passes. Had to do a little remembering there, but hey, it is a process, folks. It is a humbling process. Nobody's got it nailed down 100%, and you see the process daily with me. Absolutely. All right, so here's all your checks, and try it out for yourself. See how much you can condense it. See if you can come up with some better logic. But that's it for me, folks. And with that, dudes and dudettes, I am out. What up? We're back with another one. Yes, I'm not stopping yet. Another one. A Python exercise called return a sorted list of objects. Yep, it is Code Wars. So in Python, objects are going to be dictionaries. Return a sorted list of dictionaries. Let's go. Fired up. You fired up like I am? Ready to rock it. Whatever that means. All right, you're going to be passed an array of objects. Really, in Python, you're going to be passed a list of dictionaries called list. You got to sort them in descending order based on the value of the specified property sort by. Where it says specified property sort by, this is really key. You're going to be sorting them by the key, but really you're going to be sorting it by that key's value, because the value is the value. Values are going to be numbers, and you're going to use the numbers for sorting. So when it says sort them in descending order, that's important. Descending order based on the value of the property, it means sort them in descending order based on the value of the key. So given that explanation, let's take a look at a sample piece down here. we have a list of dictionaries. These are all individual dictionaries. And so we're supposed to sort by a key. Sort the list of dictionaries by a key. And when sorted by A, so here we're supposed to sort by A, you look at all the A's in the dictionaries, we have 1, 3, 2, 4. It says sort in descending order based on the key. So the values we have are 1, 3, 2, 4. They're going to turn into 4, 3, 2, 1, being in descending order. And what you have to do programmatically is move the dictionaries around so that they match this order. So the one that has 4 is the one on the bottom, and it's got this B12 with it. This B12 is just going to be along for the ride. So what will happen is this dictionary, this whole dictionary, A4B12, is going to go to the top, and then 3, the one with 3, the A3B2 is going to go under it, and so on and so forth. So you're going to sort it, or it is going to be sorted by the values of A in this case, and the whole dictionaries are going to move around. And so let's look down below and see what the outcome is down here, where we see that, yeah, A4, 3, 2, 1. Now this dictionary, or actually this list of dictionaries, has been sorted by the key A, really the values of A. And really the other value or actually the other key or keys are just along for the ride. When you sort them, you're going to move the whole dictionary to sort, based on the value of one of the keys. So an interesting concept here. So let's dive into the code, see what we got here. Alrighty, so I'll leave that return. So I'm going to get I'm going to get a list of dictionaries, and I'm gonna sort them and put them into a new list. So I'm gonna create a list called new list. This is going to be my new list of dictionaries once they are sorted, and I'm sorting them by the values of a certain key. So I'm going to create a list of vowels where I'm actually going to extract all the values that I need to sort them, and then go back to the dictionary, or actually go back to the list of dictionaries and do the sorting in some kind of way. You'll see it later on. So first I am going to loop through this list. Remember, well, not remember, but maybe you just don't know, the arguments or the parameters here, they are sort by, which is the key. Sort by is the key, or sorting by. LST is the list of dictionaries, So I'm going to loop through the list of dictionaries, and what I'm going to do as I loop through the list of dictionaries, I'm going to get the values for that key that I'm going to sort by. I'm going to isolate the values, and then I'm going to sort those values. And now that I think about this a little bit, it's probably a better way to do this than I'm doing it, but there always is, so oh well. All right. So what I'm doing here is LST index I is one of the dictionaries, and then I'm indexing into that dictionary using the key to get a value. So really for each dictionary I'm getting the value associated with the key that I need to sort by. And I'm just isolating the values in a list, and then I'm going to sort them. and this will occur after the list. We'll do it like this. What I want to do actually is I'm going to remove duplication, then I'm going to turn it into a list, and then I'm going to sort it. And sorting in reverse, or actually in descending order. So yeah, that option reverse sorts it in descending order. So what I just did here is took the list of values, turned it into a set to remove duplication, turned it back into a list, and then on the next line I sorted the list. And now I'm going to go back into the dictionary and pull out the dictionaries in the order that I want them to be in. And the order will be according to the order of the sorted list that I just sorted. And that list is vowels. So I'm going to loop through vowels. And then I'm going to do an inner loop, looping through the list of dictionaries. And what I'm going to do is, as I loop through the list of dictionaries, I'm going to find the dictionary that corresponds, or find the dictionary that has the value that I'm isolated on, and that key, I guess you could say, or actually, I'm going to loop through and find the key value pair that I have the value for. And I'm going to take that whole dictionary and put it really in the order of the values. That's how it's going to work. Hopefully you're following that. I'm barely following it myself, but maybe it'll become clearer when I put it in the code. All right, what I'm doing here is in the inner loop, I'm looping through the list of dictionaries, and then for each dictionary, if I find the value that I'm isolated on and it belongs with that key that we're sorting by, I'm going to go ahead and append this entire dictionary to my new list of dictionaries because it'll be in the order that I want. Basically, I'm using the order of vowels, which is sorted, to pull out the dictionaries in the order of the sorted list of values. Because for each value in the list of values, I'm cycling through the dictionaries until I get the one that has this value, and then I'm copying it into my new list. And yeah, this is just copying the whole dictionary based on the key value pair that I am finding. And I can clear some white space here and use the return and just return my new list. And it is LIST for new list. Just looking it over. A lot going on. Yeah, this is a good exercise in dictionary tomfoolery, dictionary manipulation. Sorted. What? Where did this come from? I don't remember typing that. Or any of this. Weird. Was I high? Alright. Impressive. Alrighty, folks. That is, what's the name of this sucker? Return a sorted list of objects. Here's the code, yeah. Return a sorted list of objects. Code Wars, Python, ready to roll. All good. You guys do it. Tell me about it. That's it for me. I am out.
right. Yeah, homies, we still here and we're still doing it. Okay. Code Wars today, once again, it is remove consecutive duplicate words, a Python exercise, and here we go. 3, 2, 1, record. Even though I'm already recording. Okay. Your task is to remove all consecutive duplicate words from a string, leaving only first words entries, whatever the hell that means. I think I say whatever the hell that means a little too much in these videos. I also want to say that this is a redo. I did this exercise in Java a few weeks ago. So this is a Python version of this solution. Okay. Remove all consecutive duplicate words from a string, leaving only the first word entries. So you got a little string right here. You see duplication, obviously. And so I am actually supposed to remove duplicate words. Not just duplicates overall, but actually, so I don't remember what I said. What you're supposed to do, let me get this straight, is remove consecutive duplicates. Not simply duplicates in the string, consecutive duplicates only. So looking at this string, I remove this one, these two, this one, these two. So consecutive duplicates. You notice in your result down here, you still got duplication. You remove, or I remove, I'm empowered. Okay, yeah, I remove consecutive duplicates. And there it goes. So you remove consecutive duplication. So basically, if you have if you have a duplicate word next to, you have duplicates next to each other, you remove the duplicate. Yeah, I'm kind of talking around myself this morning. If it's morning out there, good morning wherever you are, or whenever you're watching this. From what corner of the globe? Tell me what corner of the globe you're in, even though nobody really comments on my videos yet. So I'm not big enough. All right. The words will be separated by a single space. There will be no leading or trailing spaces in the string. Empty string is a valid input. Okay. Got my marching orders. I'm going in, homies. Your mission, should you choose to accept it, so wait for this to load. Yeah, I'm not sure which end the issue is on here, but let's see what we got. It's live TV, folks. All right, no edits. And looks like the header for the function is gone. Okay, there we go. All kind of weirdness going on. I'm gonna first say, so here, S is the input string. So I'm going to say if S is empty, I'm going to return empty. And forgot my if. Come on, dude. Yeah. Okay, what I'm really going to do is, my strategy is I'm going to go through the original string, remove consecutive duplication, and really I'm going to copy from the original string to a new string. I'm going to copy over only those non-consecutive, the words that are not consecutively duplicated. That's what I'm going to copy over from the original string to the new string. And I've got a little method to do that. I'm going to put the copied over stuff into this string called ANS, short for answer, I guess. And first thing I'm going to do with my incoming string is I am going to split it into words, because I feel it is the natural thing to do. I've got a string with words separated by spaces. I'm going to split them by those spaces, put them into a list. And yeah, it'll be a list, so that I can do things, or I can process the words as words.
Harder to do in a string, of course, easier to do in a list. Before I do my full processing, I'm going to go ahead and populate my the string that I'm going to return. I'm going to go ahead and populate that with the first word, because I know that the first word is going to be in there from my list. The first word is going to be in there because there's no duplicate before the first word, so I can safely put the first word in there. I'll put a space next to it because it'll have a space, and if it happens to be the only word, I'm going to strip it so the space will be gone later on. So there you go, there you go. Now I'm going to do my loop. There's always a loop, dudes. Fellas. There's always a loop. Well, really, that's not actually true, but in a lot of these there's going to be loops because you want to automate tasks, and you're going through a structure and doing some manipulation and such. It ain't always the case, but a lot of times you're going to use loops in these exercises. All right, I'm going to loop through my list that I'm calling split str, a little slight misnomer. I'm going to start at index 1, not index 0, because my strategy is going to be, for each word, I'm going to look at the previous word, and if the previous word is not a duplicate of this word, I'm going to copy this word to my new string. That is my overall strategy. So I'm going to go word by word, starting at index 1, look at the previous word. If that previous word is not a duplicate of the current word, I'll copy it over. If the previous word is a duplicate of the current word, then I will not copy the current word. That's a consecutive duplicate. I will skip to the next one and try again. Yeah. So here I go. If this one, being the current word, is not equal to the previous, then remember A and S is my destination string that I'm going to return with my solution. I'll append the word, or I will concatenate the word and a space. Of course, I'm going to end up with a space on the end. And yes, I could manage this another way, but I'm going to do the duct tape, basically, solution of returning the stripped form of my string. Because, yeah, there's going to be a trailing space at the end, so I'll just strip it off the end and be done with it. But there's a better way to do it. I'm not going to think of it now because I'm recording a YouTube video. Harder to do that, but yeah. All right, that's it. So let's try this one out. See. A lot of times they'll say, I see where it fails, because a lot of times you do something sort of hastily, you're gonna make a mistake. And I did. That's good. That is good. Correctamundo. Out freaking standing. All right, I was gonna say baby. Oh, I don't know what I'm doing. It's just today, yeah. Here it is, homies. Remove consecutive duplicates. Python this time. Code Wars. Got your solution. Good to go. Solution passed. And with that one, I am out. See ya. Hey, back again with sliding puzzle verification, a Python exercise from our old buddy Code Wars. We are back home, folks. Always here, always grinded. Sliding puzzle verification. Okay. Given a board of n by n distributed with tiles labeled 0 to n squared minus 1 inclusive, a solved grid will have the tiles in order of label left to right, top to bottom. Return true if the board state is currently solved, and false if the board state is unsolved. The input's always going to be a square 2D list, and this one does not become clear until you look at the examples, like a lot of these Code Wars exercises. Like, I don't know if you got what you're supposed to do from there, but I didn't when I initially looked at it. So let's look at the examples. A 2x2 solved grid is going to look like this, where we have this two-dimensional list. It's sequential, 0, 1, 2, 3. That is said to be solved, so that would return a true. A 2x2 unsolved grid has numbers that are not in sequential 1x1 order. And so whatever you got from this, the reality is that what's supposed to be done is check a two-dimensional list to see if all of the numbers are in sequential order, and really going from 0 to n squared minus 1, and n being the square dimensions of the list. So yeah, you just got to see if the you just got to see if the sequence stays in order and consecutive from 0 all the way up to n squared minus 1. So you're checking a two-dimensional list to see if all the numbers are sequential and then that they end at the right value. So that's what you got to do. And realistically, you can get away with this one by simply determining if each number is one more than the one before it. You can simply do that, and that is what I'm going to do in my code. So let us and let me get into this mother. Enough talking, let's go. All right, got my header here. So I'm going to get a two-dimensional list, and I'm going to begin to loop through that list using nested looping, because I got to check every single. I'm sure there's a way to do it without checking every single one, but kind of the more spelled out normal way, I guess you could say, is going to be to check every single element. So what I'm going to do is I'm going to ensure that each element here, each integer, is one more than the last one, and that should represent a solved grid, because they're all in order, and they will carry through from 0 to the last value, which is n squared minus 1, as I keep repeating. I don't need to repeat myself anymore, right, folks? Right. So, strategy-wise, in dealing with a two-dimensional list, I'm gonna be checking the previous element to see if this element is one more than it. But there's a little dilemma. What if I'm on the first element of a new row? How do I check the previous? Because the previous is going to be in a different row. Kind of like this. Let's do this scenario. That is a 4 on the left. So, like, let's say I'm here on this second row, and this 4 is my J. I need to check the previous one, which is this 3 up here. And that 3 is on the previous row, so it's going to end up being I minus 1. And so I can't just check it doing my normal sequential stuff of like going to the previous J. That's not going to work, because J is going to equal 0 when I'm on this 4. If I go to the previous, it'll be J equals -1, and that ain't working. So long story short, I'm going to do a condition or I'm going to check it differently if j equals 0. And then for all other values of j, I'm going to do a different thing. So let's get into it. I know that was not a complete explanation, but maybe you will get it in the code. I don't like to do complete full walkthroughs all the time because of time considerations, but I don't need to explain myself. Nobody's watching this stuff anyway, right? All right. I'm being negative today, y'all. Gotta help me. Gotta get some PMA up in here, do some burpees. All right. So yeah, if j equals 0, I'm going to do a certain thing. I'm going to check if I equals 0. I know this is a little, it's like hella nesting, but it is what it is sometimes, folks. I'll explain this stuff once it's in because it's a little decent amount of typing. Yeah. More than 9 divisions. All right, that's a mouthful, ain't it? Yeah. So if j equals 0, which means if I'm at the beginning of a row, and if I is greater than 0, meaning that I am at least on the second row, because I don't need to do this for the first row. So if I'm at least on the second row, then I proceed. And what I'm going to do is I'm going to take the current element and I want to subtract it from the last element on the previous row to see if the difference is 1. And this is wrong, actually. The difference should be not -1, should be 1. So if the difference is not 1, meaning if this element is not 1 more than the one in the previous row, I have a failure because I'm not going sequentially. So I will return false here. All right, so that is one condition. And otherwise, I'm going to do kind of a normal test where if I'm within a row, I'm going to check the previous value to see if it is the previous value 1 less than the current value. So yeah, board ij minus board ij minus 1. And if that is not equal to 1, it means that I am not in sequence and I do not have a solved board, so to speak. I'll return false in that case. Not fail, I'll return false. Fail is different. Epic fails, yeah. And if I get through all of that and I haven't returned false yet, I'm going to return true, because that means that I've encountered no failure. They're all sequential, and I'm going to get to the end solved. Let's go, let's go, let's go. Pass and pass. Out freaking standing. There we go. So there is your solution to, I always have to look back to see what the hell it is. Yeah. Whoa. This is your solution to sliding puzzle verification, a Python exercise in Code Wars, and that's it for me. That's all, folks. See y'all later. Hey, 1, 2, 3, 3, 2, 1. We are back again. I told you we're not stopping. We're not stopping for anything. May take a little breaks, but we ain't stopping. Okay, today's exercise is it is a Code Wars exercise called Substring Fun Python exercise. Would it be anything else? And yeah, it's from Code Wars. Okay, dive it in here a little bit. Complete the function that takes an array of words. So this function is going to accept a list of strings. That's what it's going to be. That's my translation to what it said there. I notice with these Code Wars exercises, you must translate what they have, because many times, yeah, you get it. You must concatenate the nth letter from each word to construct a new word, which should be returned as a string, where n is the position of the word in the list. Let's look at an example, shall we? You have a list of words, and the objective is to construct a new string, or construct a string that consists of the letter, or really, yeah, the letter from each word that corresponds to the word's index in the list. I'll say that again. What we need to do is construct a string where each letter comes from I messed that up. Okay, so let me try this again. Reset. So you're going to construct a string where each letter consists of a letter from each word in the list, and the letter that you get from each word is going to correspond to its index from the list. So it's a concept. I'll leave it at that. Okay, so with this list, we're grabbing the Y because Yoda is index 0, so we grab index 0 of Yoda. With the with best is index 1 of the list. Let's just number it here, 0, 1, 2. Best is index 1 of the list, so we get index 1 of it, which is the E. And then has is index 2 of the list, so we get index 2 from has. So you have Y, E, S. Yes. There we go. So that is what you get there. And that's it. So that's what you got to do. You're going to get these. And I'm going to do this one in PyCharm. I'm going to show you. I've got a couple of test cases from Code Wars in it. And yeah, going to do it in Python and PyCharm. Whatever the hell that means. All right. So we have it here. And I'm going to be constructing a string. So I'm going to make my new string equal to an empty string right now, because this is going to hold the string that I create. Then I am going to loop through the list of words. And this is, and you see down here a couple of test cases. These are sample inputs. So I am looping through each one of the words using this list. And then for each word that I get, I'm going to get a certain letter from that word, and the letter will correspond to that word's index in the list. And for each letter, I'm going to concatenate it to my new string. So there'll be words, and then of course you're going to index to get the word. This is the current word that we're on. And then we're going to index further using double indexing to get the letter that we want to get. And the letter is going to be the same index as the word in the list, so it's also going to be I. So you're going to double index I twice. You're going to use I, the first bracket I is to get the word from the list. The second bracket's I is to get the letter from that word. And that's that. When the loop is over, S will contain our formed string. And we will return said string. Emphasis there. This is ready to run. So looking at these sample inputs, the answer is over here in the comment. So for Yoda best has, the answer is yes, because you got YES. For line 13, where you've got all these countries, interestingly, the answer is Code Wars, because you get the C, O, D, E, and you keep going. Yeah. So I'm going to run it, see what we get. Because, yeah, these are already set up to run, by the way. And we get yes and Code Wars. That's it. Good stuff. So this is ready to run in Code Wars. Yeah. Enthusiastic this morning. Good stuff, good stuff. It's morning somewhere. Chop it up and put it down, baby. All right, let's run it. Test. And attempt. All right, that looks good. So we have a solution for substring fun from Code Wars in Python. My name is Dean. Once again, have a great day. Keep coding, keep grinding, keep getting better. I'll do the same. And I'll see you here another time. I'm out. Okay there, 10-4 good buddy. And right now I'm looking at C is for Code Wars. And yeah, it is from Code Wars. It is a Python exercise. Yeah. C is for Code Wars. Cool name. Cool exercise as well. I like it. So let's dig into what the heck it is. Build a string representing a capital letter C of a given size out of C characters. Let's take a look at this one. And this is an ASCII art exercise where, given this function call and you supply a 1 as the argument, you're going to get this printout of a C. Yeah. And I think it's instructive to look at another example before I dive into the explanation. Let's look at the example when you generate with an argument of 2. This first one was with an argument of 1, and you take a look at it. Looking at it with an argument of 2, we see a little difference. So we see 2 full first rows, and then we have a bunch of rows with just 2 C's, and then we have 2 full rows at the end. You can kind of see a pattern here where for a given argument, it's got that number of full rows at the beginning and end. Like for an argument of 1, it's got a full row. It's got 1 full row at the beginning and 1 full row at the end of C's. For the argument of 2, it's got 2 full rows at the beginning and 2 full rows at the end. So, yeah, when you're having to generate ASCII art, you got to look at what are the patterns. So I see that pattern. Seeing another pattern is that when, or for the argument, the number of rows is going to be times 5 of the argument. So you have 1 as your argument. 1 times 5 is 5. You see there's 1, 2, 3, 4, 5 rows. There's 5 rows there. And if we scroll down, when the argument is 2, with this one, the argument's 2, we have 1, 2, 3, 4, 5,
6. Yeah, getting a little tedious here. 7, 8, 9, 10. So if we call the argument size, then the number of rows in your output is going to be equal to size times 5. And that is size times 5. This is an X. Yeah. But yeah, the number of rows in your output is going to be size times 5. So we see those patterns. We see the pattern of the, so if we call the argument size, we have a number of full rows that are equal to size at the beginning and end. You have these two blocks. And then the number of rows is equal to size times 5. Another pattern is in these interior rows, the non-full rows, the number of C's will be equal to size. Here size is 2. We have 2 C's per with these interior rows. So you're seeing a few patterns here, or at least I'm seeing a few patterns here. I don't know what you're seeing over there, but hopefully I'm doing a good job of explaining them to you. Yeah. And there's the exercise. So you got to really account for all of these patterns. And now I'm going to fire this one up, get it in the pie chart, and let's go. Yeah, PyCharm will be good for this one because I can demonstrate the outputs as I go. And I'm going to be building a string to satisfy this. So it's going to be, it really is going to be rows concatenated to each other. It's going to be, you know, generate this row, concatenate it, this row, concatenate. So it's going to be strings concatenated to each other. Of course, I'm going to need new lines at the end of each one. So like here, you're going to do a new line, here, a new line. So I'm going to concatenate the appropriate amount, new line, appropriate amount, new line, all the way down. This last one will not have a new line. The instructions actually say that, but I've glossed over the instructions because I gave my own. So I'm not going to look at them because we're already far enough in. So we will leave it at that. Home slices. That's a weird thing to say. Okay, so let's generate this sucker. And I'm going to call the final string final C to make it equal to empty string. And I'm going to create a variable to hold my size times 5. Because if you follow the pattern, you know a lot of this stuff is contingent on the size minus 5. So I'm going to go ahead and put it in a variable so that I am not continually multiplying the size times 5 in all of these different scenarios. It just makes sense to me to put it into a variable. And I'm going to loop. I'm going to use R for the row. And this loop is going to go really top to bottom. And I told you before, the number of rows total is going to be equal to the size the size times 5. So I'm making that my range. My range is going to be the size times 5, giving me the appropriate number of rows. In the body of the loop, I'm going to create the across portions of the row. I'm going to populate each row basically in a horizontal fashion. And I need to create a few rules to govern this, where if I showed you before. Let's take a look here again. That's not it. Yeah, told you before. Like with looking at the one that has 2 of each. You have 2 full rows first, then you have the rest, then you have 2 full rows. So we're going to have full rows according to
size. We're going to have size full rows, if you can follow that. So I need to make that rule. And then, of course, I need to make rules for these other ones. And go back here. So I'm going to say if my number of rows, or actually my variable, is less than size, I am going to generate C's that are equal to the size times 5. These are going to be the full rows going across. And of course in Python you can multiply a string by an integer to duplicate it. So this is going to be full rows at the top. And for this next one, I'm going to do the condition of the interior rows, the rows that have a number of C's that is equal to the size. Actually, no, I'm not doing that one yet. I'm actually going to do the rows at the end because I like the way this condition is set up, or the flow here. So I'm going to do the end rows actually. The end rows is kind of complicated. I'll just type it up here. All right. All right, so what I'm doing here is I'm creating the bottom full rows. And what it is I'm going to say if R is greater than or equal to the size minus 5 times size, and it's less than the size times 5, then I'm going to populate a full row here. It's because when you look at the bottom, the ones on the bottom, what? Yeah. Whoops. It's a little hard to navigate, right? Yeah, looking at the ones on the bottom. Let's say, these are 10, it's 10 total, so, it's, size times 5 equals 10 here. 0, 1, 2, 3, 4, 5, 6, 7, 8. This would be rows 8 and 9. And what it is, in this case, size times 5 minus size is equal to 8. And while it's less than SZ, which is size times 5, it'll go 8 and 9, covering these two spots. So not a full explanation, but maybe you can follow what's going on by me plugging in the numbers for when the size is 2. It's gonna go for 8 and 9 while it's less than 10, and it's gonna do a full row for those rows. And yeah, so these are the ones at the bottom. All right. And then otherwise, you're doing the interior rows. And the interior rows are just going to be, it's going to be plus equal C times size. This is going to be the size given as the argument. Like if the argument is 1, you're going to have 1 C in the interior rows. If the size given is 2, you're going to have 2 C's in the interior row. And sort of finally, after each row, the if, elif, and else, these each create single rows at a time. And after each single row, you're going to have to put a new line. So I'm going to do that. And of course, I don't want a new line at the end, and there's a better way to handle this maybe, but I'm going to do the kind of the cheap duct tape way, and I am going to strip it at the end instead of creating a condition or such. I'll just strip it at the end so that the last new line is just stripped out. And there is your ASCII C generator. Let's take it for a spin a little bit here. And yeah, I didn't explain some things fully in the interest of time. So I was rambling enough, I think. So, but you guys can get it. Okay, let's look at the C we've generated. Beautiful, beautiful, beautiful. You see we got 2 corresponding to the 2, and then we got 10 total lines. Then we have 2 on the interior, 2 C's. So 2 rows to begin, 2 in the interior, and then 2 to end. Let's do 4. The big C. See, we have 4 full rows at the beginning. Then we have interior rows, as I call them. You have 4 C's, and then you got 4 rows of full C's at the end. All right, we'll do 1 as a last one. Okay. Yeah, 1, 1, 1. It's all good. So I'm going to plug this in, and let's go with it. Hallelujah. Plug it in, plug it in. Let's get it. Alrighty, that looks good. And folks, there we go. Impressive, impressive. I know it is. You know it is. All right, y'all find a better way to do it and let me know. And but for me, I got my solution, so I am out. Okay, back again, my friends. We're here with a Code Wars exercise called Playing with Digits, done in Python. This is a familiar refrain. Yep. Python Code Wars. Let's get it. Some numbers have funny properties. For example, you have 89, and you break apart the digits, and then 8 to the first, 9 to the second, you add them together, and they're equal to 89 times 1. So 8 to the 1 plus 9 to the 9 squared actually is 89. Interesting property, I guess. And then you see 695, digits split apart, and then we have consecutive powers, and they're added together, 1390. It happens to equal the original number times 2. So it's kind of a thing where there's some number that you can multiply by the original number that will equal that number's digits raised to consecutive powers. That is the idea here. Looking at the 46288, and we have the digits split apart. Then we have consecutive powers here, and it equals this number. And lo and behold, it equals the original number times some number. So what this is getting you ready for is the idea that you can take a number, split its digits, and have its digits raised to consecutive powers, add the results together, and that can equal that original number multiplied by some number. Given 2 positive numbers n and p, we want to find a positive integer k if it exists, such that the sum of the digits of n raised to consecutive powers starting from p is equal to k times n. Getting mathematical on y'all. Yeah. So talking about the consecutive powers starting from p, you in this exercise, I'm going to get 2 integers as input. Integer n is going to be the original number, like one of these. P is going to be the starting power. Like in this first one, P is 1. That's the starting power. In this one, P is 2. And in this one that's kind of highlighted, P is 3. P is going to be your starting power. In other words, writing the consecutive digits of n, such as blah blah blah, there's an integer k such that, yeah, a little kind of formula here, you raise it to the consecutive powers, the digits split, and my task here is going to be to find the k that, or if it exists, that when you raise these digits to the consecutive powers, add them together, there is some mystery number, perhaps, that you can multiply by your original n and achieve the result of the multiplication of the digits with consecutive powers. It's a hell of a mouthful, right? There may not be a k, and if there is not a k, you're going to return -1. So, a lot going on in this one, my folks, but we got it, and we'll persevere. Let's drop into the code, shall we? Let's get this. Knock this mother out. So, the idea, or the beginning is you need to split up the digits. You're going to have a possibly multi-digit number, so you need to split the digits so that they are, you can access them individually. There is a mathematical way to do this, and you may have seen it in other videos that I've done. Not going to do it here. I'm going to do the more expedient way, which is going to be to take my multi-digit integer and turn it into a string so I can access each digit via character of the string and manipulate it that way. It is a lower code way to do it, kind of like the easy way. So I'm going to take n, which is our original number, and actually n is going to be on the other side. I'm going to take n and convert it to a string so I can loop through it and get each individual digit very easily. And I need to create a total of the additions of each digit raised to consecutive powers. I needed to store that somewhere, so I need to put it in a variable. I'm going to make that variable equal to 0. Yes, yes. That's my announcer voice. And I'm going to use a while loop to loop through the characters that are really digits. So I'm going to use an iteration variable because we got an index in, so I got to do that. And then I'll do while I is less than the length of my string, which is going to be the digits. I am going to do the addition of the digits raised to a power. I got to do an integer conversion on the string, and I got to index into the string to get the digit. Whoops. Yeah, that NSTR index I, that is me indexing into the string to get one digit. I'm going to raise that one digit to the power of P. Haven't mentioned P yet, but P is the power. So it's going to be set to something to begin, and it's going to increase for each iteration. Just like you see over here, where you have the P begins at 3, then it increases to 4, 5, 6, and so on. It's going to start at something increase, but for each iteration, it's going to be used to raise the digits to a power. So I'm doing that. And then I get in here and I'm gonna increase P and I'm gonna increase I to move the train along. Once the while loop is done, I've got my total of the additions. I've got my result number. Now I gotta find out if there is a k, if there is a number that when multiplied by the original n is equal to this total that I have. So I'm going to see if my total that I have is see if it is divisible by n by using modulo, because that's going to check divisibility. Because if a k exists, then k times n equals total. If n is not divisible, or if total is not divisible by n, then there is no k. If it is divisible by n, then there is a k, and I'm going to return it. And I'm going to return it like this. I'm going to return it by total divided by n, because if n times k equals total, then total divided by n equals k, and I will return k. So line 11, it is really a formula to get k using some property of math that I don't remember. Like, I don't remember the names of the properties of multiplication and division and such, where you take the multiplication, you turn it around to division, and yeah, whatever. I'm not a mathematician. I'm a programmer. Probably should be better in math, but I will be maybe someday. Anyway, so that's going to return my k. There exists the possibility that there is no k. If total is not divisible by n, hope I'm saying that right, it's gonna there's no k, and I'm gonna return -1. There we go, folks. I think that's it. Cut and print. Let's see what we got. That looks good. Alrighty. Correctamundo, correctashundo. Take that to the bank. All right. Time to fire it up, homies. There is your solution to playing with the digits. There's a solution. This is my solution, actually. There's probably 1,000 damn solutions, but this is my solution to playing with the digits. Code Wars, Python, let's go, let's get it. And we out. Or at least I'm out. You can stay, but I'm out here. See ya. One, two, three, we back. Back with a Python exercise called Boiled Eggs. And this is from codewars.com. Back in familiar surroundings. Absolutely. Description-wise, you are the greatest chef on earth. Nobody boils eggs like you. Your restaurant is always full of guests who love your boiled eggs. Little leap in reality. But when there is a greater order of boiled eggs, you need some time because you only have one pot for your job. How much time do you need? Let's scroll down, and your task is to implement a function which takes a non-negative integer representing the number of eggs to boil. You must return the time in minutes which it takes to have all the eggs boiled. Yes, so you're going to be given a number of eggs and return the time. So here's the rules. This is really a development of an algorithm. That's what this is going to entail. Like a lot of coding, right? You can put at most 8 eggs into the pot at once, and it takes 5 minutes to boil an egg. We assume that the water is boiling all the time, so no time to heat up. And for simplicity, we also don't consider the time it takes to put the eggs into the pot or get them out of it. So you're going to be given a number of eggs, and we need to determine how long it's going to take to boil those eggs. Now, you can only boil 8 at a time, and it takes 5 minutes to boil an egg or a set of eggs. So really the 8 and the 5 are really important in this algorithm development here, because you can do 8 at a time, and that 8 will take 5 minutes to boil. And yeah, really, and of course, no matter how many eggs you have in there, it's going to take 5 minutes to boil. So looking at a few test cases, we have 0 equals 0, of course, if there's no eggs, take no time. 5 is 5. So let's look at this one. 5 eggs, of course, it's less than 8. You can put them all into the same pot at once, and it takes 5 minutes to boil. So after 5 minutes, all those eggs are going to be done. I feel kind of silly talking about eggs. We look at 10. 10 is going to take 10 minutes, where on the first set, you can only put in 8 eggs. So 8 eggs are going to take 5 minutes to boil. And then what you have left over from 8 is 2. So then you put in the next 2. Those 2 are going to take 5 minutes. So we have 5 minutes for the first set of 8, 5 minutes for the set of 2. That takes 10 minutes total. So you kind of see a pattern here where we're going to get, if the set of eggs is larger than 8, we're going to get a set of 8, put it in there for 5 minutes, and then what's left over, we'll put it in for 5 minutes, and then of course you kind of repeat for however many sets of 8 you have. So really sets of 8 is going to be kind of the grouping of the pattern. So let's dive in to this code, or dive into the creation of this code. All right. So you can have at most maximum 8 eggs per set and boil those for 5 minutes. So what if you get a set like what if you get 64 eggs, 8 times 8? Well, you're going to be boiling 8 at a time, 8 times, and they're going to take 5 minutes each. So really, you just take, I think the answer would be times 5, because it's like 8 times 5. That's going to be the answer. It's going to be 40, because if you have 8 sets of 8, you can put in 8 at a time, and those 8 sets times 5, it's going to be 40. Really, my point in rambling through a simple multiplication problem was to impress upon you, or to bring up the point that if you have a number of eggs that's evenly divisible by 8, then you're just gonna do the division times 5. So like if we have 64, which is divisible by 8, we just do 64 divided by 8 times 5, because that's going to give us the answer. Because if we have a number that's evenly divisible by 8, we can just continually put in sets of 8, and there's no left over. So that's it. So we can do it like this. If the number is evenly divisible by 8, we can return the number of eggs divided by 8, and then multiply that by 5. I guess it's going to be, eggs. Yeah, because it's just going to be it's going to be sets of 8. So it's just very, very easy. Sets of 8, nothing left over. However many sets of 8 there are, you just multiply that by 5, and you're out of there. So like if we have 24 eggs, we just put in the first set, 5 minutes. Second set, 5 minutes. Third set, 5 minutes. It's just 5 times 3, because there's 5 minutes, 3 sets, and there you go. There's your answer. So what if there's a remainder? Like if the set of eggs is not divisible by 8, there's just another little piece here where we're going to we're going to get the portion that is divisible by 8, if there is one, and multiply it by 5, because that's going to still apply. Like if there's, if you have, let's say, 43 eggs, the 40 is divisible. Wait a minute, is 40 divisible by 8? What am I thinking here? Yeah, 8 times 5 is 40. Yeah, basic multiplication here, folks. Yeah. So yeah, if you have 43, the 40 is divisible by 8, and then there is 3 left over. And you can handle those 3 in a different way. Well, really, any part that's left over is just going to be 5 minutes, because the part left over is going to be less than 8, and any number of eggs takes 5 minutes. So whether you have 3 left over, or 6 left over, or 7, or even 1 left over, it's all going to be 5 minutes. So you just add 5 for any remainder. So my formula for if the number of eggs is not evenly divisible by 8 is simply going to be to take the number that is divisible by 8, get that, and then simply add a 5 on the end, because it's going to be less than 8, and really any number of eggs takes 5 minutes. We can break this down as well. Let's look at, I'm sure most of you get it, but I'll just kind of put this out there for those of you who are still kind of not with it. Let's say, say we have 28 eggs total. Of course, this number is not evenly divisible by 8, but let's get the part that is evenly divisible. So the evenly divisible part, yeah. Having trouble here, folks. All right. The part that is divisible by 8, 28 divided by 8 equals 3. And there's a remainder of, 24. Yeah. Remainder of 4. So the part that is divisible is 3. So that means there's 3 sets. You take those 3 sets times 5. 8 equals 15. But then there's a remainder 4. For the 4 that's left over, you just add 5 to it, and that's going to give you 20, because that 5 left over is for the 4. Yeah. So there you go, folks. And that is it. That handles everything, because you return for your if, and then for your else, you return if and else is, it's binary. So like, if it's not one, it's the other. So all of my returns are handled. Out freaking standing. That goes. And that goes. Impressive, homies. All right. That's it, folks. That's all, folks. Like Porky Pig says. Got your solution for boiled eggs, Code Wars. Take a look, try it out. Do a one-liner if you can. But for me in my house, I am out of here. See y'all later. Yeah, we back and looking at ones and zeros, a Java exercise from Code Wars. And yes, this is Code Wars. I'm trying the daylight, the bright interface today. I usually use the dark one, trying something new here. Spice it up, my homies. All right. Given an array of ones and zeros, convert the equivalent binary value to an integer. And yeah, this is Java, this is not Python. So doing this in Java today. Language is Java, remember that. I need to remember it too, because I'm always doing Python. Anyway, 0001 is treated as 0001 in binary, which is the binary representation of 1. And then you got your examples down here. And really, it is simply you're simply converting a binary number to an integer, but the binary number is going to be in the form of an array instead. So, like, let's take this one out, and you can just think of it as 1, 0, 0, 1 in binary. And like, let's look at this one too. And generally, to convert binary to integer, you're going to do really, I guess you get powers of 2, and you add them together. So like with this 1001, you really set up a situation where you do powers of 2 starting from the right and going to the left. And so like on this one, it would be 2 to the 0 power. This would be 2 to the 1 power. This would be 2 to the 2, and then 2 cubed. So like each one of these is a power of 2. And you're only going to count the ones that have a 1 as their value. The zeros you can ignore. So really converting to binary, or converting from binary to integer, is simply taking each binary number, only the ones that are 1s, getting the appropriate power of 2 for that slot, and adding them together. For instance, here we have 1s at 2 to the 0, which anything to the 0 power is 1. And then we have 2 cubed, which, 2 cubed is 8. So those two together are going to be 9. And there's your answer there. And you look at these. This one, you put a 2 to the 0 power. Here's a 2 to the 1, 2 to the 2, and 2 to the cube. And because these are all 1s, you're going to add them all together. And remember, yes, when you have zeros, you basically ignore that spot. You only count the 1s with 1s. So coming back down here, 2 to the 0 power is 1. 2 to the 1 power is 2. Anything to the 1 power is itself. 2 squared is 4. And then 2 cubed is 8. So we add all these together. We have 3, 7, 15, 15. So there we go. There's a tiny tutorial in converting from binary to integer. And that's really what you got to do. You go through the array kind of however you want to do it, and you get the powers of 2 of each of the 1s, and then you add them together. Now let's do it in code. Slide up in here. Yep. Got your Java boilerplate for the method. I'm going to be storing my integer total in an integer, so I'm going to create an integer for that. And then I'm going to begin looping through the array. The array is called binary, I believe, not non-binary, which is a big term these days. And remember, I was saying when I was explaining the binary to integer conversion, you only need to count the 1s. If you encounter a 0, you can just ignore it. So I'm only going to do something here if I encounter a 1 in binary. So that'll be my condition. If the value I encounter is a 1, then I'm going to do something. Of course, I'm going to get its power of 2. I wanted to say that the data structure for binary is not an array. It's a Java list, and that's why I'm using size and get and not indexing. Just wanted to make that point, because I said array before, but I realized that this is a Java list. Yes. Wonder why they're using list and not array list. Some people like to be fancy like that. All right. So if I encounter a 1 in my binary list, I'm going to be adding it to my total, but I gotta do some stuff, and I'll type it up here and then I'll talk about it. All right. So what I'm doing here is I'm getting the power of 2 for the location of the 1 in the array. And for the location of the 1 in the array, I'm getting the size of the list minus 1, which means that's going to be the very last possible index. And then I'm minusing I to get the actual location of this 1. Let's look at an example here. Let's say you got 1, 0, 1, 1, and these are at locations 0, 1, 2, 3. These would be indexes. All right, so let's look at this one. Of course, we're already looking at it, of course. So binary size on this one is going to be 4, and then you minus 1. Of course, that gives you a 3. And then let's say I is this one. I is the 2. Let's say so in this I guess a formula here, it would be, I've already done size minus 1, so then I minus I, which is 2, and that is going to equal 1. 1 is the power of 2 that I need to use to do to this binary number. So it would be 2 to the 1, which is appropriate for its place, because remember I said going from the right to the left, you have 2 to the 0, 2 to the 1, and then going to the left. Well, we've determined that from this formula you get 1, and that's the power of 2 you use. So in this particular specific index, or not index, instance, that's the right word, this particular instance, this 2 would be raised to the power of 1. So there you go. And that's a little bit about what this formula does. All right, let me clear this out, because gotta wrap this one up, homies. Almost got it. Time for an appointment. All right, let's go here. Always working, always grinding. I think all I gotta do is return the total anyway. I think I'm good here. And there is your binary to number conversion. Let's see if this sucker works. Looking good, homie. All right, all right, all right. As McConaughey would say, we are looking good. I like it. Nice and wrapped up right before I got to head and do an appointment. Wish me luck, y'all. All right, looking good. Okay, that's it. This is binary array. Actually, I was reading the method name. This is ones and zeros, a Java exercise from Code Wars. And with that, good people, I am out of here. I almost said suckers. That wouldn't have been good. All right, see ya. All right, I'm back, my peoples, representing for my peoples, and this is diagonal sum, a Python exercise from Code Wars. Let's do it. And it says create a function that receives a square matrix and calculates the sum of both diagonals, main and secondary. And it has a little definition of what a matrix is there. Realistically, for the programmer, a matrix is a two-dimensional list of numbers, and square matrix means that you've got a two-dimensional list that has the same number, or it has a number of elements in each sublist equal to the number of sublists. So a sublist, or a two-dimensional list that has 3 sublists has 3 elements. I think I got that right. Crossing up here. I'm cracking up, people. Okay. So anyway, now to what we're doing. Create a function that receives a square matrix and calculates the sum of both diagonals, main and secondary. So what we got to do here is look at the diagonals, as it says, and calculate the sum of each diagonal. So yes, in a matrix, you have 2 diagonals. You've got this one that goes left to right down. Then you have this one that goes right to left down. And I believe the main diagonal is the one that starts on the left. And a secondary, I think, is the one that starts on the right. But it really doesn't matter which is which, because you're just adding them both together. So for this exercise, it doesn't really matter. Look it up. Okay, so yeah, just get the sum of both diagonals. So you have 1 plus 5 plus 9, which is 15. And then you have 3 plus 5 plus 7, which is also 15. And I believe that'll yield you 30. There we go. Going down here, now things are all screwy. Yeah, and it says it returns 30. So yeah, first diagonal, second diagonal, add them up. So this is going to involve two-dimensional list manipulation, and I'll see what I can do in here. It's a tall task, my friends. All right, let's get in here, work it out. Brother's going to work it out. Okay, so matrix is going to be a two-dimensional list. And I've got to kind of traverse it in a certain way. First thing I'm going to do is, if my matrix, or if the two-dimensional list, if there's no rows, then I have to return 0 because there's going to be no sum. Like if you have an empty list, then it will have no sum. Don't know a better way to say it. I guess I was searching for one, but there ain't one. But that's a thing to get out the way. So I'm going to create variables for my main diagonal and my secondary diagonal. So I'm going to add them together later on. And so I'm going to diagram out my strategy a little bit. Let's say we got this. Let's write up our little square matrix. So I'm going to diagram out my strategy of looping. So I'm going to create a loop with an I iteration variable, and that I iteration variable is going to go for the rows. It's going to go down. It's going to go down from index 0 to whatever the index is of the last row, but I is going to go down. And of course, that's going to allow me to get to 2 diagonals going down. What I'm going to do also is create a J variable that's going to go across. It's going to go from left to right. And that's going to allow me to get the main diagonal, like the 1, 5, and the 9, as we go down. And I'm also going to do a K variable that's going to go right to left, so that as I go down, I can get the secondary diagonal, like the 3, the 5, and the 7, because it's going right to left. So these three variables are going to allow me to get to where I need to get. Because when you think about the diagonals, it's look at the top left. Its index combination is going to be 0, 0. Then the index combination in the middle is going to be 1, 1. And then the index combination of the bottom right is going to be 2, 2. And there should really, I guess, be commas in between these. The second numbers, these are all going to be come from the J. These are all going to be J's. And the J is going to allow it, it's going to start here at 0, then go here to 1, and then go here to 2. 0, 1, 2. And that's that. Now if we look at the other diagonal, the 3, the 5, the 7, the upper right, that index combination is going to be 0, 2. Row 0, column 2, 0, 1, 2. And then next it's going to be 1, 1. Of course, the 5's in the middle of all of it. And then we're going to have, on the last row, it's going to be 2, 0. And that is a 0. All of these second numbers are going to be K's. Whoops. They're going to come from the K variable. And the K variable is going to be counting, it's going to be counting from right to left. And really it's going to go in the negative direction. It's going to be going backwards because, normal counting is left to right. K is going to go backwards. And I'm talking index-wise. Index-wise, left to right is positive, and index-wise, right to left is negative. Yeah. So that's a little bit about the strategy. I know it is not a complete explanation, but it'll give you a picture if you can piece it together. And now I'm going to throw this into code. Whoa, I didn't mean to get rid of all of it, but you can always rewind and check it out again. I'm now going to create my variables. I is going to be for the rows, and then, rows up and down. J is going to be for the it's going to be the columns left to right, and then K, and this will be a little bit different. -1. It's going to be columns right to left. And see, K is going to start at the length of the matrix -1 because it's going to start at the end on the last index of the row and go backwards going right to left. That's what it's going to do. I'm going to do a while loop where this while loop is just going to use I to go down. While I is less than the length of the matrix, it is going to be going in the down direction. And then inside the body, I'm going to use J to go left to right, K to go right to left. First thing I'm going to do in the loop is I'm going to add to my diagonal totals, because like when you first start, we're going to be at the, you'll see how it plays out, but at the beginning of each body, I'm going to add the current index to my diagonals, and then I'm going to move the diagonals down, really, or actually increment all the variables. I can't get it straight in my head, folks. See, the secondary is going to be IK because, like I said, K is going to go right to left, backwards. And when I'm done with that, I'm going to increment I, increment J, because those are both going to be going positive down the main diagonal, and then K is going to be going backwards on that secondary diagonal. And really, once the while loop is done, you're going to add main plus secondary because that's the point of the exercise. Get the main diagonal, get the secondary diagonal, add them together, and there you go. So that would be that. And that really is it. There's no more code to do. I've done a reasonable amount of explanation. Don't know how cohesive it is, but I tried my damnedest, folks. That's all I can do. So, let's put this sucker in and run it. Or it's already in, actually. I can just run it. My goodness. Okay, now it looks good. It got the greens. All right, green light says go. That is excellent, excellent, folks. Got it good. So there is the diagonal sum. Yeah, done in Python. Yeah, 11 is for the main diagonal, or line 11 is for the main diagonal, line 12 is for the secondary diagonal, and you increment for the main diagonal row-wise, decrement for the secondary diagonal because the horizontally you're going to be going backwards through it, and you guys give it a try. Good luck. Maybe you can do it in one line. I know some people out there can, but I did it in however many lines I did. What, 16? And that's it. So that's good for me. I'm good. You're good. And I am out. See ya. Okay, 3, 2, 1, go. Here what we have is sectional array sort, a Python exercise from good old Code Wars. What's up, people? In this one, you are given an array, which is really a list in Python, to sort. But you are expected to start sorting from a specific position in the array in ascending order, and optionally, you're given the number of items to sort. Optionally. The inputs are going to be the parameters, I guess, the list to sort, the starting index for sorting, and then optional, the number of items to sort. Note this optional one. This is going to be an optional parameter, and in Python you have the capability to specify optional parameters where you will, what you'll do is the parameter is optional by you give it a default value, and if the user of the function includes the argument, then that default value is overwritten. If they don't include the argument, that value assigned is going to be the value of it. So we're going to use an optional argument in this function we create. If the number of items to sort is not provided or 0, meaning if that optional parameter is not provided or it is 0, sort the array from the starting position to the end. So yeah, there's a lot to see and notice in this exercise. So the overall point of the exercise is that you're given a starting position and optionally a length of the sorting, and you're sorting a section of this list. For instance, with this example, there's a start of 2 and then a length not specified. Length in this case, this is the optional parameter. And really, when the length is not specified, the length will be 0, which really means go from the starting point all the way to the end as per the instructions here. If it's not provided or 0, sort from the start to the end. So the starting position is 2. Let's go 0, 1, 2. So it'll be starting at this 5. And as already specified, the length is not given, so it's all the way to the end. So the point here is to sort from position 2 all the way to the end. We're going to keep the unsorted part intact. So that's the thing with this exercise. You sort from where it starts, from where it says to start until the end. The non-specified portion stays unsorted. So from 5 to the end, we're going to sort. So it's going to look like this, where this is your sorted portion, this is your unsorted portion. There you go. So when given a starting position and given no length, you just start and then sort to the end. That's how this one goes. Looking at the second example, this one you're given a start of 2, but you are given a length. So the optional parameter in this one is 5. So you're specified. So what this means is we're going to start sorting at position 2, 0, 1, 2, and then the length of the sorted list portion is going to be 5. So we'll start here, 1, 2, 3, 4, 5. So from here to here is what you sort. And notice we have a beginning and an end portion that will be not sorted. So let's look at the answer here. You got here to here. So you see this is the same section, now sorted. 1, 2, 3, 4, 5 from there. Notice the beginning and end are untouched. That's the point of this exercise. You sort the section that you're supposed to sort in the list, and then the unspecified portion remains unsorted or intact or whatever the heck you want to say about it. So let's dive into the code now and check out how to do this. Yes. I think this is an interesting one where you're not sorting the whole thing, you're sorting a piece of it, and it is interesting. All right, let's get in here, open it up, and yep. So the first thing with this is we've got to create, we are not given parameters, and part of the exercise, part of the difficulty here is to determine how to set up the parameters. Because remember I was talking about that optional parameter situation. The creator of this exercise wants to challenge you to set up your parameters the correct way. So there will be 2 definite parameters and 1 optional one. The definite parameters are going to be the list, which you can call array, as per the name of the exercise, and then the starting point. These 2 are going to be the definite or fixed parameters. There's going to be 1 optional parameter called length, which will be the length of the sorted portion to sort. And when you create an optional parameter, you have to give it a value, because therein lies the optionality, if it will. I don't think that's a word, but if you provide a value, it's going to overwrite the value that you set here, the user of it. If you don't provide a value, meaning if you don't use the parameter, it's going to have its default value. And the default value I'm going to give this one is 0, because that looking at this exercise, I kind of derived that the default is going to be 0. So you use it as well. And so as we get into this, into the body here, The key distinction I've noticed is there's a clear distinction with how you're gonna handle this thing. If the length is 0 or the length is not given, if the optional parameter is not given, you're gonna sort from where they say to start all the way to the end, and that's it. If a length is given, you're gonna sort from the start to where the length is over. And it's really kind of a fork in the road. So we're going to do an if and an else based on the length parameter, because you're going to solve this two separate ways depending on if the length parameter is provided. So if it is 0, then we're going to go all the way to the end. Well, actually, I got to do the double equals, of course. So if it is 0, I'm going to set up my sorted portion, and the sorted portion is going to be from the start to the end, and I'm going to use sorted to sort it. So my sorted portion is going to be from the parameter start, and I'm going to use a slice here from the parameter start all the way to the end of the list. This will only be my sorted portion from from the start to the end, as per, you see the slice right there. Now I've got to put my unsorted portion. In this particular context, the unsorted portion is always going to be the beginning of the list. So actually I can just return, because I'm just going to concatenate the beginning of the list to my sorted portion, and that is it. So I'm going to use a slice into the list, and I'm going to get my beginning portion, which is going to be from the beginning to where the start of the sorted portion is. I'm going to concatenate that through list concatenation to the sorted part. So there you have the beginning, which is the unsorted, and the sorted part. Those two together will comprise my returned list. I've got my pieces. So if the length is 0 or unspecified, this is how you would sort it sectionally. Now we have the else portion, and this is if the length is provided. And if you provide a length, you're going to have like a prefix and a suffix, meaning you're going to have a beginning portion that is unsorted and an ending portion that is unsorted. Optionally, I guess. But yeah, you're going to have those two portions, and you're going to have the sorted portion in the middle. So I've got to do 3 sections, really. I'm going to do the ending portion first, and I'm going to create a variable that says end, and I'm going to use this kind of formula to set it up with slicing, where the end or kind of the suffix of the sorted portion, this is going to be after the sorted portion is over, and it's going to be really, I'm going to move the marker forward from the start of the sorted portion to the end of it, get that addition there, and then I'm going to start the end there and then go to the end of the list. So may take a little time to figure out, but yeah, this is the way to do it. You start from the sorted portion, add that to the length, and the end will start there, because this addition will give me the end of the sorted portion, if you think about it. Well, even if you don't think about it, it's still going to work. But you'll understand it if you think about it. That's a good way to say it. And now I'm going to make my sorted portion, which is going to be sorted using the sorted function, of course. Array. And not that. I'm going to start at the starting position, of course, and then start plus length, of course, to give me the end of my sorted portion. Because if I'm sorting it, if the length of the sorted portion is going to be length, then the end would be start plus length. And now I'm going to do my beginning portion, but I'm going to do my beginning portion as I return, because I don't really need to create a separate line for it. So I'm going to return and concatenate all three positions together: the beginning, the sorted portion, and the end. I'm just going to return. It's like a Snoop Dogg song. Seems you haven't learnt. I'm the knick-knack paddywhack. Okay. Quoting a little hip-hop there. It seems you haven't learnt. I done returned. Okay. This is going to be my beginning portion. It's going to be from the beginning of the list to the start of the sorted portion. And then I'm going to concatenate that to my sorted part. And then I'm going to concatenate that to my end. How many times have I said concatenate in this video? And that is it, my friends. So I've got my, if the length is 0, and if the length is specified and non-zero, I've got the else. All situations are covered because if and else is binary. It's either this or this, nothing else. And, or actually you have, really a way to say it is you have if, and then you have anything else, because else is anything else. All right, I'm rambling, so let's get in here and run this joga. Joga. Alrighty, we got that. Cool. Flying colors, my friends. That is sectional array sort. You all have a good day. I am gonna have a good day as well, and you'll see me back here another time with another awesome video. I'm out. Okay, it's coding time once again, folks, and I'm back with a Code Wars exercise, and this is speed control, a Java exercise. Doing it real big with Java today, baby. All right. Description. In John's car, the GPS records every s seconds the distance traveled from an origin. Distances are measured in an arbitrary but consistent unit. For example, below is part of our record with s equals 15. I guess s is seconds. What you got here is an array of really double values in Java. And these are distances traveled from an origin, so they get bigger as you go forward in the travel. So jumping up. So what you can take away here is an increasing set of float values in an array. And the sections are, and here it's showing the getting the differences between the distances. So just difference between 0 and 0.19, 0.5, 19, 0.75, and 5. You see, these are differences. And it kind of clues you into the idea that you're going to need to get differences. But there's more to the story. We can calculate John's average hourly speed on every section, and we get this list of, or this array of doubles. Where, yeah, these are average hourly speeds based on these differences and based on some other factors that are that I'm about to get to. So we got an array of average hourly speeds. So given s and x, not e, given s and x, the task is to return an integer, the floor of the maximum average speed per hour obtained on the sections of x. If x is less than or equal to 1, return 0 since the car did not move. So yeah, there's your little qualifier. If the length of your array is less than or equal to 1, return 0 because there's no movement. There's no difference in speeds, or no, there's no difference in distance. That's the thing. No difference in distance. So we have to get the maximum average speed per hour. These are the this is a list of the average speeds per hour according to these different differences in the distances. You're still with me? Yeah, I was a little confused on this one too. These are the average hourly speeds given the differences in the distances. And then the question is, how do you get these? The objective is to get the maximum of these. You see, the maximum, and of course the maximum is 74.4, and so you return 74. But yeah, how do you get these? That's not really given, and maybe you're thinking, I've got to come up with a formula myself. Maybe I'll look it up or whatever. But actually, lower in the instructions, they give you the formula. It's down here. So here's the formula. It's 3,600 times delta distance. Now, what is delta distance? Delta distance is one of these. So each difference is going to be used as the delta distance, and then you divide by S. S is going to be given as an argument or as a parameter, or it's going to be given as an argument. It's stated as a parameter. But anyway, S is going to be given. So we've got all the pieces for this formula. Got to do 3,600 times the difference. How do you say that? The difference in distance, which is one of these, divided by S. And S is given. For instance, in this example, S is going to be 15. All right, so having said all of that, we get a list of, or an array of them, array of these differences, and then we find the maximum, which here is 74.4. We got to convert it to an integer, as is said, convert to an integer, and then return it. So that is the task, folks. Okay, I say folks this morning. Screwing up all the words. But yeah, that's what I got to do. And you'll have to do it yourself eventually. Don't copy my stuff. Don't buy my style, homie. Actually, you can buy it all you want. Just don't chew. Okay. I think I'll increase the size. Yeah, I'll increase the size a little bit. Alrighty. So I'm going to do a sort of a qualifier right off the bat just to make sure we're good. I am going to say if the length of the list, or I keep saying list because I'm doing a hell of a lot of Python stuff. If the length of the array is less than or equal to 1, we're going to return 0, because if you have an array that only has one distance in it, it didn't go anywhere. There's no difference. Right, folks? All right. I'm going to create some arrays here. I'm going to create one array. Oops, -1. This first array is going to be to hold the differences in distance. Another array is going to be used to hold the averages. And I'm using x.length -1 for the size because I see that when you do the differences and get the subtractions, the number of them is going to be one less than the total size of the array. Because yeah, if you subtract each set of values, you're going to end up with one less as a result when you do all the subtractions. Same thing with the averages, because the averages are just going to be averaged from the differences. Or actually, yeah, you're going to use each difference to get the average. So the number of averages is going to be the same as the deltas, so to speak, and that's why these are the same. So let's stop rambling and get into the loop, where I'm going to loop through this array of distances, and I'm going to get the differences and the averages. So I'm going to do a lot in this array. let's move forward here. Yeah, I'm gonna get the deltas, I think. And actually, yeah, kind of revising my earlier code, but I don't need one of these arrays, but you'll see as I get this done. This is the formula that was given at the bottom of the exercise instructions. Divided by S, that's good. Okay. Yeah, I'm not going to need this delta times because I'm not doing kind of any intermediate storage. I'm doing the difference in here, and I'm not pulling it from any kind of storage, so I don't need that array. That was from an earlier version that I did. Anyway, I'm using the formula given to get each average distance. I'm using this is the difference in distance right here, times 3600 divided by S, just like if we go here, just like this formula, that's what it is. So let me expand it back out, and we got that. And once I have a set of averages, an array of averages, we're supposed to get the maximum. Well, yeah, there's a few ways to get the maximum number out of a set of numbers or an array of numbers. I'm going to use the arrays sort method, because if you sort an array in ascending order, the last element is going to be the highest. It's a very easy way to do it. Maybe a lot of labor, but oh well. It's not manual labor. So I'm going to do sort on this array to get the max, and the max is going to be, again, the last element of that list. And I got to import Java util. I was import the whole thing. Wasteful, but it don't matter. All right, now I'm just left with the return. So I got to get the maximum out of that array of averages. Then I've got to convert it to an integer. That's the last step that it said. Get the floor of it. So if you convert from double to an integer in Java, I believe it gives you the floor. So it works. I don't believe it, I know it. I gotta have conviction, right? And that is that. Now I can just check this and see if it will go, because it looks pretty good. So let's try it out. Test. Nope, got errors. What do we got here? Let me check this out. Yeah, so it would appear the issue was that I did not have new in front of double. So let's try this again. That was not it. You look here, and yep, there's always possibility of mistakes, of course. You gotta stay humble in these situations, and that passes the test. And run it through, it's a little slow, but it passes, and that is great. So we have another successful run, and that, my friends, is speed control done in Java this time, and this is a Code Wars exercise. There's the code. That's what you got. This is me, and that is you, and I am out. All right, right, 1, 2, 3, 3, 2, 1, y'all. We settle it in with isograms, a Python exercise from Code Wars. Same routine, y'all. Okay. An isogram is a word that has no repeating letters, consecutive or non-consecutive. Implement a function that determines whether a string that contains only letters is an isogram. Assume the empty string is an isogram. Ignore letter case. I had never heard of an isogram before seeing this on Code Wars, but I guess this is what an isogram is. Okay, no repeating letters in the word. So looking at these examples, whatever this word is, it has no repeating letters. And yeah, this function that is going to be created is going to return true or false, depending on if it is an isogram or is not. Of course, if it is not an isogram, it is going to contain repeating letters. And you're going to ignore case. That's important. So ABA, it is not an isogram because it's got 2 A's in it. Moose is also not an isogram. You ignore letter case and it's got 2 O's in it. Oh, let's go O's. All right, this one should actually be pretty short and simple. Just gonna determine if the word, the string, contains any repeating letters, any duplication. That is it. That is all. So let's get in here and tackle it. So whenever I think duplication, I think about the data type of the set, because when you convert a string or a list to a set, it'll remove duplication. And I'm going to use a set in this exercise. What I'm going to do is I'm going to convert the string to a set, and then I'm going to compare the length of the set to the length of the original string. If they're the same, then it is an isogram because it would contain no repeating, no duplicates. If they are different, it means the set has gotten rid of the duplicates and they are not the same, thus the original string is not an isogram. So I'm going to convert this to a set. I'm going to convert the original string to a set, I should say. And I'm going to convert the string to lowercase first to ignore case. Then I'm going to convert it to a list, then to a set. It works easier this way. But essentially, I'm taking it through all of this to convert the string to a set, and the set will remove duplication. What I will do next is I'm going to create a Boolean expression to compare the length of the set to the length of the original string. Again, if they have the same length, it means that no duplicates were removed and it is an isogram. If they differ in length, then this is not an isogram because the set operation or the conversion to a set removed duplication. And quite handily, I can use really a one-liner to do this. I can just put the Boolean expression to compare the two lengths in my return statement, and that will be a reflection of if it is an isogram or not. So I just get my length of the set, and then the length of the original string, and see what the outcome is. I just return the outcome because, as I said, the outcome of this Boolean expression really determines if the string is an isogram or not. And this is handy shorthand that you can use in programming, where if you have a Boolean expression that returns true or false, well, actually all Boolean expressions return true or false, but if you have if you have an expression that returns true or false, and your function returns true or false, and your expression completely ties into the truth or falseness of the function, you can simply return the expression. Getting a little jumbled up there, folks. It's still early. But that passes, and go for the attempt. This passes as well. Alrighty, folks. There you are with isograms from Code Wars in Python. Keep it Pythonic, y'all. And with that, I'm good, you're good, and I am out of here. Yeah, back with a Code Wars exercise called Square Digits Sequence. Doing this one in Python, y'all. Look at the description. It says, consider a sequence of numbers, if you will. Consider a sequence of numbers in which an element is equal to the sum of square digits of the previous element. The sequence ends once an element that has already been in the sequence appears again. Given the first element A0, find the length of the sequence. So we're going to be given a number, you separate the digits, you square each digit, add them together, producing another number, and you do that process over and over again until you end up with the same number. So let's look at an example here. This one will get a little thick here. So if we begin with a 16, the outcome will be 9. And what you're supposed to do is find the length of the sequence. So eventually it's going to come back around and 16 is going to be in the sequence again. You have to find out how many numbers are going to be in the sequence until 16 comes up again. So find the length of the sequence. Let's take a look. In this example, you start with 16, then you separate the digits. 1 squared, 6 squared, add them together, 37. Then you separate the 37 digits, square them, 58. So what you're going to do is, for every turn, you're going to separate the digits, square each digit, add them together once they are squared. And then you just kind of, you keep hopping along, and then you get here with the 4. 4 squared is 16, so the 16 comes back around again. 16 is 16. The job is going to be how many elements are going to be in the sequence once the original number comes back around again. Let's just count. 1, 2, 3, 4, 5, 6. Like all the clicking? 7, 8. And then the last one is 9. So it is inclusive of the last and the first. So yeah, 9 elements in the sequence, if you see it down here. 9. So that's what we got to do. We're going to get a number. We're going to separate the digits, square each digit, add them together, and then do it again and again and again until we get the original number. All right, so I'm going to do this one in PyCharm because I want to demonstrate this example so you can see the breakdown. I think it'll be instructive. But let's go ahead and slide this over here and get started. As I begin, I'm going to create a list to store the results of every square and sum operation. That's what I'm going to do. And then this is going to be more of a temporary list where I'm going to, well, you'll see what I do, but I'm going to use this to, for each number, I'm going to use this to separate the digits, and then I'm going to, the digits of that number, then I'm going to use it to help me do the squaring of the digit and the summation. So current digits will be involved in the number by number operation of doing the separate the digits, square, sum. Used digits will be all the outcomes. And then I'm going to create a variable here, and then I'm going to do a loop. And here what I'm doing is I'm going to do a loop really according to when I need to stop. And when I need to stop is going to be once the original number comes back around again. And that's what it's going to be. So that's what I'm going to do. And I'm going to first place my original, whoops, in there. And no, I don't need that. Because of course the used digits is going to be all of the numbers that it's going to be all the numbers that are outcomes, and then I'm going to get the number of the outcomes once that original number comes back around again, so that I can solve the problem, because the problem is going to be how many numbers in a sequence are going to be used so that the original number comes back around again. Whoops. And it's greater than 0. This is going to be the breakup of the current number into its digits. Yeah, for those who don't know, this is really the algorithm to take one digit at a time and put it into a list. Where line 10, I'm doing modulo to get the number in the ones place and put it into a list. And then on line 11, I am using division to remove the ones place, so that I can get the next number. So it's removing one number at a time from a multi-digit number, so that I can have them separated, so that I can then square them and add them together. And once they are separated, I'm going to loop through the digits. And I'm going to get the sum of the squares of each digit. So I'm going to square each digit, get the sum in kernum. That's what kernum is being used for, getting the squares. And then current digits is really a temporary list, so I'm going to clear it, because its job is done. Its job is just to hold the individual digits of the number. And once I've got my sum of the squares, I can clear it out for the next turn of the loop, or the next iteration of the loop, where I can fill it up again. And then what I do here after that is I'm going to make n my current, I want to make n my new sum of the squares, because on the next iteration I'm going to use that one to separate and get the sum of the squares. So it's just now n is the next result, and it's going to keep being the next result and the next result. And then I'm going to see, of course, once n comes up again, it'll be the end of the solution. And I'll set cur_num equal to 0 to clear that out, because I'm going to reuse it. See, that was the sum of my squares. I'm going to reuse it when the loop turns back around. Yeah. And once the main while loop is over, I want to add the last result that I got to the end to make the list complete, because this loop, as it's constructed, will not add my final result. Meaning, like for the example from Code Wars, when that 16 comes back around again, on the last turn it's not added, so I go ahead and add it here, because the adding is done at the top, and on the final turn I'm going to hit this condition and then it's going to leave. So I'm doing this one-off add to the end so that I can add my 16 in that specific case back to the end. And then once that one is added, I'm going to return the length so that I can, that's the solution, because you want to see how long the sequence is, and I'm going to return the length of that sequence. All right, so now I'm going to run this thing with 16, and I'm going to first, ensure it's the right answer, and then I'm going to I'm going to modify this a bit, because I wanted to show you the actual sequence that is generated. So I'm going to use a print statement in here to show you. There's your sequence. I guess I'll use an F string on this one as well to give it a label. Okay. Gonna do a little split screen here so I can show the example along with my call here. All right, gonna run it. Okay, looking down here, look at the sequence generated: 16, 37, 58, blah, 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 blah. But notice the 16 comes back around again. And 16, let's say 1 squared plus 6 squared is 37. Then 3 squared plus 7 squared is 58, and so on. And you look over here in this sequence, all the outcomes are the same. You see? And then of course you have the 16 that comes up again. So there you go. This one's ready to run because I've only done one case, but of course I've submitted the solution before, so I know it's good. And this is the kicker. The result of the function call is 9. There are 9 numbers in the sequence, so there we go. All right, enough yammering. Let's get this thing on and delete the print. Don't need that. Get my function body on a Code Wars, my friends. Let's get into this training interface and submit this and kill it. Mark it. Oh yeah, I can't submit here like that. All right. Test it. That one looks good. Great, stupendous, fantabulous. We got it. So there, my friends, is, I think the name of this is square digit sequence. Let's see. Yeah. So that is squared digits sequence from Code Wars. My name is Dean. I'm good and you're good. And with that one, I am out. Hello, YouTube watchers. This is another installment. My name is Dean, and we're looking at digit degree, a Code Wars exercise done in Python, or it will be done in Python. So it hasn't been done yet. Although, yeah, I did do it before, but I'm going to do it now here live for you. And now that that unnecessary introduction is out the way, let's dive in. Let's define a digit degree of some positive integer as the number of times we need to replace this number with the sum of its digits until we get to a one-digit number. So we're going to be given an integer n, and we need to get the sum of its digits until it is a one-digit number. And we're going to count each time, and that will be the degree. Got that? I know you do. But let's look at examples. For n equals 5, the output is 0. Now why is it 0? Because 5 is already a one-digit number, so you don't have to go through the operation. The operation here is going to be, if you have a multi-digit number, we're going to get the sum of the digits until, over and over, until it's a one-digit number, and that will be the end of the operation. If we look at n equals 100, the output would be 1, because it only takes one summing to get it to a one-digit number, because we got 1 plus 0 plus 0, that equals 1, and that is a one-digit number. Looking at n equals 91, the output will be 2. It's going to take two operations to get it to a one-digit number. So 9, you say 9, are you right? 9 plus 1, that is a 10. And we see 10 is it is a two-digit number. So then we do 1 plus 0. I don't know why I'm saying 0 like that. And that equals 1, and there's your one-digit number. This was two operations, 1, 2. So that's why we get a 2. So you see it now, you understand it, you got it crystal clear. Clarity is power, where we're going to start with a number, and we're going to sum the digits of the number until we get it down to a one-digit number, and every time we do a summing of the digits, we're going to increase a count. That count will be the degree. And that rhymes. Got a rap verse there. Outstanding. Let's dig into the code here. Digit degree. I always say let's dig into the code, but there's no code. I actually just write the code from scratch. Yeah, hopefully y'all can see this okay. I can see it, and that definitely counts. Digress, degree. Degree is going to be an integer, of course, that will hold my count of the operations. So because we're doing something over and over again, potentially, we're going to need a loop. And the while loop is well suited for this, because in the while loop in Python, you can really customize your condition. If you want a customized Boolean expression as your condition, you need to use the while loop. There's a little basic guidance there. So because the solution will be when the number is one digit, I'm going to make that really the condition of the loop. While the number is not a single digit, we will keep looping. And putting that into code is like this, where n is going to be an integer, and you can't get the length of an integer, I guess, in a condensed format. So I'm going to turn the number into a string temporarily and get its length, which will be the number of digits. So I get the length, and while the length is not equal to 1, meaning while the number of digits is not equal to 1, I'm going to keep looping. And what I'm going to do in the loop is I'm going to do the operation of summing the digits. You sum the digits, and then you use that result to replace n with a new value. Then you loop around and do the test again. So the loop is going to be add the digits together, get the sum, loop around. Well, actually, it's add the digits to get the sum, use that result to replace the previous number, then you loop around and check if the number of digits is equal to 1. So I will do that now, and I'm going to do a lot of that in one line as per being Pythonic. Yeah. And I'll break this down soon, but I'm going to type it first. A lot going on, but yeah, you can do this kind of stuff in Python. My guideline when I teach people, when you're looking at a semi-complicated expression, is to start from the inside out. Really, what this line is going to do is it's going to separate the number into digits, convert to integer, and then sum the digits. That's an abbreviated explanation. A real solid explanation is going to be, I'm going to first convert my integer to a string, then convert that string to a list so the digits are separated. But when it's a list, the elements will be strings, so I can't do a summation of that. So then I use the map function to convert. I use the map function to convert each string, each individual numeric string, into an integer. And then I've got a list of integers, or really a map object of integers, and I will sum that object, getting my sum and then putting it into n, which will be n's new value. And then it'll loop around and check it for being one digit. So there's your breakdown, folks. And every time I do that, I'm going to increase degree by 1 because I have done an operation. So I need to record the new degree. Once this is done, I return degree because once I get out of the loop, n will be one digit, and I've done my set of operations. So it is time to go. And now it is time to run. That one passes the basic tests. And looking at here, the more comprehensive tests pass. Very good, very good. I did an amazing job on this, folks. If I did say so myself, whatever. All right, this is it. What it is a digit degree, a code wars exercise in Python. My name is, you see it on the channel, my name's Dean, and I'll do another one pretty soon. But for now, I am out. back again, back again, back again. I think I'll try to clear my throat less this time. We're looking at numbered cards, a Python exercise from Code Wars. Okay, you have a pack of 5 randomly numbered cards which range from 0 to 9. You can win if you can produce a higher 2-digit number from your cards than your opponent. Return true if your cards win that round. Let's look at the example situation here. So you each get a set of cards which syntactically is going to be a list of integers in Python. So the first set is your cards, the second set is your opponent. You can win if you produce a higher 2-digit number from your cards than your opponent. And so you look through and you see you really you retrieve the highest 2 values from the list. So here it's 6, 9, and for the opponent it's 3 and 7. And then of course the highest values are going to be, or the highest 2 digit, well, whatever the hell I'm trying to say. What it is going to be is, for the first one, 96, because of course 9 is higher than 6. And then 7, 3, 73. Of course, you're going to put the highest number in front to make the highest value. Yours is 96, theirs is 73. You win that round. And that's how it goes. You get the 2 lists, you get the highest value, the highest single values, put them together to make the highest value. And if yours is greater than theirs, you win. If not, you lose. And this function that is going to be created returns true or false. That is how it goes. That's my story, and I'm sticking to it. Looking at the examples we got here. We already went over this one, or I went over it. You watched. And this next one, yours is going to be, it'll be 54. There's your highest, and then there's going to be, of course, 98. So you don't win that one, so you get a false. Here, the highest would be 54 again. Yeah. And the highest there is going to be, looks like 54 as well. They're the same, so that's a false. Because the test is yours higher than theirs? And when they're equal, they're not higher. Or yours is not higher. Yeah. And say, yeah, here, return false if you and your opponent reach the same maximum number. So if they're equal, it's a false. So you only check for higher. If it's not higher, if yours is not higher, it's a false. All right, good little exercise here. Now I'm going to let y'all see my take on this one. Take on me, take me on. Aha, yes. I'm sure some of you older cats remember that song. Take on me. All right. So we're going to be given two lists, and we got to get the highest values from each list. And really the way to do that is to sort, or a way to do that is to sort the list. When you sort a list of numbers, it sorts in ascending order. The highest values are going to be at the end. The highest 2 values are going to be the last 2 elements in the list. So I'm going to take those last 2 elements, and those are going to be my high value, my high 2-digit number. And of course, the last element is going to be the highest one. So I'm going to put that one in front of my 2-digit number for each of these. I'm going to be able to wrap this one up really in one line, doing some Pythonic stuff. So you guys can just sit back and watch me work, and then I'll explain what is being done here. It's a lot to type, a little semi-convoluted, so I'll save the explanation till the end. Hopefully I get all my parentheticals correct. Is that right? Integer, sorted. No, it's not. Okay. And to focus for a second there. And this will be after. Do a little bit of a shortcut copy paste here and just change a little bit. Guess in the interest of time, I'm saving y'all and saving me a little bit. All right, I just want to make sure parentheses are good, matched up. Looking good. Okay, negative one, blah, blah, blah. All right, let me break this sucker down. All right, so I was saying before that to get the highest values, you got to sort. And I do it in a somewhat inefficient way, but it works for this little exercise situation. So I sort the lists, and I get index -1 and index -2. Index -1, of course, is going to be the last element, which will be the highest value. And -2 is going to be the second to last, the second highest value. So I put index -1 in front of index -2 because index -1 is going to be higher, thus yielding me a higher 2-digit number. For each of the digits, the list is going to be a list of integers. So sorted U index -1 is going to be an integer. I convert it to a string. I convert both of these to strings because I'm going to concatenate them. Like, see, if I have a string 9 and a string 6, I want to concatenate them to produce a string 96. And then I'm going to take that and convert it to an integer so that I can compare values. Of course, these start as integers. If I was going to add them together, of course, 96 is not the same as 15, which would be the addition. So the process here is going to be taking the integer, converting to string, so that I can concatenate the two, producing the correct 2-digit numeric string. Then I turn it into an integer. So that is exactly what's happening here, where I have integer, convert each to a string, then I concatenate, and then I convert it back into an integer. So that's the process. And I do the same thing for the opponent. Get the digit, convert to string, concatenate, then convert to integer. I tell people all the time, when you have a semi-complicated expression, you look from the inside out, and that's going to give you some clarity. And so I've got both of those quantities here, and what I do is I see if mine is greater than the opponent. And this is a Boolean expression. I'm saying, is mine greater than the opponent's? That Boolean expression returns true or false. Because the Boolean expression returns true or false, I can simply return it. Because the objective here is to get a true or false result. And that's it. So that's how I can do the one-liner, because It's expecting a true or false, and I'm producing a true or false with the Boolean expression. No need to do the if and else situation. So go ahead and return it, cut it, print it, and that's good. So I will test. Surprised I got all the parentheses good. That's awesome. And then I will attempt, and that one's good. So folks, here is your solution to numbered cards from, whoa, that's not it. That's the test cases. Here's your solution to numbered cards, a Python exercise done in Code Wars, in Python and whatever. All right, that's it for me, folks. And for you and for me, I'm out of here and talk to y'all later. See ya. All right, we back, bitches, and today we got array. Maybe you should have commas in here. A Code Wars exercise done in Python, or it'll be done in Python. Gotta clear the old throat there, yeah. You're gonna be given an initial 2-value array, which is really a 2-value list. You're gonna be given a 2-value list. You're gonna use this to calculate a score. If both values in the list are numbers, the score is going to be the sum of the two. If only one is a number, the score is that number. If neither is a number, return void. This is kind of like Simon Says, sort of. But you're going to get a list that is a pair of things, like XY, you're going to get a pair. And if both of them are numbers, the score is going to be the sum. If only one's a number, the score is that number. If neither is a number, return void. So you can really see with this one, you're going to do conditionals. You know, you got your ifs, if. So these are all conditional pathways. Going down a little bit further, once you have your score, you must return an array of arrays, really a list of lists. Once you have your score, you're going to return a list of lists. Each sublist will be the same as X, and the number of sublists should be equal to the score. So the score you found in the first conditional set is going to be the number of subarrays that you create, and the subarrays will be equal to the initial pair. So let's say my initial score was 3. I'm going to create 3 subarrays of XY. So the score determines the number of subarrays that you create with this one. Yeah, it's kind of a category of exercises that I would call a Simon Says, where there's really little practical about this. It's just do what it says and follow the directions, which is an important skill in programming. You're going to be given tasks that you don't really get the practicality of, and you just got to do them. And also a little bit of, well, it's always beneficial when you put keyboard to screen, as they say, or as I say. Here's an example. If your initial array list, your initial list is A3, you're going to return a 2-dimensional list with 3 instances of it, because your score here is 3, and this corresponds to the situation of if only one is a number, score that number, or the score is that number. And only one of these is a number, and that's 3, so the score is 3. So that gets you 3 sub lists. If they were both numbers, then it would be the sum of the two. And to recap the rules, if neither is a number, going to return void from the function. Like this says. And here we go. Let's dive in. As they say in a lot of programming tutorials, let's dive in. I'm wondering if I should go ahead and put the... Yeah, let's drop this in there so you guys can kind of see how things are as I... So you can see the rules as I code. I think it'll be beneficial to remember. Do you remember? A little Michael Jackson 90s action. Oh, that's not looking good. Yeah. So you can see the rules as I code, so I'm just not like coding in the dark, sorta, or like what the hell is this guy doing? So ARR is going to be a list. Really, it's going to be a pair in a list, a pair of things. And initially, I'm just going to do the conditionals. The first conditional I'm going to do is the kind of the no-go conditional, the one that says if neither is a number, return void, because you're going to leave early if that's the case. You're not going to process further. So, and in this exercise, when they say number, they really mean integer. So you don't need to check for floats, just integer. So I'll do it like this. I'll use isInstance. For each of the elements here. And what I'm doing is returning the string of void. Yeah. So isInstance returns true or false if argument 0 is an instance of argument 1, it returns true or false, or it returns true in that case. So I'm checking for it not being an instance. So if really this if statement says if neither of these is an integer, then we're going to return void. Very simple. I am going to, now that I've got this out of the way, I need to determine the score of the list because I know that there will be a score. I've eliminated the possibility of there being no score because I've eliminated the possibility of having two non-integers. So I will have a score. So I'm going to use a variable to record the score. Do you know what the score is? And there's a little placeholder. And then I'm going to do conditionals to correspond to the rest of the conditions here. So I'll do if one of these, or really if index 0 is an integer and index 1, is an integer. Really, if they are both integers, then I'm going to say that my score is equal to the sum. Actually, I can do this. This is pretty simple. Yeah, use the sum function. That's easier. So if they are both integers, then I'm just going to get the sum of the list. And if, a lot of typing here, folks. Bear with me. Guess I could just copy and paste my solution, but I feel like this is more interactive, seeing the things kind of come up from scratch, sort of. Let me know what you think. Of course, nobody really comments on these videos, so do what you do. And I see that I'm so used to typing I that, you know, I type it in brackets. When I see brackets, I put an I in there just by, it's like muscle memory. Yeah. All right. For this next LF condition, it's if one of them's, if index 0 is an integer and index 1 is, wait a minute, what am I doing? Oh yeah. If index 0 is an integer and index 1 is not an integer, then the score is going to be index 0. I'm losing myself here with this very simple logic. Okay. And then I'm going to do kind of the opposite, so, well, not the opposite, but the other side of the coin, where if index 0 is not an integer and index 1 is, then the score is going to be index 1. Yeah. So I'm sure you see what's going on here. If the first one's an integer and the second one is not, then the score is the first. If the first one is not an integer and the second one is, then the score is the second one. And I'm sure this can be simplified, but it's sometimes I do drawn out code so that you guys can see, really understand the logic. Because some of you lower level individuals, in terms of, it's not really a put down, it's more like, if you don't have that much experience and that much exposure, this code is easier to understand than, you know, I could condense it and make it uber, but I'm trying to draw people in here a little bit, have you guys understand it rather than show how amazing I am at code. I can do that on my own time, right? This is my own time. I'm doing YouTube videos for myself. Anyway, rambling is over. I've got the score now. Now I know the score. And from here, I just need to create a two-dimensional list that corresponds to the value in the score. Like if the score is 3, I need to create 3 sub-lists inside of a list. Yeah, you get that? My talking is off this morning. This is the first speaking this morning, so I tend to be a little rusty. I'm going to use list comprehension for this because this is a tailor-made list comprehension scenario. Because I'm just going to be duplicating my original array. I'm going to be duplicating my initial list a certain number of times. That is simply it, folks. Where with this list comprehension, I'm going to loop an amount of times equal to the score, and for each of those times I'm going to insert a copy of the initial array into a copy of the original list. I keep correcting myself. A copy of the original list into my list, thus creating a list of lists with each sublist equal to the value, or actually the number of sublists equal to the value of score. I think I said it right that time. Okay. And that's it. Let us run it. Now you can't see any of the code as the type is so large. But, okay. My exactness is off, so it is exclamation point. Yeah. Alrighty, folks. there's your solution to array in Code Wars in Python. Yeah. So you're good, I'm good, and really that's it for me. So with that, y'all, I am good and I am out. See ya. Okay, what up, folks? Back again with another one. This one is called String Ends With, a C++ exercise done from codewars.com. Yep, still in Code Wars, still grinding, still here. I ain't going nowhere, at least for the next few minutes while I explain this stuff. Okay. Complete the solution so that it returns true if the first argument passed in ends with the second argument, also a string. So you're going to have two strings as arguments. One string potentially longer, and then another string potentially shorter, where you're going to see if the first string ends with the second string, and you'll return true or false as a result. So we look at the first case, ABC and BC. ABC does end with BC, so you'll return true. With ABC and D, ABC does not end with D, so you'll return false. So this is really a simple ends with function where a variety of languages have ends with, like Python and maybe Java too. I actually don't know if C++ has ends with, so I'm not going to use it. I'm going to just do a custom solution, and it's going to be pretty short anyway. So yeah, if any of you know that if C++ has ends with, let me know, but I'll probably find out before you let me know anyway, so it is what it is. But yeah, that is the exercise. So let's get in here and tackle it. Into the training interface, we have our little boilerplate, or beginning of our functionality. You see that it's going to return a Boolean, and as stated, takes in a string, takes in two strings. This is going to be, str is going to be the potentially longer string that may contain the other string called ending. So, because I've already done this exercise, I know that they're going to throw you some curveballs in the case that they're going to give you some arguments where the ending portion is greater than the first argument, where ending, the length of it is going to be greater than the other string. So in that case, you're going to return false, because if one string is bigger than the other, that original string cannot, the bigger string cannot have an ending. Well, you know what I mean. I can't explain this crap correctly right now, so yeah, I'm failing at my job. But if the yeah, one take, folks, one take. If the length of the smaller one is greater than the length of the one that's supposed to be bigger, that's a way to explain it, then you just return false, because it's a no-go. Because like in the case of this whole thing, ending is supposed to be, you're supposed to see if str ends with ending. If ending is greater, the size of ending is greater than str, str cannot end with a string that is larger than it. Plain and simple. So you're going to return false in that scenario. Now that we got that rigmarole out the way, I'm going to use the C++ substring or substr function I'm going to capture a portion of str that is the same size as ending, and if the two match, then str ends with ending. If they don't match, then it doesn't. So like, I'll lay it out for you a little bit here. So we got two strings here where A, B, C, D, and D, E as my two strings. This will be str. This will be ending. It takes 1,000 clicks to write this one out. This will be str, this will be ending. So my method is I'm going to get a substring of str that's equal to the length of ending, starting where it's supposed to start. So I'm going to get a substring of str that's the same size as ending, and then I'm going to compare the two. Does DE equal DE? Of course it does, so it's going to pass. So I'm going to get the length of ending, and then I'm going to use that to create a substring that's the same size on the end of str, and then I'm going to compare them. And that'll be the true-false comparison right there. You're getting a substring of equal size from the end of str, and if it matches, once you get that, if it matches ending, then str ends with ending. I know you follow that. I know it, I feel it, I feel it. The brains are sparking out there. To the two individuals who are watching. Okay, I'm going to create a string here where I'm going to create that substring that's going to be the end of str to then compare to ending. Using the substring function, of course it's str here. So I'm going to use the two argument version of substring, where the first argument is going to be where my substring is going to begin. The second argument is going to be how long it is. See, this is how it goes. It goes begin and how long. That's how substring works in C++, at least this version of it, this overload of it, as it were. So I'm going to begin here, where I'm going to begin by the length of the string minus ending length, where let's think of the string length or str length as going all the way to the end of the string. And then when you minus ending length, you go backwards a certain amount. Yeah, I should have just left my stuff up here. A, B, C, D, E. Let's say this is our string. str length is going to get you to the end of it. And let's say ending length is 2. You'll count back 2. It'll be 1, 2, and it'll get you here. So this will be your starting point of your substring. So the minus really is a way to count backwards once you get to the end. You get to the end with str length, and then ending length is going to take you back as many times as you need to go. 1, 2. There we go. And then how long, like I said, it's going to be the length, or maybe I didn't say that, but I am saying it now. It's going to be the length of ending, because you want to capture a substring that is the length of ending at the end of your longer string. End match is going to hold that substring. And what I do there, or after this, is I've got a substring that's equal to the length of the other string that I'm checking on. So I'm just going to compare the two. because end matches my substring of str. I'm going to compare it to ending, and if they're the same, it's going to return true. If they're not the same, it's going to return false. This is a shorthand you can use with a Boolean expression. Instead of using if and else, I can just return the outcome because my function returns a Boolean. Let's get this on the running. Let's go. Aha, error. Yep, missing it. Semicolon. Let's go. Whoops. Guess I did the attempt before the test, but dude, it passes. So there you go. I think I always say there you go, but this one is string ends with C++, y'all. Codewars.com. Still grinding, still here. You keep grinding as well. And I'll see you on the flip side. But for now, I'm good, you're good, and I am out. Hey, what up, folks? And today, right now, as we speak, we're going to check out numbers to letters, a Java exercise done in Python. That is not correct. That's funny. I'm so programmed. No, it is a Code Wars exercise done in Java, not a Java exercise done in Python. That is hilarious. It's almost like an outtake, but I'm going to keep going because it's funny. All right, numbers to letters. It is a Java exercise from Code Wars. Let's get it. Given an array of numbers in string format, you must return a string. The numbers correspond to the letters of the alphabet in reverse order. A is 26, Z is 1. So backwards numerical placement, etc. You should also account for exclamation, question mark, and a space that are represented by 27, 28, and 29 respectively. All inputs are going to be valid. So with this one, you're going to get an array of individual strings, and you're going to convert these individual numeric strings to letters going through a process. Like, let's throw out some here. Like if you have a string of 25 and 3 and 12, this would be an example of what you would get. These are going to be strings incoming. So the numbers correspond to the letters of the alphabet in reverse order. So normally, a 25 would be the 25th letter of the alphabet would be Z, but it's in reverse order. So you would take 25 going in reverse, and really the formula is you take your input number and subtract 26 from it, get the absolute value of that, and that's really where you need to be in the set of alphabetic letters. What I mean here is, like with 25, if you do 25 minus 26, of course you get a -1. You get the absolute value of that, and that's 1. So it's index 1. That's going to be a B, because if you have, let's say, the set of A, B, C, D, blah, 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 on and on, A is index 0, B is index 1, C is index 2, and so on, if you're looking at the alphabet in order. So a 25 would convert to a B via this formula. 25 minus 26 equals -1, and the absolute value is going to be your answer, which is 1 here. And you can use this this method, this formula, to convert all of these. Yeah. So that's what we'll use. So I will erase this and dive into the code. And I think as I dive in here, I'm going to take some of these test cases because it may not be that clear, like what the heck is going on here. So grab a couple of these just to give you a visual of the conversion that's going to take place. Just put these like up there so you can see what the haps be. All right, let's expand this out, and I'm lost over here. I'm scrolled over. All right, how do I? Oh, okay, it's good. It's good. It's good. Comment these out. What you see up here, want to sort of highlight this. You look up here. These are examples of the input strings where you're going to get an array of numeric strings, and then you convert it to a string using the format that I showed you, where let's look at 24. In this case, the 24, going to the formula that I was talking about, you do the input number minus 26. So 24 minus 26. That's going to give you a -2. Take the absolute value of that, which is going to be 2, and then you find the index of 2 in the alphabet. If I didn't say that before, it's what I meant. Where you look at your alphabet, A, B, C, D, 0, 1, 2. So that is a C, right? 2 is C. That's why C is the first letter there. There's your conversion scenario. So we got to throw that puppy into code. Yeah. And that's what we're going to do. Of course, these are going to be numeric strings, of course. So you got to convert the string to an integer, then do the subtraction, then get the absolute value, then look it up in the alphabet index-wise. You can also do this by converting to ASCII, but we're not going to go that far. We're going to look up the index in the alphabet rather than doing the ASCII conversion type of deal. Maybe you may incur a few more instructions doing the ASCII, and I just ain't dealing with it right now. So you guys can handle that. Show me what you got. I'm going on this route. I'm going to stay with this as KRS-One says. So really the first thing I'm going to do, really I already did the first thing. The first thing I'm going to do in code is to create the alphabet as a string. Because I'm going to be the outcome of my little formula is really going to be an index that I'm going to use to look up the character in the alphabet. Got free-flowing madness here, folks. Always the throat clearing in the morning. Actually, I'm just going to copy it. Let's speed this sucker up a little bit. Do the jump cut, right? There's going to be my alphabet, and it's also said that you have to handle exclamation, question mark, and a space. So I'll put those at the end, and I'm going to do a coding consideration to handle these last 3 at the end. But for the rest, the alphabet characters are in the right spots, alphabetically. Okay. And I'm going to create a string to hold my converted situation. This is almost like an encryption type of thing, or an unencryption. That's the vibe I get with this particular exercise. Next, I'm going to loop through the array of strings, which is this. I'm going to loop through it, and I'm going to do a conversion on each numeric string. We are using the length property of arrays. Remember, when you're talking about Java, you got the length of a string and the length of an array. Length of an array is a property. Length of a string is a method. So if you're going to get the length of a string, you're going to use parentheses. The length of an array, no parentheses. That's a thing to remember when you're dealing with basic Java stuff. Foundations, my people, foundations. All right. Somebody count how many times I say all right in these videos. It's like thousands. You do an all right drinking game. Probably not going to be drinking when watching these videos, though. All right. There it is. Once again, all right. It's a tick. I'm going to do a conditional in the body here where I'm going to say if the value of the numeric string is less than 27, I'm going to do conversion a certain way. If it is greater than or equal to 27, I'm going to do it a different way, where I'm going to handle the letters one way, and then I'll handle the other characters another way. So I'm going to differentiate via a condition. I'm going to say this is the conversion of the numeric string to an actual integer. And I'm going to say if that string converted to an integer, if its value is less than 27, I'm going to handle the conversion a certain way. I'm going to copy and paste here to reduce some typing. There's my conversion formula in code that I was showing you before in drawing, where really you look from the inside out, like I've said before with these, where it's going to be, first of all, what is index? Well, I am getting one of the numeric strings, like one of these. That's what ARR index I is. Then I'm converting it to an integer. So the 24 becomes an actual integer, not a string. And then once I do the conversion, I'm subtracting 26 to get it to its reversed alphabet index. And in this particular case, it would be a -2. I'm getting the absolute value of that -2, converting it to 2, and then, as a final step, I'm looking up that 2 in the alphabet, where charat is really indexing a character in the string. In this specific case, I'm indexing character at index 2, 0, 1, 2. That's going to be the C. So there's an example of what this syntax means. And there we go. That's how I'm going to handle all the letters. Now, with an else, I'm going to handle all those 3 other characters, not all of them. It's not that many. All right, on this one, yeah, I'm getting the index, or I'm getting the numeric string, converting it to an integer. Then I'm going -1 because that's going to be the correct index. So let's look at an example where Z is index 25 in this array. Let's look at the exclamation. Exclamation is 26, index 26. But the instructions say that the exclamation point will be 27 when you see it as a numeric string. It's going to be 27. Question mark 28 space 29. So looking at the particular case of the exclamation point, it's going to come in as a numeric string of 27. I'm going to convert that to an integer, -20. Actually, I'm down here, screwing myself up. I'm going to convert it to an integer and do a -1 to make it 26. And then when I look it up in the string, it's the right one because it's 26. So that -1 is going to sort of offset it to the correct index in my crafted alpha string. Good, good. I know you're good. And that's all, folks, as Porky Pig would say. So, return my converted. We pretty much out. That's going to do the conversion, and didn't really bring up the fact that for each character I get, I'm concatenating it to my new converted string, and then I return that string. Returned. I've returned. You haven't learnt. It seems you haven't learnt. That works. And that works. Seems like I have learned. So, this is numbers to letters. A Java exercise, not a Java exercise done in Python, a Java exercise done on the website codewars.com. That's it for me. I'm out of here, and you're out of here too. See you on the next video. Catch y'all soon, very soon in fact. See y'all later. Welcome back, y'all. Today, right now, we're looking at even or odd, which is greater, a Python exercise from Code Wars. Yes, we're back in here. I told you that we will not, or at least I will not stop. Can't speak for you. I ain't stopping. Okay. Given a string of digits, confirm whether the sum of all the individual even digits are greater than the sum of all the individual, misspelled, odd digits. Always a string of numbers will be given. If the sum of even numbers is greater than the odd numbers, return. You see what you return, that string. If the sum of odd numbers is greater than the sum of even numbers, return this other string. If the total of even and odds are identical, return this other one. So you can probably guess this is going to break down into a simple if, elif, else kind of deal. Some combination of those. Conditional. So you're given a string of digits, and looking at the test cases, the string of digits is going to be like this. It's going to be a string of numbers. String is important. So you're not getting an integer where you're not given a list of integers, you're given a string of numeric you're given a numeric string of digits, I guess is a way to say it. So conversion is going to be a part of this as well. And that's enough for the explanation. Let's get in here and check it out. What are you talking about? I want to look first down at the test cases so you can see what I mean. Yeah, see, this is what you're given. You're given a string of digits, and you have to total up the evens and the odds and see which sum is greater. So in the case of the third one, you have 2 ones, and then you have the number 2. The odds, the sum is going to be 2 because it's 1 plus 1. And then the sum of the evens will be 2 because there's only 1 2. So it's 2 and 2. Of course, 2 equals 2. Even and odd are the same. So that's how it's going to work. That is straight. Let's get in there and crush this code, my friends. The initial job is going to be getting a sum of the evens and then getting a sum of the odds from this numeric string. And really I'm gonna loop through and get a sum of the evens, loop through and get a sum of the odds, where I can condense this operation definitely, where I can just do a list comprehension kind of thing, loop through, get the sums of the evens and the odds, and that's it. But yeah, get a sum of the evens and the odds, and then I'll compare them later. Yeah, I was kind of floating there for a minute. All right, so I'll do the evens first, and having said that, or what I said before, I can condense this operation. So watch me work here. All right, what I am doing here is focus on the inside of the parentheses first. I'm using list comprehension to, I'm looping through the string, getting a character at a time, and if that character converted to an integer, modulo 2 equals 0, this is a test for evenness. So if that character converted to an integer modulo 2 equals 0, it is even. And if it is even, I'm going to place it into my even list. And inside the parentheses, I will produce a list of even numbers. That's what the inside the parentheses code is going to do. Once I've got my list of even numbers, they're going to be fed to the sum function, which will get a sum of that list, thus giving me the sum of my even numbers. And now I'm going to do a similar thing for the odds. Change that slightly. Now I've got my odds. Now I've got a sum of the odds. Then I can simply do my comparisons. Even Steven. Can I have it else? return it there is the same. That is pretty much it. Once I've gotten the sums, I'm doing the comparisons via if, elif, and else. Pretty straightforward there. So I'm going to take this and run with it. Run with it. No syntax problems. No problems at all. No static at all. That's good, folks. There's your solution to this exercise. Even or odd, which is greater. Python Code Wars. That's it. Good morning, good afternoon, good night. That's all for me, folks. With that, I'm out. All right, 3, 2, 1, go. Right now, I'm looking at running out of space, a Python exercise from good old Code Wars. Kevin is noticing his space run out. I guess that means he's running out of space. Write a function that removes the spaces from the values and returns a list showing the space decreasing. For example, running this function on the list I have no space would produce this. All right, folks, so regardless of what the explanation says, and it's not a good one, what it is you're given a list, basically a list of strings, usually a list of words, and what you must produce is a progressively larger string that takes on more of the elements of the original list. For instance, in the first element, you're simply going to have the first string. In the second element, you're going to have a combination of the first and second strings. Third element, combination of the first 3 strings. Fourth element, combination of all 4. So the number of elements you put in, the number of elements from the source list that you put into the new list will grow for each next element. So the string element is growing, and really you're tacking on more strings from the original each time. Interesting concepts, but so they're here talking about it in the context of running out of space. I don't really get that, but what I said holds. So let's get this one together. Let's get in here and do some training. Time to train. Check out these test cases real quick just to give you more of an idea of what I'm talking about. You see Kevin has no space, and you see here as you go through these just to let you all know, the solutions are here on the right side. These are on the left side of the inputs, solutions on the right. So with the input, Kevin has no space, you see first turn or first element Kevin, then Kevin has no space. So you're getting progressively more of the words per each element as you go forward. So we got to build that, and I'm going to show you how. Follow me. I'll show you how. Because we are creating a new list, I'm going to create a new list, and then I'm going to loop through the original array. And I'm going to use this temp variable to build my string, because I'm going to create a second nested loop, and in that loop I'm going to build my progressively larger set of elements that I'm going to tack on to each element in the new list. Nope. What I'm doing in this nested loop is I'm going to start one past I'm going to start one past my current I, and that's going to allow me to build a progressively larger portion of the string, because I'm going to go zero to I, and of course I is going to increase as this outer loop increases. It's going to allow me to build a larger set of elements for each element of my new string. And for each one, I'm going to append. I'm going to append that new string, or that, I guess you could say, the growing string. I'm going to append that to new list every time. And then I'm going to, got to return new list eventually. A lot of spacing here that I think I put in myself. Yeah, and that is pretty much it. Again, in the nested loop, let's actually take this through, use a little example. I'm going to grab one of the test cases to explain this thing a little further. So I feel like some of you out there may not be getting it completely. Back in here, drop that. Test case in there. Let's look at this example where all right, let's say here, of course, we start at the beginning, and let's say source on the left, destination on the right. Let's say we start in our loop with I equals 0 and I is Kevin, and we get in here to the inner loop. It goes J is going to go 0 to I plus 1. I plus 1 at the beginning is simply 1. So this loop will loop just 0, because of course the end is not inclusive. So I'm just going to get Kevin on the first turn, just going 0. On the next turn, I is going to be 1, and then I plus 1 is 2. So this loop is going to go 0 and 1. 0 and 1 giving me Kevin and has, which ends up here. On the next turn, I is going to be 2. Actually, wait a minute. No. Yeah, I is going to be 0, 1, 2. I is going to be 2. I plus 1 is going to be 3. So this inner loop is going to go, it's going to go 0 to 2, giving me Kevin has no. 0, 1, 2. Kevin has no. And then we have Kevin has no. So there's a little run through of how it ends up working with this inner loop. But this, folks, is done. So let's run it. Oh, maybe not. Let's see here. Kevin has no space. Yeah, I am missing something important. Importante. The looping is right, but this is wrong. Line 10, where it's not, I need to concatenate to accumulate instead of being equals. That's a typo there. So let's get in here. Pass, pass. Great, great, great. All right, home slices. Whoops. This is running out of space. From Code Wars, Python. Hey there, what up, what up, what up again? This is, well, yeah, you know my name's Dean, but I usually don't announce myself. But anyway, here we are with reverse sublists of even numbers. Python exercise from Code Wars. Yep, this is not Tuesday morning slow jams. This is a code breakdown, my friends, even though my voice may sound like that. Ain't no slow jams coming. All right, it's a hot jam. Write a function, revSub, which reverses all sublists where consecutive elements are even. Note that odd numbers should remain where they are. Example, you got a list 1, 2, 4, 5, 9. As input, we should get 1, 4, 2, 5, 9. Because what happened here is that consecutive even elements got reversed. 2 and 4, and that's really it actually. That's 2 and 4 are the consecutive even elements. So, simple as that. You take in a list of integers. For any set of consecutive even numbers in the list, you reverse them, you leave everything else intact. So there's a little bit of challenge here. That's why we're here, right? Code Wars, challenge. All right, a few other examples. Empty, empty. If you only have evens, you reverse the list. And we have 2, 4, 3. Reverse the 4 and a 2. And, well, this one's similar to the, actually no it isn't. It's, you have 2 pockets of evens. And they get, that's a little too long, and they got reversed. The 4 and the 2. The 2 and the 10. They are reversals of the previous. Okay, so we got to take in a list, reverse only the consecutive evens, and return the list. Tall task, but I'm gonna blow through it, folks. You'll be surprised with the speed at which I decimate this mother. Okay. No, I'm not feeling myself. I'm just being silly. All right. I'm going to do a while loop for my initial loop. I just decided to do that. So, of course, going to manually set the iteration variable to 0 to begin. This will be a multi-loop situation because I'm going to like go in and then, well, I'm not going to pre-explain. I'm off a little bit today, folks. Watch me work. So I loop through the array of integers just one by one, and I'm going to create a variable named sublist. This is going to hold the consecutive set of evens that I find. So really what I'm going to do is, once I find an even number, I'm going to create a sublist of all the even consecutive numbers that I find, reverse them, and then insert them into the list where the even number started. That is going to be the process here. So as I loop, I'm going to create an if statement that says, if the current element is even, I'm going to do something. So it's going to start like that. if this element that I'm on is even, and this is the classic test for even, if the number modulo 2 equals 0, it is even. So if I find an even number, what I want to do is I want to see if there are other even numbers in the row. So like, say I find the number 2. I want to see if the number next to it and next to it and next to it is even. And if I have consecutive even numbers, I've got a sub-range of even numbers that I'm going to reverse. So once I find an even number, I'm going to create a variable j and set it to where I am now in the list, the index that I'm on. I'm going to set it to that, and then I'm going to do a sub loop or a nested loop to loop as long as the current element is even. So I'm going to find all consecutive evens by doing this sub loop. I do have to do boundary checking, of course, because I don't want to. Trying to talk too fast. I want to make sure that I don't hit the end of my list while I'm looping. That's kind of an obvious thing. You don't want to hit the end of the list, so I'm going to check to make sure that I'm not at the end and that the current element is even. Notice I'm using j to index because I'm in a j loop where j is going to do the counting forward at this point while I have even numbers consecutively. And while I have even numbers consecutively, I'm going to add them to my sublist. Add that. And then I'm going to increase j by 1, because of course in a while loop you have to manually increment, decrement, or whatever you're going to do. So I increase j by 1. Once this loop is over, it means that either I'm at the end of the list or the current element is not even, meaning that I've gone back to odd and now it's time to get out of this thing. So if I'm no longer on an even number, it means I'm at the end of my odd sub. Sorry. Let me try that again. If I'm here, it means that my set of consecutive even numbers is over and my sublist is as it's full as it's going to get. I'm going to reverse the sublist, and then I'm going to insert the sublist back into the original list. Because what's happening here is I reversed my even numbers, and I'm going to put them back into the original list in reverse order, now that I've reversed them. You following me with that? Okay. Having trouble following myself. All right, so I reverse the sublist because now that the sublist is done, I've gotten all my even numbers that I have for now. I'm back to odds. So I've got my even numbers, reverse the list, and then I'm going to insert it. This is an interesting part where I'm going to create a slice of the original list. I'm going to make it equal to sublist. This is really what this is doing. This is taking the sublist of even numbers that is reversed, and I am inserting it into the original list using this slice. Not everybody, well, maybe some beginners don't know that you can do this. You can use a slice to replace a portion of a list, not just, of course, you can replace with an explicit index, like the thing at index 3 is now equal to x, but you can actually do this with slicing as well. This may have been the exercise where I learned this. I did this exercise a long time ago, but this may have been where I figured it out. I don't recall. But anyway, good principle to know, the fact that you can do this. once I've inserted my sub list into the original, this is an important thing. I'm going to make my original index variable jump to where I am now by making I equal to j. Yeah, this is a jump because if you recall when we started, I is up here doing its thing and j is set to I here. Well, in this loop, j is going to move forward to cover the next set of, or to go through all the even consecutive numbers. So j potentially is further along than I, and given that it's further along and I've already covered and handled the even numbers in the sequence, I can move I to j because I no longer need to process the numbers between I and j. That is already done. So I need to move I forward so that on the next turn of I am not processing the numbers over again that I've already processed. I've already processed the even numbers, put them back into the list, so I don't need to do it again. I need to jump. Might as well jump for you Van Halen fans out there. Alrighty. Wonder what David Lee Roth is doing these days. Interesting dude. Okay, so I need to increment I as part of the outer while loop. This is just normal stuff. It's got to go forward. I guess this is all normal stuff, right? Nothing crazy going on here. And this is it, folks. I'm done. So returning the array, or sorry, the list, once all of the reversals are done. And notice, I'm not doing anything to any other portion of the list other than the even numbers. So thanks for making it through this this harrowing explanation, but I think I said everything I wanted to say. And if I didn't, it doesn't matter because I'm not doing another take. So let's run it. I'm only doing another take if I say something crazy in the next few seconds here. Let's attempt. That's good. It's all good, baby. All right. So this one is reverse sublist of even numbers, code words exercise, Python. We got it. It says it's great, like Tony the Tiger. That's it for me, folks. And I am out. Alright, what up? Today looking at colats. I love the name colats. Python code wars. Let's get it. Looking down here, the colat sequence, starting with a positive integer n, is found by repeatedly applying the following function to n until n equals 1. And yeah, you got that function notation for you math heads out there. So the colat sequence is, if n is even, you do n divided by 2. If n is odd, you do 3 times n plus 1. So it depends on the input. So really you have like this conditional function where if n is even, you do n divided by 2. If n is odd, you do 3n plus 1. And the point here is to repeatedly apply it until n equals 1. So really, whatever number you plug in here, you're going to do this thing, this colat sequence or function over and over again until n equals 1. And that is the task at hand here. And that is it. Well, not completely it, because you got to return it in a certain format. But that's the sequence. And then getting further down here, create a function called colats that returns the colat sequence string starting with a positive integer argument passed into the function in the following form. blah, blah, blah. Let's actually just fast forward down here. Take a look. Given an input of 4, you're going to return this. Given an input of 3, going to return this one, where really it is you're showing the application of the colat's function step by step. So for instance, 4, 4 of course is an even number. So when you have an even in the colats, you divide it by 2. And that of course is going to give you a 2. That's the next number in the sequence. So then a 2 is also even. You divide it by 1. And that gives you a 1. So then we do it until n equals 1. So we've arrived at our answer. So yes, the point here is to show all the steps of your colat sequence. Same thing happening down here where we have a 3. A 3 is an odd number, of course. So you do 3 times 3 plus 1. 3 times 3 is 9. 9 plus 1 is 10. So you get 10. There's where the next number in the sequence comes in. And you go really down the chain, and for each one you print the number and an arrow to show really each output each output of the function as you move through your colat's sequence. And that's what it is, folks. So on we go. Ale oxen free, as they say. No clue what that means. Okay, let's dig in here. So with this input, if it equals 1, I'm just going to return a 1 because you're supposed to return a string of all the steps. Well, if there's only if there's no steps to endeavor upon, you just return the single number, because we're supposed to do this until it equals 1. If it already equals 1, we just return. Let's make it that. So initially, I'm going to put my incoming in. I'm basically going to start the string to kind of set the stage for the next number in the sequence, because I'm supposed to create a string consisting of each number in the sequence. I've already got the first number in the sequence via n, so I'm going to plug that in to start my string. And of course there's going to be another number in the sequence because we know that n is not 1 because we've already eliminated 1 via the conditional. So then I'm going to create a while loop to loop while n is not 1. Once n is 1, I'm going to exit the loop. But while n is 1, I'm going to do the colat's function on n. And yeah, this is going to be the main driver, where I'm going to perform the colat's function on n until it equals 1. And whatever n comes in as, I'm going to check if it's even or odd. Even, you do one thing, odd, you do another. And then I assign the new value to n, and then I loop over again, having the new value of n go through the process until it equals 1. So I have to check for even and odd, because that's the condition of the sequence. So if n, that's not right, if n modulo 2 equals 0, it's even. And if it is even, the directive is to divide by 2. So I'm going to use Python's double division operator, because the double division does, I think they call it floor division. I call it integer division, where The result is going to be an integer that I believe is rounded down. But the key point here is that I want an integer result. I don't want a fractional result. So that's why I'm doing that one. And then we have an else for the odds, of course. And for the odds, it's going to be that 3n plus 1. And what I will do also is add to my return string, because once one of these conditionals is pursued, I'm going to have my next in, so I'm going to place that next in my return string to basically make another link in the chain. Actually, I can just copy this. This is same-ish. Yeah. And I'm almost done, because that while loop, when the while loop is done, I will have all my numbers in the string of the sequence, because 1 is the ending situation. One last thing, because of the way I'm putting the string together, there is going to be an arrow at the end of the output, because I'm indiscriminately adding an arrow to every single number that I add. There's going to be an arrow at the end next to the 1, so I've got to remove that arrow, and I'm going to do that as I return. So I'm just going to return the return string, and I'm going to strip it. As in Python, the strip function allows you to strip any character from the beginning or the end, or really any set of characters. So it's kind of a duct tape solution, but I'm gonna strip the extra arrow off the end. And yeah, I know there's a more efficient way to do this. Of course, I'm writing something and then removing it, but this is what I'm doing right now, folks. I'm gonna go with this one. But if you got the better solution, throw it in the chat and have everybody look at that, because I'm all about discussion. So, but this is not the best way to do it, but can't think of another way right now, so I'm going to leave it as is. As I say all the time, let's run this sucker, or this mother. How about that? Alrighty. I got a situation here. Looks like I might have a typo. Let's check it out. If n equals 1, return 1. I think I did this yesterday or a day before or something like that. I forgot to do the plus equals and put an equal there, so yeah, it kind of jacked it up. I believe that's what it is. Looks like it. Let's go, folks. We got that collats. I got that collats, homie. So yeah, this one is done. Solution good, code good, and you're good, and I'm good. So with that, folks, that's all. And I am out. See you later. Okay, let's go. Looking at Driving School Series 1, a Python exercise from Code Wars. Still in Code Wars. Every month, a random number of students take the driving test at Fast and Furious Driving School. To pass the test, a student cannot accumulate more than 18 demerit points. At the end of the month, the school wants to calculate the average demerit points accumulated by only the students who have passed, rounded to the nearest integer. Write a function that's going to allow them to do so. If no student passed the test in that month, return no pass scores registered. And let's look at the example. You get an array or a list of integers, and it says that want to get an average of only the ones who passed. So to pass, you cannot accumulate more than 18. So that means 18 or less will be accepted. So you get an average of the 18 or less values from the list. Here we have 18 and a bunch of 10s. The 20s don't count because they did not pass. So getting an average of the 3 10s and 1 18, you get a 12. And it says rounded to the nearest integer, because when you do the division, a lot of times you're going to get a float or a fractional result. So you round that to the nearest integer, either up or down, and there is the solution. So there's a backstory to this, but it breaks down very simply in that you get a list of integers. You get the average of the values 18 or less, and that's it. And there's another condition that says if there's no passing, you return a string of no pass scores registered. And there you go, folks. All that's left now is to do the code. Let's get in here and do that code. Hit up the training interface. This one will break down rather simply, where I'm going to use list comprehension to create. I'm going to create a separate list of only the ones who passed. So I'm going to do a filtering via list comprehension. And what you see here is using list comprehension to filter the list. If I encounter a value that's less than or equal to 18, I'm going to put it in the list. Otherwise, I'm going to ignore it. So this is going to populate this list called passed with values 18 or less, so that I can then get an average of those values. And if you don't know what list comprehension is a Python construct that allows you to create and populate a list on a single line using a for loop. I've kind of memorized that definition, like a lot of things. All right. And so I can return here, because I'm going to do the rest of the stuff on a single line, being Pythonic here, of course. So watch how it goes. And of course I will explain after I've got this all typed out, but it is easier to do so once I've got it all typed. All right, and I think, yeah, I'm missing an if. That's pretty important. Da-da-da. Almost said pissed. No, it's passed. Okay. All right. it looks okay to me. We'll see what it does when I run the thing through. But here's what I'm doing. This code right here is getting, well, actually, let's go general here. What I'm doing here is I'm using the ternary operation, and it's a conditional return, really. I'm returning one thing if the condition is true. I'm returning another thing if the condition is false. So my condition here, let me space this out, is if the length of the list of the passing scores is greater than 0, I'm going to execute this portion, this round. Well, this is really getting the average right here. Because what I'm doing is I'm getting the sum of the list divided by the length of the list, getting an average, and then I am rounding it using the round function. So that's getting the mean. So if the number of items in the list is greater than 0, I'm going to get, or actually return, the average after I get it. And then I have an else here that says, really, if the length of the list is 0, then there's no passing scores, and I'm going to return that. So I have a conditional return via the ternary operator. I was going to explain it again, but I don't think I need to. This is a video. You guys can re-watch it. So I have a tendency to repeat myself. Okay, so I got my return statement there, and I will go ahead and run it. And looks like I have a typo in my stuff here, missing a period. So I'll run this again. There we go with that. And there we go with that. Now I have a passing score for my function that calculates the number or the average of the passing scores. This is Driving School Series 1 from Code Wars. There's your code, and there you go. And with that, I am out.